Hey guys, a very good morning, a very cool morning to all of you, and this is Rakesh Alreja now live, okay, for something that you are all waiting for. I know a lot of students already waiting for the session. All right, so guys, yeah, you had to wait for 5-7 minutes, but I think that's going to be worth a wait, okay, because now, okay, 10, okay. No problem, fast track, you can go back. You are most welcome to go back. I never mind that. Right. So that's what, okay. Right, very good morning everyone. Come on everybody, keep joining and quickly update your friends that the session is due live now. All right. All right, come on everybody. Yes, I know you had been waiting, but now we are live, and quickly update all your friends, those who were also waiting, that the session is now live and they can start, they can join immediately. Very good morning everyone. All a very good morning to all of you. All right. Okay. All right. So I think, okay. Let me make some things clear to you. There are some things whose answer even I don't know. Yes. So probably there are some answers which I don't know. What are the answers? I don't know. Let me make it very clear for you. Number one, how long is going to be the session? Okay, I don't know, because I really don't know, because till what length the topics are covered. Of course, I'm going to cover up all of your maximum topics, and we are going to cover it in two different parts. Guys, part 2 is also going to come up tomorrow. Today is the part number 1, of course. Today is your part number 1, of course. So we'll cover some topics tomorrow also. But today also I'll have a target to go as much as possible. Okay? You should be ready for it. Okay? Now, there are some topics in mathematics which are, not there in all branches. So I will keep telling you which topic is there in every branch. But first I will start. With the common topics, of course. Okay. So the first answer that I don't know right now is how long the session is going to be. But at least till evening. Okay. Second answer I don't know is what is going to be the sequence of chapters, because I have actually put up everything today. Let's see, based on how much time is spending, sometimes I may need to go to another topic based on, मान लो break करना है तो कोई छोटा topic ले लिया या something like that. Okay, so really, to be honest, I don't know, okay, what the sequence of chapters is going to be today. Okay, ठीक है. Chalo, great, Treyo, that you enjoyed digital electronics, and I wish that you're going to enjoy this as well. I think you're going to enjoy this as well. So let's start. And the start is like the attendance. All of you mark your attendance by hitting the like button. Show your motivation early in the morning. At least here it's a cool morning, right? How many of you are having a cool morning? I mean, you may be at different parts of the country. Of course, I know it's not that cold everywhere, but at least in Delhi, it's quite cold this time. That's what I feel. So how many of you are feeling the cool morning and still ready in every situation, whether it is cool or hot, okay, to prepare for the best? Okay, with that motivation, chalo, quickly like, that is your attendance. Hit your attendance so that we start. Yeah. Okay, so time to start with your attendance, I believe. करेंगे. Numerical methods भी cover करेंगे. Okay. Only thing you have to ensure is you are ready with the same energy, okay, for the entire day, and not only one day, for the entire 2 days. If you are ready with the same energy, we'll try to cover different chapters as well, including numerical methods. I have it. Numerical methods is also there. Okay, in this particular PPT. Chalo. All right. Okay. So yeah, some of you are enjoying cool morning. Some of you are even in the hot morning. Good. Chalo, whatever the situation is, GATE aspirants, okay, are always ready. Concepts, problems, everything is going to be there. Chal. चलते हैं. All right. So yesterday night, actually, to be very honest, yesterday entire night, till late night, I was busy preparing the entire content because it's 2 days, complete full day. So a lot of content is there. Okay. So to be honest, I could not share the EM electromagnetic PDFs because of that. Okay. Electromagnetic PDFs I could not share because of that. I whole time spent on this and then I went to the bed directly so that I come up with the fresh energy live in front of you. But I'll share it. Don't worry. EM PFD PDFs I'll share with you. Okay. So this is a regular introduction about me. Okay, so guys, whatever we discuss today, whatever we are gonna discuss today, okay, whatever it is for all branches, the session today, okay, is applicable, helpful, pretty much helpful for all branches. Okay, okay. So whatever we discuss today, guys, okay, and today and tomorrow, okay, I'm going to share the PDF of it. Okay, the PDF will be in this Telegram group. Okay, if you want, I'll share you the link of the Telegram also straight away. But my PDFs, those who know me, my PDFs are password protected. Okay, only those who have the password, they can access the PDF. What is going to be the password? I also don't know right now. I will tell you randomly. Okay. I am also trying randomly. Okay. So I will give a password at random and this is the link of the Telegram. Session will be mostly English, but if you have any doubts in Hindi also, ask me. Doubts I can take up. Okay, but I think language is not at all going to be a barrier. It's not any foreign English that we are speaking. It's a regular English because ultimately engineering is in English. So that is the reason we put it in English. Also guys, tomorrow Sunday 21st of January, BYJU'S exam prep brings to you the next national scholarship test. Appear in the scarce test and you can get as much as up to 90% scholarship based on your performance. Based on your performance in the examination, you can appear at any time between 9 a.m. to the 9 p.m. as per your convenience. Okay, a free live interactive workshop on the BYJU'S exam prep app the coming Wednesday, that is 24th of January at 7:30 p.m. by Dheeraj Sardana sir, and he is going to speak about how to secure single-digit rank in the GATE 2025 examination. Right? Okay, ji. Chalo. Now, for all ECEE aspirants, this is an update, a big update for ECEE aspirants. Okay, mathematics is common for all, but all ECEE aspirants, now the GATE exam is coming closer and closer. We have had lots of revision marathons also. Okay, and now, okay, some question-based series is going to come your way. Some question-based series. 20 important questions from every subject. A T20 series is going to come for you on the YouTube channel. On the same YouTube channel for all ECEE aspirants. Okay. Okay, the T20 series, 20 important questions from every subject to subject we'll keep looking into, and that starts, okay, the coming Tuesday, 23rd of January. Okay, to be taken by different faculties, as you're able to see all your favorite faculties in front of your screen. Okay, so different technical subjects, okay, will be there for all of you. Also, I have covered up the aptitude marathon this type on the app. Last weekend, Sunday or Monday, weekend to nahi bolunga, but last Sunday, Monday, we covered up the aptitude marathon on app. But still, there are some students who missed the aptitude. They were not aware ki app pe hone wala hai. Okay, so guys, that is the reason. That is the reason. Okay, some more. Okay, some more about aptitude. One more session. Okay, for revision of aptitude, I will bring on the YouTube also. I will bring on the YouTube also. Don't worry. Very soon, some more revision session for aptitude. Okay, a very fast track revision for aptitude. Okay, we are going to bring you on the YouTube also. Don't worry. Okay, don't worry. ठीक है, चलो T20 series के लिए ready रहना आप लोग. Okay, चलो. So guys, this is what mathematics. Okay, we are starting today. Okay, now we are starting. Just a final reminder, 20 and 21st January, okay, is the mathematics schedule. Part 1 and part 2, okay, both are going to be held at 10 a.m. each. Okay, both are going to be held at 10 a.m. Today and tomorrow also we are going to start at 10 a.m. And now we start with the first concept. Okay, now we start with the first concept. So basically, firstly, I have preferred to start with the linear algebra. I am preferring to start with the linear algebra, one of the important topics. Okay. Let us start with linear algebra. Okay. Yeah, I'll update you about the signal schedule also, Dreamer. I'll update you about that as well. Don't worry. So, linear algebra. Okay, starting with the concept of rank. Everybody, let's get started now. In case somebody missed to put the attendance, now you can put the final attendance, hit the like button, and then let's starting. Okay. बिल्कुल श्रेया, बिल्कुल बिल्कुल टारगेट 13 का करेंगे पूरा, ठीक है. ओके, अब देखो, let's start first of all with the concept of rank. Okay, one of the important topics, because rank is linked with linear system of equation. Again, final the whole concepts are linked with eigenvalue, eigenvector. तो ये सारे important connected चीजें हम लोग देखते हैं, ठीक है. And rank, which is the largest order of any non-vanishing minor of the matrix. Which is the largest order of any non-vanishing minor of the matrix. Now, to simply understand the concept of rank, let us take one or two examples, and then there is a proper method also, echelon form. Okay, echelon form bhi bataunga, and then there are shortcuts for rank that also I am going to tell you. Okay, so have a look into it before we come to the important points. See, this is a given matrix. Okay, what is this matrix, dear? It is a 3 cross 3 matrix. Okay, it is a 3 cross 3. Acha, number of rows and number of columns are equal. So basically it is nothing but a square matrix. Okay, so firstly what I have given to you is a square matrix. Okay, now what is the maximum possible minor that you can pull out of it? Okay, what is the maximum possible minor? So what exactly is a minor? Minor is any determinant which can be extracted from the matrix. When I say minor, okay, some fundamental points we will keep revising here only. Okay, when I say minor basically is any determinant of any size, which can be extracted from the matrix, from the given matrix, whatever is the given matrix. Okay, any determinant which can be extracted from the given matrix. Okay, so let us say I pull out all the numbers and put it in a determinant. I pull out all the numbers and I put it in a determinant. Okay, so that is 1, 2, 0, 0, 4, 5, 0, 0, minus 2. Okay, this is what is known as a 3 cross 3 minor, and this 3 cross 3 minor is nothing but the determinant of the entire matrix. It is determinant of the entire matrix. Okay, we all know how to calculate determinant. Okay, but can you have a very simple answer for this determinant? Can you have a very simple answer for this determinant? Can you have a very simple answer for this determinant? What type of matrix you have? Basically, what you have is an upper triangular matrix. Whenever all the elements below the diagonal are zero, whenever all the elements below the diagonal are zero, that is known as upper triangular matrix. Okay, now whether the matrix is upper triangular or lower triangular, determinant is nothing but product of diagonal numbers. Okay, product of diagonal numbers. Okay, important fundamentals bhi batate jaunga. Product of diagonal elements. Why? Because it is upper triangular. Yeah, any triangular matrix, upper ho ya lower ho. Okay, triangular matrix, whenever you see upper ya lower, it's going to be product of diagonal elements. So what is the determinant here? It is -8. Now, is it a zero or non-zero determinant? It's a non-zero determinant basically. Okay, what it is basically a non-zero determinant coming up in front of you. Okay, now the largest possible minor is 3 cross 3 in size, and the determinant of that and the value of that is non-zero. Now I told you something. Okay, step by step chalenge kuch examples ke sath. Okay, largest order of any non-vanishing minor of the matrix. Okay, so I already get a order 3 which is non-zero. Okay, and that is the largest possible order. There cannot be 4 cross 4, na? So I can say that the rank of the matrix is 3. You can read this also once again. A rank of a matrix is said to be 3. Rank of a matrix is said to be 3 if it has at least one non-zero minor of order 3. So do I have one non-zero minor of order 3? Yes, there is a one non-zero minor of order 3, and the rank is equal to 3. And the rank is equal to 3. Okay, acha. Now let me take one more example. ठीक है, थोड़ा connect करेंगे सारे points को फिर brief करेंगे एक बार. Okay, before I come to the shortcut. Just a second. Let me allow all the slides to open. See, when I try to open all the slides, it starts hanging also. I'm telling you that today's PDF is very big. Every content I have brought for you. Let us see कितना कुछ आज cover करेंगे, कुछ कल cover करेंगे. ठीक है? Something we'll cover today, something we will cover tomorrow. Have a look into this, dear. Now have a look into this, everybody. Okay. Now, if suppose this is the matrix given to me. If this is the matrix given to me, okay, what is going to be the determinant? Again, a square matrix is there in front of you. What is going to be the determinant of this matrix? Okay, let me start. This is not triangular, so don't apply product of diagonal everywhere. Okay, that is for triangular. Okay, let me expand the determinant by first row. Okay, once again, guys, what is the largest possible minor? Okay, if I explain in terms of minor first of all, so there is a 3 cross 3 minor. When I pull out all the elements, when I pull out all the elements, okay, and that is going to be, okay, the value of this determinant, 5 9s are 45, minus 8 6 are 48, okay, minus 2, alternate plus minus na when you're calculating the determinant, so minus 2, and then cross multiply, 4 9s are 36, minus 7 6 are 42, okay, plus 3, okay, 4 8s are 32, minus 5 7s are 35. I am simply hoping that at least you know to calculate the determinant. Okay. Acha, this is equal to minus 3, minus 2 into minus 6 and plus 3 into minus 3. Okay, plus 3 into the minus 3. Correct? Eh? Okay, so ye kitna ho gaya? This is minus 9 and minus 3 and this becomes actually plus 12, eventually 0. Now you have a 3 cross 3 minor. Now you have a 3 cross 3 minor which is 0. Correct path. There is a 3 cross 3 minor which is 0. Okay. Can I say that the rank is now 3? For the rank to be 3, there should be one 3 cross 3 minor of order 3 of non-zero, one 3 cross 3 minor which is non-zero, but you have only one 3 cross 3 now, or to nikal nahi sakta because I have taken all elements. Okay, so whenever, okay, all 3 cross 3 minors, okay, are equal to 3 or are equal to 0, there is no non-zero minor, so rank cannot be equal to 3. Acha, then can I try 2 cross 2 minor? देखो ये होता है डिटर्मिनेंट मेथड, फिर बाद में शॉर्टकट्स बताऊंगा. आई विल टेल यू टू मोर थिंग, Echelon मेथड एंड द शॉर्टकट मेथड. Echelon method and the shortcut method. Okay, now how many 2 cross 2 minors will be there? Okay, you take any element, you subtract the row and column. Okay, for any element, when you subtract the row and column, the determinant left is known as the minor then. Okay, so how many 2 cross 2 minor? How many 2 cross 2 minor? Rank kabhi 0 nahi hai dada. Rank is not 0 here. Okay, so when you take any 2 cross 2 minor, suppose I take 5, 6, 8, 9, any. I have taken this one. Acha, how many 2 cross 2 minors are possible? 9 2 cross 2 minors you can take. Okay, take it. 9 2 cross 2 minors you can take. So this is 5 9s are 45, minus 8 6 are 48. This is known as minus 3. This itself is non-zero. Now what I am telling is, there will be 9 2 cross 2 minors. There will be 9 2 cross 2 minors. Okay, but do you need to check all? यहाँ पे सारे निकालने की जरूरत है क्या? I told you if at least one non-zero minor you get, answer is over. If at least one non-zero minor you get, so there is at least one non-zero minor, okay, of order 2. It is already non-zero. Okay, so rank will be 2. So rank will be 2. Finish na? You don't need to check all others. Clear? Okay, so at least one non-zero minor. Okay, rank equal to 2. Finish. Rank equal to 2. Rank of this matrix will be equal to 2. Everybody okay? Everybody okay? So first of all, what I'm trying to explain you is just the definition. Okay, it is just the definition. Acha, ab dekho previous question that I've solved, na? Where is that previous question? Have a look into it. Here, I got the 3 cross 3 minor itself, which is non-zero. Okay, so do I need to go below? Do I need to check for 2 cross 2 minor? Not at all, na? Rank is the largest order of non-zero minor. So Baba, jab 3 cross 3 non-zero hai, so why will you check 2 cross 2? If 3 cross 3 minor is non-zero, clearly the rank of the matrix equal to 3. Clearly the rank of the matrix equal to 3. Okay, so that is what first thing is, rank is the largest order of non-vanishing से मेरा मतलब है non-zero. Simple लिख देता हूँ, non-zero minor of the matrix. Okay, so if there is at least one non-zero minor, at least important है, if there is at least one non-zero minor of order R, then the rank is R. ठीक है? If all 2 cross 2 are 0, Shamshad, then we will check 1 na. ठीक है? आते, let me continue guys. Then you ask your doubt. I know everything is going to be clear. Rank can be 0 also. Some of you are telling rank can never be 0. Rank 0 भी हो सकता है. कब होगा? बताता हूं मैं. Okay. Now, if there is a, now look into this matrix guys. This is a 3 cross 3 matrix. Okay, and then the largest possible minor is also 3 cross 3 in size. There cannot be, okay, a size more than 3 cross 3. So if there is a 3 cross 3 matrix, what is the maximum value of the rank possible? Maximum is 3. Here it is 3. Next question it is not 3. Remember, here it is 3. Next question it is not 3. But I am telling you what is the maximum possibility before I solve anything. Okay, so maximum possible rank, if it is a 3 cross 3 matrix, that is equal to 3. Okay, that is equal to 3. I hope that is clear to you. Okay, that is equal to what? That is equal to the 3. Okay, so if you have a square matrix of n cross n size, okay, maximum possible minor is of size n, the rank will be always less than equal to n. Okay, number 1 point. Number 2, if you have a non-square matrix, दोनों के लिए बता देता हूं. If you have a square matrix or non-square matrix. Okay, now non-square matrix, suppose you have the size Suppose you take a non-square matrix of size 2 cross 4. Say for example, 2 cross 4 liya, something like this. Suppose something like this. Okay. Suppose something like this. 1, 2, 3, 4, 5, 6, 7, 8. Tell me. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is the minimum possible rank? Sorry, what is the maximum value of the rank? What is the maximum value of the rank? I'm not asking you what is the rank, but okay. You come and spam here. अरे यार इतना chatter I am not even. Okay. Okay. So I don't know what is the rank. Don't calculate, but just tell me ki the maximum possible minor that you can extract. Can you extract 3 cross 3? There is no third row. No, there are 4 columns, but there is no third row. So maximum that you can extract is a 2 cross 2. Maximum that you can extract is a 2 cross 2 minus. So maximum possible rank is 2. Okay. So maximum possible rank is equal to minimum of mn. I mean, okay, m is the number of rows, n is the number of columns. Jo bhi chota hai. Okay. That is the value of maximum possible rank. That is the value of maximum possible rank. Okay. So you should know rank limitation. Okay. Now, whenever matrix attains the maximum possible rank, have a look into this question. Okay. This is a 3 cross 3 matrix. And I can tell you that maximum value of the rank possible is equal to 3. That's what first thing I told you. Okay. The maximum possible rank is 3. And here the rank is actually 3. Here the rank is actually 3. Whenever matrix attains the maximum possible rank, it is said to have full rank. It is said to have full rank. Okay, these terminology you must know. What is the meaning of full rank? Whenever a matrix attains the maximum possible rank, then it is said to have full rank. Clear everybody? Okay. Now, if a square matrix is non-singular, non-singular ka matlab hai non-zero determinant. Okay, like you got here. Okay, if you have non-zero determinant, okay, this determinant non-zero, so you get the full rank. Okay, you get the full rank. But in the next example, dear, that I have taken, in the next example, I got the determinant 0. That is why the rank was not full. Okay, the rank is not full. We have to go below. We have to go below. Correct, everybody? So that is what you have to check. Whenever a square matrix, if it is a square matrix having non-zero determinant, it will have full rank. Important conditions you must know. Okay, whenever you have a non-zero determinant, that means whenever you have a non-singular square matrix, it will have the full rank. Clear? It will have what? It will have the full rank. It will have the full rank. It will have the full rank. ठीक है? चलो जी, बढ़िया. It is going to have what? It is going to have the full rank, no doubt. Okay? It is going to have the full rank. Done. Okay, whenever a square matrix is non-singular, it will have the full rank. चलो, this is one point discussed. Okay? Now, there are some more things about dependency. वो बाद में देखेंगे. Okay, वो बाद में देखेंगे. But now, let us learn. Okay, a dependency here first of all. Okay, let me go to this example once again. Okay, now a simple way of dealing this example. Come on, now a simple way of dealing this example. Rank 1 or 0 भी हो सकता है, उसकी बात करेंगे. Allow me some time. Let me go in my flow. Now look into this, guys. Okay, the rank of this matrix is obtained as 2. Okay. The rank of this is obtained as 2. No, Vishnu Priya. Square matrix cannot have the full rank always. Now look into this. This is not the case of full rank. It will have the full rank when the non-zero determinant is there. When the non-zero determinant is there. अब इसको देखिए. Okay, have a look into this case, dear. Have a look into this case. Okay. Is there any relation between the rows? Everybody please focus. Do you have any relation between the rows? Do you have any relation between the rows here? इसको देखना है यहाँ पे. Dear, very simple. Okay, take up the R1. Okay, add with the R3. What do you get? Add the R1 and R3. Morning, everyone. Okay, so 1 plus 7 is 8, which is twice of 4. 2 plus 8 is 10, twice of 5. 3 plus 9 is 12, that is the twice of 6. That is the twice of 6. That means when you add R1 and R3, you are getting the twice of R2. Or I can say that R2 is R1 plus R3 divided by 2. So you have, okay, a row which is dependent. I can say that R2 is dependent on R1, R3, or you can arrange anyways. Somebody can say that R3 is equal to 2R2 minus R1. You can rearrange anyways, na? Matlab one of the row is dependent on the other two. one of the row is dependent on the other. To clear everybody. Okay, out of the 3 rows, you have 1 row which is dependent. Okay, you have 1 row which is dependent. So how many independent basically? How many independent? There are 2 independent rows. And look into this. What is the rank of the matrix? Okay, what is the rank of the matrix? Okay, what is the rank of the matrix? The rank of the matrix is 2. The rank of the matrix is equal to 2. Everybody, the rank of the matrix is equal to 2. The rank of the matrix is equal to 2. Here it is. Okay, the next very, very important technique. Okay, the rank of a matrix is always equal to. The rank of a matrix is always equal to the number of linearly independent rows. Or sometimes you can look into dependency of column as well. दोनों में एक साथ मत देखना. Either solve by rows or columns. Or it is also equal to linearly independent columns of the matrix. Okay, it is also equal to linearly independent columns of the matrix. Yes, Pramanjan. So in a way, rank also determines and tells you about the dependency in the rows. Okay. Okay, so we use this technique to calculate the rank as well. The shortcut for rank, and lots of problems you can apply. Okay, in lots of problem you can apply. Chalo. Okay. In lots of problem, we will keep applying. Don't worry. We will keep applying. Have a look into this. Have a look into this. What is the rank of this matrix? What is the rank of this matrix? Dear, very clearly here, 2 rows are same. R3 and R1 are exactly same. Rank of adjoint hai, bataunga. That there is an entry left for that. Okay, I'll tell you that also. Okay, R3 equal to R1. R3 equal to R1. Isn't it? R3 equal to R1. Matlab third row is dependent on 1. First row. So you have 1 dependency. Okay, so how many independency? 2 independent row. So rank of the matrix will be 2. Rank of the matrix will be 2. Okay. Ab dekho, choice is yours. You can, I have told you till now, I have not told you Echelon form till now, but I have told you 2 techniques. One is the determinant technique, one is the independent rows and columns technique. Dekho, what else you can do? अगर dependency strike नहीं किया, तो आप ये भी तो सोच सकते हो कि whenever rows are identical, whenever rows of matrix are identical, the determinant of matrix is 0. Whenever any matrix has identical rows or proportional rows, the determinant of such a matrix is always and always, always and always 0, everybody. That is sure. It is 0. Acha, ab determinant 0 hai, so I am clear that rank cannot be 3. Rank cannot be 3. It's a 3 cross 3 matrix. Na? So now, can I check any 2 cross 2 minor? 1, 1, 1, minus 1. I have taken this one only. Let us check any 2 cross 2 minor. Okay, what is the value of this? Minus 1, which is minus 2. I mean not equal to 0. Okay, so you have a 2 cross 2 minor not equal to 0. The rank will be 2. If you have a 2 cross 2 minor not equal to 0, rank will be 2. Chalo, ye kar lete hain. Okay, that is also one way of looking into it. That is also one way of looking into it. Okay. That is also one way. So you can either follow determinant or dependency method. Okay. Now there is a 3 cross 4 matrix. Okay. One thing let me tell you that for a 3 cross 4 matrix, there is no determinant. Determinant is only defined for a square matrix. Dear, determinant is only defined for a square matrix. Come on guys, share the session. Let's make it 200 watching guys. Come on everybody. Let's make it 200 watching. Okay, tell me. Find the rank of this matrix. Find the rank of this matrix. Okay. Any minor path, any minor you can take. Any minor. Okay. Yeah, only thing that you know is, correct, the rank of this is less than equal to minimum of m or n. That is 3. The rank will be 3 or less than 3. Okay, now, again you start solving, by Echelon form. Echelon, I will tell you, I have not even told Echelon till now. See, the story is I have not even told you Echelon till now, but still I can solve it independent of that. Independent of that. I want you to settle this dependency and independency, because if you settle this in mind, if you practice with this, a lot of questions will become easy. Lot of questions will become easy. Okay. Okay. In the first matrix, 1 to 9, R2 and R3 are dependent on R1. हाँ नहीं Baba, How, Govindrao, R2 and R3 are dependent on R1? R3 is dependent on both R2 and R1. When you say R3 and R2 are dependent on R1, that means R3 depending only on individually R1, R2 depending only individually on R1. But we have R3 equal to 2R2 minus R1. That means R3 depends on both of them. Only one से नहीं निकलेगा. Okay, only one से नहीं निकलेगा. ठीक है. So dear, yeah, most of them narrative PPTs, most of them are shared. Okay, if there is something due, I will just one or two is due. I will share that also, but mostly it is shared. तो ये देखिए C1, C2. This time it will be easy to see in terms of column. देखना. Okay, this time it's easy to see in terms of column. R1 plus R3, R2 बोल रहे हैं. देखो guys, if you see a dependency, it has to be there with every term. Now many of you are talking R1 and R3s. 4 plus 2 is 6. 2 plus 1 is 3. 1 plus 0 is 4. By patience, take in every element. You just don't check in a single element. Okay, you just don't check in single element. Okay, the 1 plus 0, not matching. Na? So there is no R1 plus R3, Baba. There is no R1 plus R3 equal to R2. Clear? Okay, clear? ठीक है. Yes, nullity and dimension की बात करेंगे. I'll talk about nullity. ठीक है. Now, nullity की बात करेंगे जरूर. Have a look into it. Okay. Definitely, if this is 2 4s are, 3 2s are, and 1 2s are. Okay, this is into 2. Okay, C1 is clearly obtained by twice of C2. Everybody, this is clear. This is existing with all the elements. This is there in all the elements. Okay, anything else? 2 plus 1, 3. 3 plus 4, 7. 1 plus 0, 1. Perfect. Okay, तो ये भी match हो रहा है सभी में. So what is that next thing matching up is C2 plus C3 is C4. That means C4 is C2 plus C3. Okay, so I can say that I have two dependent columns. C1 depending on C2, C4 depending on C2 and C3. Okay, ये दो पे depend कर रहा है, एक पे कर रहा है. मतलब two of these columns can be derived using C2 and C3. Okay, using C2 and C3. Okay, I have two dependent columns depending on C2, C3. Okay, they are depending on C2, C3 and they will be, C2, C3 will be known as independent columns here. Rank is either number of linearly independent rows or linearly independent columns, anything. Okay, so two linearly independent columns, rank will be 2. Without the Echelon form, पहले इसका आंसर बता दिया हमने. I will introduce Echelon form little later. पहले इसको adapt कर लेते, which can help you solve the problem simply. Everybody okay with that? Everybody okay with that? ठीक है. So rank is equal to 2. Done. What is the effort required? Okay. Nothing. Very simply, the dependency was to be seen. Can you tell me next answer now? Everybody. Which doubt, Govind Rao? Can you recommend it? Okay, tell me. Find the rank of this matrix. Observe the numbers and let me know what is the rank of this matrix. Observe the numbers and you can let me know what is the rank of this matrix. Tell me. Yeah, dear. Chalo. How much? How much is the rank? Okay, many of you are telling that the rank is 1. Chalo, dekh lete hai. What is the rank here? Let's say this is R1, 1, 2, 4. Okay, so 1 into 2, 2 into 2, 4 into 2. Everything multiplied by 2. So this is twice of the first row. Okay, now look into this. 1 into minus 5, 2 into minus 5, 4 into minus 5. Everything is matches. So this is minus 5 times R1. Clear? This is nothing but minus 5 times R1. Okay, so all the rows are just proportional to each other. Okay, I can say that R2 is twice R1. R3 is minus 5 R1. Okay, so how many dependency? There are two dependencies. Okay, so how many independent row? Only one independent, na Baba? Only one independent row. So rank of this matrix equal to 1. So some of you were talking about rank equal to 1. This is what is the significance of rank equal to 1. You can check in the columns also. Okay, but dono mein mix mat karna. Purni, don't mix in the both. Either check on rows or either check on columns. Don't mix in the both. Very honest advice, otherwise you will fall into a trap. Either check dependency all rows or either all column. Please mix mat karna, you will fall into a trap many times. That can be a trap for you, okay? That is what is the rank equal to 1 when only one independent rows. If this is R1, this is some alpha R1, this is some beta R1. Okay, that means whenever all the rows, okay, or same thing applies to columns of a matrix are identical, okay, or proportional to each other, then the rank will be equal to 1. That means, okay, your matrix was in the size R, matrix is suppose R1, okay, some alpha R1, some beta R1, okay, some gamma R1, etc. You have only and only one independent row. Okay, others are dependent on it. Alpha R1, beta R1, gamma R1, any numbers you can take. Okay. Okay. Please say your doubt, Govindrao. I mentioned you. Okay. Na, Anantu. Rank is number of independencies, not number of dependencies. Clear? Number of independencies. So Venkat, if one column depends on two columns independently, so definitely those two are independent. Na? You have to check whether those two are independent or not. Like here, in our one of the previous case, C2, C3, they are not related. Why they are not related? I'll tell you why C2, C3 not related. Because you multiply any number, 1 cannot be converted to 0. Na? That is only possible if you do 1 into 0. Okay. But 1 into 0, so 3 into 0 bhi hona chahiye, not possible. There is no ways you can convert any non-zero number into a 0 number by multiplying anything. ठीक है? What is 1, 2, 3? Govindrao, please specify a doubt fully or otherwise don't specify. What is 1, 2, 3? What should I understand? What do you say 1, 2, 3? ठीक है? चलो, now rank has been taken as 1. ये 1 वाला case आ गया है. Okay, now some of you were worried about, some of you were talking about rank equal to 0. Can the rank be 0? Okay. Can the rank be 0? Okay, can the rank be 0? Tell me. Can the rank of any matrix be 0? Now I am asking for your replies. Okay, can the rank of any matrix be 0? Okay. R2 is R1 plus R3, R1 plus 3. Na, Govindrao, see. We only talk about linear dependencies of the form. Dekho, dhyan rakhna. Whenever I say a dependency, na, suppose R3 is dependent, it should be alpha R1 plus beta R2. That is a dependency. Please listen everybody clearly. Right? ठीक है. So narrative, I request you, please don't watch. I have put a lot of PPTs. You know what you do by this? You are blocked for the upcoming 24 hours. Nothing you achieve out of this. Okay. Baba, एक तो comfort के लिए PPT दे रहे. It is not my moral responsibility to give you the PPT. You come and watch and you make your notes na. What is going bad with you? You come and watch, make your notes. People are so lazy these days कि पढ़ना भी है, सब कुछ लिखा हुआ मिल रहा है, आपको हाथ पैर नहीं चलाना है, आपको कुछ नहीं करना है, ठीक है? और आपकी गेट रैंक भी नहीं आने वाली है by this way. Okay? ठीक है? आपकी गेट रैंक भी नहीं आने वाली है. You have to watch a movie, you will get a spoon feeding and spoon feeders never become ranker. Okay. By the way, I am providing the PPTs. Okay. Most of the PPTs. Okay. But even if I don't provide, that is not my moral responsibility. Now I am providing to help you. भाई बना लो अपने नोट्स अगर नहीं मिल रही है पीपीटी तो. You come and sit, make your notes. Okay. You come and sit, make your notes. Okay. Chalo, if that is the case. But although guys, okay, digital control, whatever marathons we have completed, I have given you the PDF. Don't worry, all mathematics champion, you will get the PDF. Okay. It's not that I don't want to say I'll give you the PDF, but just those who are spamming, let it be. Now he's blocked for 24 hours. Let it be. Chalo, aa jaate hain. Okay. R3 is equal to alpha R1 plus beta R2. I was replying to a doubt. This is a dependency. But when I say, suppose R3 equal to alpha R1 plus beta R2, okay, plus suppose 5. Okay, this is not known as dependency. Only dependent on rows, not on constant. Acha, suppose you say R3 is equal to R1 square. This is also a dependency. No, I only say linear dependency, which does not even involve a constant term. Purely dependent on rows. Purely dependent on the other rows. Okay. Purely dependent on the other rows. Clear everybody? It is purely dependent on the other rows. Okay? this one only will be counted as dependency. This is not a dependency. I mean, this can be some other dependency. We don't count it in the linear dependency. We also don't count this in the linear dependency. And the technique that I'm telling is for linear dependency. Okay, clear, Govind Rao? Badhiya. Okay, so remember, this is for everybody. This is what dependency do not mean. Okay, only of the form alpha R1 plus beta R2. Okay, dependence purely on the rows. Chalo, हाँ, हम बात कर रहे थे यहाँ पे rank of A equal to 0. Yes, it can be possible, but only for one matrix in the world. Only for one matrix in the world, and that is known as null matrix. Bhai, what do you mean? Understand like this, na? What do you mean when you say that the rank is 0? That means rank 1 bhi nahi hua. You come to 0 means there is no 1 also. That means all 1 cross 1 minors are also 0. Baba, if there is one non-zero minor of 1 cross 1 size, if there is one non-zero minor of 1 cross 1 size, then the rank will be equal to 1, na? The rank is not even 1. That means all 1 cross 1 minors are also 0. Now, what is a 1 cross 1 minor? Suppose I give this matrix. Every single element is a 1 cross 1 minor, na? And even if you get 1 cross 1 minor non-zero, iska rank 1 hoga. The rank of this matrix will be 1. The rank of this matrix will be 1. So 0 tabhi ho sakta hai ki no 1 cross 1 minor is also available. All elements are 0, and matrix having all elements 0 is a null matrix. A matrix having all elements 0 is a null matrix. Hope that is clear to you. ठीक है, तो चलो कुछ फंडामेंटल्स डिस्कस कर लिया. रैंक इक्वल टू 1 डिपेंडेंसी वाला डिस्कस किया है. ओके, करेक्ट. टेल मी दिस आंसर नाउ, कम ऑन, टेल मी दिस आंसर. ठीक है जी, बताइए. टेल मी द नेक्स्ट आंसर. ओके, इफ a is equal to aij, I1 less than equal to ij less than equal to n, that means I and j are both in the range 1 to n. They are both in the range 1 to n, and greater than equal to 3, and aij is I into j. N can be any value greater than equal to 3. Let's try n equal to 1. It will be simple. Let us try n equal to 3. Chalo, n equal to 3 try karte hain. Okay, aij. Okay, aij is the element in ith row and jth column. It is the element in ith row and jth column, and that is given by I into j. That is given by I into j. Okay, so our first element is a11, na? So what is a11? It is 1 into 1. Next element is a12, first row, second column. Then a13. Now, in next element here, it should be a21. This should be a21. Okay, a21 is 2 into 1, 2 into 2, 2 into 3. 3 into 1, 3 into 2, 3 into 3. This is how elements are made. Okay, now when you complete the multiplication, this is 1, this is 2, this is 3. 2 1s are 2, 2 2s are 4, 2 3s are 6. Okay, and then this is 3, 3 2s are 6. Okay, 3 3s are 9. Now very clearly once again, if this is R1, okay, this is just multiplication by 2. 1 into 2, 2 into 2, 3 into 2. So this is 2R1. Okay, 2 into 3. Sorry, first say dekhenge. 1 into 3, 2 into 3, 3 into 3. This is 3R1. This is 3R1. Okay, this is 3R1. Okay, R1, 2R1, 3R1. All the rows are proportional. Okay, of this format. Of this format, all the rows are proportional to each other. Then the rank of such a matrix is always 1. Okay, only good thing about this question is, the good thing about this question is language. Matrix is not directly given. Matrix is not directly given. Okay, you have to form the matrix with the help of these elements. It is not difficult also, but that is something different as compared to regular question where the matrix is given to you. Okay. Correct. Done hai? Chalo, this is done. So remember that. Okay, whenever all the rows are proportional, all, मैंने क्या बोला था? All. If all the rows are proportional, then the rank is equal to 1. ठीक है? चलो, अब आते हैं. Let's talk about something else. Yeah, one result. Let me write here, and then let's talk about echelon form. Let us talk about echelon form. Okay, so suppose you have an n cross n square matrix. Suppose you have an n cross n square matrix. Okay. What is the rank of adjoint A? No need to derive the standard results. Okay, dear, the rank of adjoint A, इस पे क्वेश्चन आ सकता है, इसलिए इसको अलग से लिख देते हैं. Rank of adjoint A, we need to see. Okay, we need to see. Suppose, let's say the rank of the matrix is A is a n cross n square matrix, na? ठीक है. So rank of matrix can be anything, na? Okay, so suppose there are 3 cases I will say. Suppose the rank of matrix itself is n. Rank of matrix itself is n. Okay, next case. Rank of the given matrix is n minus 1, and third case, if rank of the matrix is less than n minus 1, any value less than n minus 1. Okay, less than any value n minus 1. ठीक है. if the rank of the matrix is n, full rank, matlab matrix is non-singular, adjoint also will be non-singular. One formula let me add you should know. Okay, guys, what is the determinant of adjoint A? The determinant of adjoint A is given by the formula mod A power n minus 1. नहीं पता है तो उसको separately note कर लेंगे. Okay, the determinant of adjoint A is given by determinant of A power n minus 1, mod A power n minus 1. So rank of A equal to n, mod A non-zero, so mod of adjoint A also non-zero. It will also have the full rank. Okay, so this will be n. But if rank of A is equal to n minus 1, rank of adjoint A will be 1. All rows will turn out to be proportional to each other. And rank of A less than n minus 1, the adjoint A itself will become a null matrix. We know how to form adjoint. You try to form adjoint, it will be a null matrix. Okay. No, Prabhanchan. A is a n cross n square matrix. It is not necessary that it will always have rank A. It will always have rank n. It will have rank n only if the determinant is non-zero. I clearly told you, bhai, ki it is not always having full rank. It will have full rank. It will have full rank if it is non-singular. Otherwise, it may not have the full rank also. That is why all cases we are taking. That is why all cases we are taking. ठीक है जी? चलो ये done हो गया. Now, after these several examples, let me tell you echelon form. Now, after these shortcut discussions, after these shortcut discussions, ठीक है? After these shortcut discussions, okay, I don't think you need much about the echelon form, but still you should know it. ठीक है, इसमें बता देता हूँ. What is the echelon form? What is the echelon form? Okay. A matrix of order m cross n is said to be in row echelon form. I'll be taking row echelon form if zero rows, if any, they must be below the non-zero rows. Okay, and number of zeros before the first non-zero element. इसको मैं simple करके बताता हूँ. This simply means that number of starting zeros. I will write it in a simple format. Number of starting zeros must be in the increasing order. Must be in the increasing order. And what is the first statement? Okay, ROZ. If there is ROZ, row of zeros, I call it as ROZ. If there is any ROZ, I don't say कि row of zero होना चाहिए. But if there is any ROZ, okay, must be at the last. First, second position में नहीं होना चाहिए. It must always be at the last. So first, let us understand the row echelon form. Okay. Let's take the similar example first. We know the rank of this matrix has turned out to be 3. Same example. Okay. What I have told you, number of starting zeros must be increasing order. Okay. I'll define a parameter here. Suppose let m is equal to number of starting zeros. Let m is equal to number of starting zeros, dear. Suppose that m is equal to number of starting zeros. Then, okay, starting zeros means jo beginning mein, see, this is not starting zero, but this is a starting zero. Zeros at the beginning of every row. Zeros at the beginning of every row is starting zero. So what is the value of m here? There is no starting zero, but there is one starting zero here. Okay, there are two starting zeros here. So m equal to 0, 1, 2. Do they follow increasing order? Yes, they follow the increasing order. Is there any ROC? No. If there is a ROC, वो last में होना चाहिए. But there is no ROC, na? Okay, there is no ROC. ठीक है. Clear? Okay. So is this row echelon form? This particular determinant is in row echelon form. Yes, I can say that it is in the row echelon form. It is following the row echelon form. Now, whenever a matrix is in row echelon form, okay, then the rank of such matrix is directly number of non-zero rows. Rank of such matrix is directly number of non-zero rows. Number of non-zero rows. So how many non-zero rows here? Okay. How many non-zero rows? 1, 2, 3. All are non-zero, na? What is the meaning of zero row? Zero row means completely filled with zero. Here, so all 3 are non-zero. Okay, rank is number of non-zero rows. Clear, everybody? Chalo, next example. First, tell me, is it echelon form? Everybody, first tell me it is echelon form or not. Everybody. Now I'm telling you na, why you actually don't need much about echelon form. You can say its rank directly. Baba, you can say its rank directly. Rank bata दूं पहले मैं. Rank bata दूं. Entire row 0. Determinant will be 0. Determinant will be 0. Rank 3 नहीं हो सकता. Determinant is 0. Rank cannot be 3. Look into this minor. Okay, what is the value of this minor? 1 into 3 minus 0, which is 3. Non-zero. you have a 3 cross 3, you have a 2 cross 2 minor, which is non-zero. The rank will be 2. 2 cross 2 minor non-zero, rank will be 2. Khatam. You know simple methods actually, but echelon form you must know. You should know at least the concept. Okay, so dekho. So rank is 2 already we know of a previous method. This is starting 0. I have 1 starting 0. I have 2 starting zeros, and then eventually I have 3 starting 0. It is following the increasing pattern. Is there any ROZ? Yes, there is a ROZ, but that is at the last. That is what I want. Na? I want increasing number of zeros, and I want, if ROC is there, it is at the last. Okay, so it is echelon form. Correct. It is in the echelon form. If it is in the echelon form, rank is equal to number of non-zero rows. Okay, this is a 0 row now. So how many non-zeros? There are 2 non-zeros. Everybody okay? These are 2 non-zeros. Okay. Next, tell me first of all, is it echelon form? Tell me first of all, is it echelon form? Quickly, everybody, all champions. No, not necessary, Gautam. Is it echelon form? Is it echelon form? Chalo check karte hain na. Starting zeros, m equal to 1. Starting zeros, m equal to 2. Starting zeros, m equal to 2. Do they follow increasing order? Increasing se mera matlab hai strictly increasing. Strictly increasing. Okay, this is same, not allowed. Strictly increasing. Same bhi nahi hona chahiye. It is not echelon form. Okay, Alu Arjun? Okay, even same is not allowed. So this is not echelon. Okay. So if it is not echelon, then what to do? You can convert it into echelon. Next is you can convert to echelon. Okay. Yes, Jay, we can convert it to a row echelon. How you can convert? Okay, you can use, okay, the transformation. Okay, see, if this was 0, like 1, 2 and 3, you want increasing, na, this should be 3. Okay, 3 means all these 3 should be 0. Okay. All these 3 should be 0. So, isko 0 mein convert karne ke liye, I will apply an operation on the third row. I will apply an operation on the third row that R3 equal to R3 minus, multiply this row by 3. Okay, 3 2s are 6, subtract karenge. Okay, minus 3R2. Only thing is you can apply the transformation on the entire row or on the entire column, any one of them. You cannot apply on a single element. Okay, so I complete row pe apply karenge, but these are anyway zeros. 0 minus 0 not going to be affected. Okay, so ultimately when you apply this transformation, you see what is the matrix you get. You see what is the matrix you get. You get first row is not disturbed. Second row is not disturbed. I have transformed the third row. R3 minus 3R2. So 0 minus 0, 0 minus 0. But 6 minus 3 into 2. 6 minus 3 into 2 is also 0. And now I count 1, 2, 3. What is the starting zeros now? 1, 2, 3. This is increasing. And now there is a ROZ also, but that is at the last. ROZ at the last. This is echelon. That is echelon. Okay, so now you can say rank equal to number of non-zero rows 2. Number of non-zero rows, that is equal to 2. Now देखो, the catch here is, the trap here is कि maybe if you assume this to be echelon form, ये अगर आपने same वाला condition ध्यान नहीं दिया, okay, if you take this to be echelon form, then you will say, okay, 1, 2, 3, all 3 are non-zero rows, you will say rank is 3, but rank is not 3. Rank is not 3. Even you can calculate the determinant, rank will not be 3. Determinant will be 0, 100, 500%. Determinant will be 0, so rank cannot be 3, na? Okay, rank cannot be 3, na? Chalo, next. Okay, so this example, now 1, 2, 3, 4, 5, 6, 7, 8, 9, ये वाला जो example था ना dear, okay, we have solved this example by 2 different methods. Okay, okay. देखो, Nana Prakash, yes, you can make it to be last, but I will tell you it will not be required for you. If you are ensuring increasing zeros, na, think logically, you think both are required conditions, but logically, okay, you are trying to make the number of zeros in increasing order, और उसी पे focus करो. And if you have number of zeros in the increasing order, तो definitely ROZ मतलब all elements 0, maximum zeros, that will automatically come to last because of the increasing pattern. So it will automatically come for you, Nana Prakash. Okay, it will automatically come to you. ठीक है? चलो. Now echelon form on this one. भाई dependency से भी solve किया है, determinant से भी solve किया है. Okay, let's take the same matrix for the echelon form. Number of starting zeros? Nil. There are no starting zeros basically. There are no starting zeros. There are no starting zeros. It is all the way same. It is all the way same. There are no starting zeros. Okay. There are no starting zeros. Clear, everybody? There are no starting zeros. It is all the way same. Okay. It is all the way equal to the same. Correct hai? Chalo, done hai. Now, that means it is not echelon. It is not echelon. Okay, so now I will apply some transformations to convert into echelon. So देखो, I need to increase the zeros. तो यहाँ पे zero लेके आएंगे सबसे पहले. Let's try to make first element zero. Okay, let here there be no zeros. Then at least यहाँ पे zeros लाएंगे. Okay, how to convert 4? Okay, use this 1. 1 into 4 is 4. Then you subtract. So I will use R2 equal to R2 minus 4R1. Similarly, this is 7. 7 minus 1 into 7 will be 0. Okay, so R3, I will use R3 minus 7R1. Clear? Minus 7R1. After I do this much, what is going to be my matrix? Please see. It becomes 1, 2, 3. Then 4 minus 4 into 1, 0. Okay, 5 minus 2 4s are minus 3. 6 minus 3 into 4, 6 minus 12, minus 6. Then 7 minus 7. 8 minus 2 into 7, minus 6 आ गया. 7 minus 7, sorry, 0. Okay, 8 minus 2 into 8 minus 14, minus 6. 9 minus 7 से क्या? 9 minus 21, minus 12. Okay. Now you see increasing pattern. Okay, here first row number of starting zeros nil, but now I have got 1. Okay, third row also I have got 1. Okay, अभी भी ये same है. Okay, so now what I need to do is next step. Okay, now what I need to do is next step. Next step means 2 non-zero rows चाहिए होगा. 2 non-zero elements चाहिए होगा. Okay, here I have to make 2 non-zero elements. Okay, so now इसको convert करेंगे. And so what I'm going to do now is R3. Okay, minus 6 and minus 3. So what I will do? Multiply this by 2. Okay, this will become minus 6 and then we subtract. You will get 0. So R3 should be replaced as R3 minus 2R2. Okay, R3 minus 2R2. Okay, what is A? Okay, 1, 2, 3. 0, minus 3 and minus 6. Okay, 0, 0. Okay, minus 12 into 6 into minus 2. This is also minus 12. So this also 0. Okay, this also 0. Now you see 1, 3 and there is no 0 here. 0, 1, starting zeros, 3. See, it is a jump from 1 to 3, but it is increasing now. Okay, it is increasing now. Okay, for 4 cross 4, most commonly dependencies will be the shortcut. Mission IIT. Okay, the dependency methods that I have told you. Dependency method. Okay, whether it is jump or what, at least it is increasing now. Increasing hai and ROC at the last. Okay, so this is clearly echelon form. Okay, so what is the rank of the matrix? Number of non-zero rows. Okay, the third one is 0. First two are non-zero. Rank is number of non-zero rows. Baba, already we derived this. Na? Okay. Okay. Yeah, that's what. Jay is also correct. Mostly 4 cross 4, if it is a conventional problem to be taken by echelon, it will not be there in gate because gate focuses more on conceptual part. Okay, tricky part, not on lengthy calculation. But there can be 4 cross 4 question. There may be, okay, there may be, based on dependency. Yeah, correct. Mission. There can be some dependency. Okay. No, Gitika, the question doesn't say ki solve by echelon form. At least in gate. Okay, if it is a conventional paper, okay, then they can ask to method. I ask you for applying a specific method. Okay, but in gate, you need to see, like, okay, if I add first and third, I get twice of all two. There is a dependency. So if I am able to see dependency, if I am able to calculate determinant, first two methods are more simpler, then why go for echelon? Okay, so you must know it. I have told you echelon. You must know it. Okay, but, you have to think more about dependency and determinant if you want to save time. Okay. All okay. Chalo. So done. This question is done. Then rank of the matrix, dependent column wala bhi case dikha diya hai. All rows are proportional. Rank is 1. Null matrix ke liye rank is 0. Dependencies doubts also cleared. Okay. And now, okay, the rank is again ultimately used in the linear system of equations also. So let us talk about linear system of equation first of all in 3 variable. Let us talk about the linear system of equation first of all in the 3 variable. Okay, in the 3 variable. Okay, so let's say, okay, you have a11x plus a12y plus a13z equal to b1. Now this is more important. For direct question point of view, na? For direct question point of view, this is more important. Rank is indirectly used here. See, rank is also important. Aata hai question, but mostly questions from this linear algebra na, are either two topics. Highest frequency of question is from eigenvalue and eigenvector. Then either linear system of equation. Most commonly, yahan se question zyada aata hai. Most commonly, but there are questions on rank also. So you should not ignore it. Okay, linear system of equation starting in the 3 variable. Okay, so let's say you have 3 variable and 3 equation. Okay. That's what Bhanu. Dependency, देखो, dependency if you're able to strike in 10-20 seconds, it is okay. Don't waste minutes onto it. If you see कि dependency नहीं दिख रहा है, अच्छा क्या होता है ना? Sometimes dependency is there, but you are not able to see directly. You are not able to see directly. Why? Because there sometimes there can be a dependency means any dependency. Sometimes there can be a dependency that R3 is equal to 4.1 R2 minus 2.8 R3, 2.8 R1 ले लेते हैं. This is also known as a dependency na. Okay. There can be dependency non-integral numbers also, non-integral coefficient also. Okay, yeah, it can be some big numbers. Okay, it may be of the form 4R3 is equal to 17R2, okay, plus 51R3. That is also known as dependency, but maybe, you know, visualizing such dependency, okay, such dependency will be time taking. ऐसा नहीं कि dependency नहीं है, time taking. So in that case, what I suggest, if it is a 3x3 question, still better method is determinant. You will take less time to calculate determinant, na baba? Think still better method will be determinant. If it is higher order matrix above 3x3, then think about echelon. Okay? Okay? So that is what. Some dependencies can be there, but maybe you are not able to see because it is some random numbers. Some random numbers. Okay? Aate next question ki taraf. Linear system of equation. Okay, so 3 variables x, y, z, and you have 3 equations a11x plus a12y plus a13z equal to b1. And similarly, second and third. Now, dear, these numbers a11, a12, a13, a21, 22, 23, 31, 32, 33. These are known as what? These are known as the coefficients of x, y, z. Okay, and these are the constants of right side. X, y, z are the unknowns here. X, y, z are the unknowns here. So we convert this first of all equivalently, okay, into the matrix form. Okay, where I take the matrix A, which will be known as coefficient matrix. Okay, where I take matrix A, which is known as coefficient matrix. Why coefficient matrix? Because it is containing all the coefficients of x, y, z. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, etc. Okay, now this matrix combined with x, y, z, okay, multiplied by x, y, z equal to b1, b2, b3. Now, we know how to multiply matrices. We know how to multiply matrices. Have a look into it. First row, first column here. Okay, corresponding elements a11x plus a12y plus a13z. Clear? Now, how do you equate matrix? First element here should be equal to the first element on right. Corresponding elements. So, equal to the b1. Equal to the b1. Then, okay, after first row, we start the multiplication. Second row with the column. Okay, so a21x, a22y, a23z. When you add, you get b2. Okay. Similarly for third. Homogeneous पे आएंगे guys. Homogeneous पे भी आएंगे. Don't worry. Okay, first I'm starting with non-homogeneous. Okay, I'm starting with non-homogeneous. What is homogeneous? वो आगे बताता हूँ. Just wait. Okay. Just wait. Starting with non-homogeneous. Then you will understand what is homogeneous, non-homogeneous. I mean, I'm not involving into that. Right now, take any system of equation here. Okay? So that means these 3 equations can be equivalently represented by the matrix operation known as Ax equal to B, where A is the coefficient matrix and X is the matrix containing the column vector containing the unknown. See, this is a column matrix, and column matrices or row matrices are also known as vector, column vector or row vector correspondingly. So you can call it as a column matrix or a column vector of the size 3x1, and this is the matrix containing the unknowns. Okay, the result. Okay, when you multiply A with X, you get the result. That is known as B. That is known as B. Okay? Now, this system of equation, okay, may give you a unique single solution, or it may give you multiple solution, or it may give you no solution. Shortcuts bhi bataunga, but first the details. So as I already mentioned, A is the coefficient matrix. We form another matrix that is known as augmented matrix. A is to B. What is augmentation of a matrix? Generally, when matrices are combined, when 2 or 3 different matrices are combined and written together, that is augmented matrix. That is known as augmented matrix. That is known as augmented matrix. So we have A is to B, okay, where the column of B I include within the A and it becomes a 3 cross 4 size. This becomes a matrix of the size 3 cross 4. Okay, that is augmented matrix. Now, what is the final statement, Rouche's theorem? No derivation here, but the methods and the theory and the methods and concepts some question में learn करते ही जा रहे हैं. Okay, Rouche's theorem, which says that a system is consistent. A system is consistent if and only if rank of coefficient matrix is equal to the rank of augmented matrix. Okay, for a system to be consistent, rank of coefficient matrix should be rank of augmented matrix. So ultimately method is dependent on rank, but I will tell you shortcuts also. Okay. Consistent. Achha, what is the meaning of system being consistent? Consistent means it will produce some solution. Maybe one or maybe more, but it will have some solution. Okay. It will have some solution. Maybe one or maybe more than one, but kuch na kuch solution dega. It is solvable. Okay. It is solvable. That is what consistency means. Okay. It does not mean only unique, Manasvi, but it will give you some solution. Maybe unique or maybe more. Okay, some solution exists. That is what consistency is. Now, let us, remember this Rouche's theorem in the form of flowchart and let's apply it to a problem. Okay, so we are trying to solve the equation Ax equal to B. Okay, Ax equal to B, and let's say you're talking about n number of variables. Like previously was 3, let me generalize. Suppose you have n number of variables. The rank of the 2 may be equal, may not be equal. If the rank of 2 is not equal, if the rank of it does not equal to rank of A is to B, then the system is inconsistent, opposite to the previous case. And inconsistent matlab it is not solvable, it will not give you any solution. It is not solvable, it will not give you any solution. Okay, the system will have no solution. I will explain with examples also. I will explain with example. Okay, such a system is inconsistent when rank of A not equal to rank of A is to B. It is inconsistent, not solvable, having no solution. Okay, but if both of the ranks are equal, and let's say equal to R, then the system is consistent. And consistency, I told you, it will give you some solution. One or more, it will give you some solution. Okay, so now whether it is one or more, you can check. Yeah, you can check here. If both the ranks are equal and equal to n, where n is the number of variables, if both the ranks are equal and equal to n, then it will give you unique solution. If both the ranks are equal but less than n, then it will give you infinite solution. Then it will give you infinite solution. Okay? Then it is going to give you what? Infinite solution. Okay? Ye yaad rakhna. Then it is going to give you the infinite solution. Okay? Ye ho gaya done. So, if I move ahead, let's specify the unique solution separately, because is pe separate questions solve karna very easy. For unique solution, actually you don't need to go to the rank. You know why? If the question is only on unique solution, you don't need to go to the rank. The reason is, for unique solution, the condition is RA equal to RA is to B. Both the ranks are equal and equal to n. So eventually, rank of A equal to n. And what is the A matrix, dear? A is a 3 cross 3, n cross n matrix. Okay, it's a n cross n matrix. Agar square matrix ki baat kare. Okay, so for a square matrix, okay, to have rank n, that means square matrix is having full rank. For unique solution, the matrix A is having the full rank. ऐसा बोल सकते हैं ना? The square matrix A is having the full rank. And for the matrix to have full rank, what is the condition? For the matrix to have full rank, the condition is its determinant non-zero. Its determinant non-zero. That means if the question is only on unique solution, no rank is required. It is just non-zero determinant required. It is non-zero determinant required. Clear? That means if coefficient matrix is non-singular, non-singular means non-zero determinant, then the system will have unique solution. Simple. Unique solution ka problem and process is very simple. I hope you have got that. Clear? Okay, when the matrix has non-zero determinant, it is said to be non-singular. Okay. Non-singular. ठीक है? अच्छा जी. Done है. Done है. ठीक है. अच्छा, if a matrix has non-zero determinant, its inverse will also exist. Dear, what is the A inverse? The inverse of a matrix is adjoint A divided by modulus of A. And if modulus is non-zero, okay, if the modulus is non-zero, then the inverse of the matrix exists. Such a matrix is said to be invertible matrix. Such a matrix is said to be invertible matrix. Okay, whenever, okay, the inverse of a matrix exists, it is invertible, and that will exist if mod A not equal to 0. Okay, so inverse agar exist kar raha hai, to we have Ax equal to B, na? I multiply both the side by inverse. Okay, A inverse Ax equal to A inverse B, A inverse A cancelled. It will give you identity. It will give you unity. So you're left with only X. So what is X? A inverse B. So what is that unique solution? Suppose I ask you what is that unique solution? That unique solution can be obtained by A inverse B. But let me tell you honestly, okay, that you know, most likely 99% they don't tell what is the unique solution. They only concentrate, okay, whether it is unique solution or no solution or infinite solution. कौन सा केस exist करेगा, ठीक है? चलो देखते हैं. So let me first take up a question. Okay, for what value of K system has unique solution? So that is what I'm trying to say. If you have a question on unique solution, you don't have to apply any rank. It's a very simple question. Unique solution simply means mod A not equal to 0. Mod A not equal to 0. Very simple. Mod A not equal to 0. ठीक है? चलो. Mod A not equal to 0. ठीक है? mod A not equal to 0. Done है? The mod A not equal to 0. तो चलो, let's see that. Mod A not equal to 0. Let's see that. What to do mod A not equal to 0? What to do mod A not equal to 0? चलो check कर लेते हैं. What is mod A not equal to 0? Now what is mod A? देखना यहाँ पे. A matrix 1 1 2. Okay, 1 2 4. Okay, 1 3 K. This determinant not equal to 0. इतना ही तो करना है. No rank involved for unique solution. ठीक है. So now just solve this determinant quickly. Okay, it's going to be 1 and then you have 2K minus 12. Okay, minus 1 into K minus 4. Okay, plus 2 into 3 minus 2. This is not equal to 0. Let me simplify this. So I have 2K minus 12 minus K minus minus plus 4 plus 2 ones are 2 not equal to 0. And that means 2K minus K and ये हो गया minus 12 plus 6. Right side पे भेजा 6. K not equal to 6. So K can take all values except 6. Answer is C. K not equal to 6. Correct answer is option number C. Yeah, many of you are coming with that. It's not D my world. K not equal to 6. Equal नहीं. नहीं Jay, you are telling reverse. Mod A अच्छा not equal to 0 बोल रहे हो ना? Yes. Mod A not equal to 0. Okay, for a square matrix 200% guarantee rank will be n. कोई doubt नहीं है उसमें Jay. ठीक है? ठीक है? ठीक है? ठीक है? Done है? चलो now next question. The following system of equations will have the following system of equation. Now I am not asking you ki what is the value of K for unique solution or something. Okay, the following system of equations will have what type of solution? Unique, no, infinite, and two solution. Baba, this is never possible. First of all, straight away cut down the answer D. Either the system will have one solution or multiple solution or no solution at all. Okay, whenever you see option 2 solution, 10 solutions, 5 solutions, never possible. That is never possible. If a system has more than one solution, na, it will have infinite only. It will have infinite only. ठीक है? अब देखो. First, let me explain you the details and then I will write down the shortcut. I leave a space for shortcut here. Okay, but before I tell you the shortcut, okay, let us understand the Rouche's theorem here. Before I explain you the shortcut, okay, I will explain you the Rouche's theorem here. Okay, let's understand by the Rouche's theorem. Okay, let us apply the Rouche's theorem here. The detailed method. Like rank also had a detailed method, but most of the questions we don't need a detailed method. Similarly, let us learn the detailed method. ठीक है, चाहिए कि नहीं वो बाद में देखेंगे. Okay, and Rouche's के लिए I need A is to B first of all. I need to form the augmented matrix. What is that augmented matrix? Coefficients are 1 to 1. पहले coefficient लिख देते हैं. 1 to 1. Okay, 2 1 2. And third row 1 1 1. 1 1 1 is 2 is 2 is 2. Okay, 6 6 5. 6 6 5. Shortcut बाद में, पहले पूरा मेथड देखेंगे. First learn the method. Okay, then shortcut. Come on guys, share the session everybody. Let's make it 250 likes and how many attendance? 250 watching. What is your attendance right now? Let me have us look into attendance before I complete the Rouche's for you. Just a second, it is not loading. looks like there is some problem. Yeah, now it is okay. Even attendance is 250. Guys, let's try for 300 attendance. And attendance 300 means 300 likes. Okay, guys. चलो हाँ, अब आते हैं Rouche's theorem पे. Rouche's theorem is dependent on rank ना. Okay. And rank के लिए the conventional method is echelon form. The conventional method is echelon form. Okay, echelon form. अब देखोगे. Is this matrix in echelon form? See, whatever I tell for A is to B, it is applicable for A also. A is actually internal of it. A is actually inside A is to B. So whatever operations I apply on A is to B, automatically applied on A. Automatically applied on A. So tell me guys, number of starting zeros, nil. Number of starting zeros, nil. Number of starting zeros, nil. Same है. Number of starting zeros, same है. Okay, same है. Okay, m is the same variable, number of starting zeros. तो हम क्या करेंगे? We need to increase the starting zeros. Let it be 0 here, at least 1 here. और यहाँ पे भी पहले 1 लाते, then we will increase the third also. So first let's target these two. And to target these two, what I have to do is R2, 2 minus 2 into 1. R2 should be R2 minus 2 R1. And 1 minus 1. R3 equal to R3 minus R1. R3 equal to R3 minus R1. ये करना है हमें, ठीक है? At least this is to be done. Clear? At least this is to be done. R2 is R2 minus 2 R1. R3 is R3 minus R1. Okay, let us do this much. Okay, let us do this much. Then what is next? Let us do this much. And then what is next? What is next? Okay, 2 minus 2 into 1, 0. Okay, 1 minus 1, 0. Okay, but पूरे रो पे apply करेंगे. Now, if you apply to the entire rows, what is going to be A is to B, dear? Okay, first row I'm not disturbing. So 1, 2, 1, 6. Next is 2 minus 2 into 1, 0. 1 minus 4, minus 3. 2 minus 2, okay, 0. Okay, 6 minus 6, 6 minus twice of 6, minus 6. R3 minus R1, straightforward. Okay. 1 minus 1, 0. 1 minus 2, minus 1. 1 minus 1, again 0. Okay, 5 minus 6, minus 1. Okay, now what is the starting zeros? Okay, m is 0. Okay, now I have m equal to 1. First starting 0 and still m equal to 1. Okay, abhi ye dono same hai. So what is my next activity, dear? What is my next activity? What is my next activity? So many of you are coming up with the answer, that is no solution. Okay, what is the activity? Okay, we have to increase the zeros here. Okay, we have to increase the zeros here. That means one more 0 to be brought. And to bring one more 0, dekho. This is 3. Idea is multiply by 1 by 3. Idea is to multiply by 1 by 3. Okay, minus 3 into 1 by 3, minus 1 hoga. And then you can subtract. So multiply it by 1 by 3. So what I'm going to do is, R3 will be now replaced as R3 minus R2 by 3. Okay, R2 ko divide by 3 karenge hum. Okay, and then what is the matrix that is going to come up for you? What is the matrix that is going to come up for you is 1, 2, 1, 6. Okay, 0 minus 3, 0. 0 minus 6. Okay. Okay, 0 minus 0, that remains to be 0. R3 minus R2 by 3. Okay. Minus 1 minus 3 by 3, so minus 1 ho jayega. Both will be subtracted 0. 0 minus 0 anyways, this is 0. Last element. Minus 1 minus 6, देखो 6 by 3 किया, minus 2. Okay, minus 1 minus of minus 2, plus 1 हो जाएगा. This is plus 1. This is plus 1. Now how many starting zeros? Okay, sir, 0. How many starting zeros? 1. How many starting zeros? 3. Here it is straightforward 3. Now A is a part of A is to B. A is a part of A is to B. Okay. Okay, yes, Govind Rao, उस पे भी आएंगे. A is a part of A is to B. So dear, first of all, I want to ask you, what is the rank of A? Whatever operations applied on A into A is to B is applied on A. Okay, what is the rank of A? Rank of A is number of, भाई बाबा increasing order आ गया, echelon form है. So rank of A is number of non-zero rows of A. How many non-zero rows of A? This part is A, dear. This part is A. How many non-zero rows within A? 1 and 2. ये third row 0 हो गया. Third row is 0. So how many non-zero rows of A? It is 2. ठीक है. Then what is the rank of A is to B? Number of, same echelon method जो अभी study किया था ना. Number of non-zero rows of A is to B. Now A is to B, complete matrix में how many non-zero rows? Complete matrix mein, this is non-zero, and even this is non-zero, dear, because if a single element is non-zero, the row is said to be non-zero. Okay, so you have three non-zero, all three non-zero. If you talk about the bigger matrix, A is to B, all three are non-zero. That simply means what? This simply means that, okay, RA does not equal to RA is to B, and in such a case, there is no solution. In such a case, there is no solution. In such a case, there is no solution. Okay. Now, let us look at no solution condition. Let us look the no solution condition. Okay. Answer is no solution. Chalo, clear. Now, shortcut I am telling you, na. Shortcut. This takes time. This takes time. It's not difficult, but takes time. Okay. Okay. नहीं, rank of A is to be 2 कैसे आ रहा है प्रभांजन? It is coming to be 3 ना? The third row is non-zero and it is in the echelon form clearly. So rank is 2 only. Rank is 2. Rank was 3 only. For A is to B it is 3. For A it is 2. Not equal. Not equal means no solution. Okay. Na Prabhanjan. Now you are doing. I'll tell you what you are doing. Tell me. You are doing R3 6R1. Na. R3 has to be related with R3. Transformation is applied on R3. Why? For R3 you have to somehow use R3. Okay, you have to somehow use R3. ठीक है. अच्छा चलो, even if you do so, number one, that operation is wrong. R3 should involve R3 calculation. Now, even if you do so, Prabhanjan, okay, what you are doing is 6R1 minus R2, na ध्यान देना, 6R1, okay, minus R2, this will be 1, na? Here itself you make 1. Here itself you make 1. Okay, even if you do 6R1 minus R3, okay, Prabhanjan, here you make 1, na? Here you make 1. You spoil the echelon form. You spoil the echelon form. Got it? You are trying to convert this 0, but this becomes non-zero. ये ध्यान रखना है आपको. So you lose the echelon form. You make this 0, but you make this non-zero. The echelon form is gone, na? Be very careful. Okay. Some zeros already you introduced. That should not be spoiled. ठीक है. अब आते हैं shortcut पे. Baba, shortcut is, okay, say this is equation 1, equation 2, equation 3. What I am going to do is, okay, to understand the shortcut, guys, let us do one thing. Add equation number 1 and 2. Yeah, add equation 1 and 2. So, dear, if you add equation 1 and 2, okay, x plus 2x is 3x, 2y plus y is 3y, z plus 2z is 3z, and that should be equal to 6 and 6, and that is equal to the 12. That is equal to the 12. Okay, so what is going to be the x plus y plus z? 12 by 3, it is 4. 12 by 3, it is equal to 4. आएगा जय, उस पे भी आएंगे. 12 by 3 equal to the 4. Okay. Equation number 3 क्या बोलता है? Same system, but the third person is telling that x plus y plus z is 5. Okay. X plus y plus z equal to 5. X plus y plus z equal to 5. आप बोलिए. बोलिए. What is the condition here now? What is the condition? Okay, that is what is a contradiction. Okay, first and 2, 1 and 2 combine and they tell, x plus y plus z 4 होना चाहिए. But third, somebody else tell x plus y plus z 5. They don't agree to each other. They don't agree to each other, and that is known as contradiction, Baba. This is known as contradiction. Clear, everybody? Okay, contradiction, fight. They don't agree to each other. They don't agree to each other, and if they don't agree, here it will be plain, not line, Jashwant, because it is 3D. But yeah, your idea is correct. They don't agree to each other. And they cannot solve, and they cannot give you a common value. Can you have any value of x, y, z so that their sum is 4 and 5 simultaneously? 4 और 5 साथ में कैसे हो सकता है? You may have the solution 1 plus 1 plus 2. You may have the solution 1 plus 1 plus 2. But 5 नहीं होगा फिर. Third, simultaneously we have to solve those values of x, y, z which satisfy all three, and they cannot satisfy all three. They can either satisfy 1, 2 or they can satisfy 3. सबको साथ में satisfy नहीं कर पाएंगे. No solution. Contradiction. No solution. Contradiction. No solution. Okay. No solution. Tell me that big doubt last year. No problem. Okay. ठीक है. Here, RDC gamers, when it is equation, try to check in the rows only, because we have to check the dependency between the equations. Okay, equations. Okay, how the equations are related or not related. So that is why you check with the equations here. Okay. अब देखो, what about unique what about infinite solution? वो भी बताता हूँ यहाँ पे. So let me tell you one thing. if I add this tricks na, number one, unique solution trick to already known hai. Unique solution is very simple. No rank required anyways. Mod A not equal to 0. Okay. Then no solution ka bhi maine bata diya. What is the no solution technique? No solution you have when you have contradictory equations. Okay, when you have contradictory equations, and the next case left is infinite solutions. Infinite solutions. I'll tell you the shortcut for. See, these actually can be explained. RLS, we'll see more problems to apply that. Okay. Okay. Batate, let me complete and then take up the doubts, guys. There are 2-3 cases more, and then you ask your doubt. Now, all of these has geometrical proof, but I'm telling you the conclusion. I'm telling you, na, within this revision, we need to compare, maximum topics of maths. To derivation pe jayenge, to things will be lost. But yeah, the following system of equation is given to you. There are 3 equations. Find the value of lambda and mu. There are 2 unknowns, lambda and mu, for which the system has unique solution. The number 1 is directly solvable. Number 1, unique solution, directly solvable. Bhai, unique is very quick. Okay, for unique, what you need to do is, chalo, yahan pe solve karte hain, it would be better. Okay, number 1, unique if you want to take, that is very simple because it only involves a determinant calculation and you want mod A not equal to 0. Okay, mod A. Okay, that is 1, 1, 1. First row 1, 1, 1. Then 1, 4, 6. Second row 1, 4, 6. Third is 1, 4 lambda. 1, 4 lambda. Okay, ab dekho, this is required not equal to 0. So 1 into 4 lambda minus 24 minus 1 into lambda minus 6 plus of 4 minus 4 not equal to 0. Okay. 4 lambda minus 24 minus lambda plus 6 plus 0 not equal to 0. 4 lambda minus lambda is 3 lambda and 24 minus 6 yahan pe aa jayega not equal to 18. So guys, condition lambda not equal to 6. So answer for unique solution. How do you frame the answer for unique solution? Question पूछा है lambda and mu दोनों पे. Okay, lambda and mu दोनों पे. Right. So answer for unique solution is lambda can take any value except 6. But what about mu? What about mu? There is no condition required on mu. Okay, so mu, okay, can take any value. Mu can take any value. We like it like this also. Mu can take any real value. It belongs to the set of real numbers. This is the symbol for belonging to, na? It belongs to the set of real number. Mu belongs to the set of real numbers. R for real. Okay. That is the answer. That is the answer. Okay. Now, infinite and no solution की बात करेंगे. Infinite and no solution. Infinite and no solution. Infinite and no solution. Infinite and no solution की बात करेंगे. Okay. Now, no solution already I explained contradiction. Look into the second and third equation. Look into the second and third equation. X plus 4y, X plus 4y. इतना common है. X plus 4y, Xy plus 4y is there. Okay. ये lambda देखना है. Suppose I make lambda equal to 6. Just playing with the numbers. Okay. Suppose I make lambda equal to 6. So left hand side and left hand side of both the equations is same. Left hand side of both the equations is same. Okay. If I make lambda equal to 6. Okay. So I have X plus 4y plus 6z equal to 20. X plus 4y plus 6z, lambda को 6 रख दिया है, plus 6z equal to the mu. Okay, if I take lambda equal to 6, that is my first trial. So left hand side is equal. But suppose right hand sides are not equal. तो यहाँ पे, okay, if I take now mu not equal to 20, then what is going to happen? Again a fight happens. By second equation says that x plus y plus 4z should be 20 and third says that x plus 4y plus 6z should not be 20, not equal to 20. So they are fighting each other. If mu not equal to 20, so I can say that equation number 2 and equation number 3, they become contradictory to each other. there is a contradiction. They don't agree to each other. And when equations don't agree to each other, they cannot solve and give you a common value. No? They cannot solve you and give you a common value. It is going to be the case of no solution. It is going to be the case of no solution. Okay. Now, what about infinite solution? Dekho, let me take one more simple example. Suppose I tell you, two variable pe agar le, x plus y is equal to 5, and then I tell you, 5x plus 5y equal to 25. Okay, will you get unique solution here? I tell you x plus y equal to 5, and then I tell you 3x plus 3y is equal to 18. Will you get unique solution here? Normally what you think, yeah, repeating that part. Okay guys, let me complete and then एक बार मैं doubts लेते हैं linear system of equation के. Normally what we think, two variable, two equations. We can solve and get the answer. Okay, so have a look into this. X plus y is 5. That is one equation. 5x plus 5y is 25. Do you get any additional information, Baba? From the equation number 2, do you get any additional information? Do you get any additional information from equation number 2? If you already know x plus 5 is 5, okay, 5x plus 5y will be already 25. If I have told you x plus y is 5, so multiply it by 5, everybody, even a child can write 5x plus 5y is 25. That you can automatically write, na? There is no additional information given. You think there are two information. No, there is only one information. So basically, there is only, what is this equation? These are the informations between x and y. So there is basically only one information. Okay, there is only one information, and the information is x plus y equal to 5. Sum of two numbers should be 5. Sum of the two numbers is 5. Okay, now how can the sum of two numbers be 5? Dear 0 plus 5, dear 1 plus 4, dear 2 plus 3. And not only like this, it can be 10 plus minus 5. It can be 100 plus minus 95. It can be anything, na? I tell you sum of two numbers is 5. Okay, how many possibilities, etc., etc., etc. You have infinite solutions basically. You keep forming, you can never stop. There can be infinite cases where you have sum of two numbers equal to 5. Both positive, one negative. You can take fractionals also. Abhi to maine integer liya, anything, na? So you have infinite possibilities. Clear? Now, there is the infinite possibilities. Okay, there is the infinite possibilities when the equations are dependent on each other. Okay, infinite solution is coming in the case of dependent equations. Dhyan rakhna. It is coming in the case of dependent equation. Equation number 2 is 5 times the equation number 1. Yahi to hai. Equation 2 is 5 times the equation number 1. They are dependent. So whenever dependency is there, infinite solution. Whenever dependency is there, infinite solution. Ab ye wale case pe aa jayenge. Okay, again let me call it as 1 and 2. Equation 1 and equation number 2. Now dear, I have been given equation number 1. There is a information which says that x plus y is 5, and when I multiply it by 3, 3x plus 3y should be 15, not equal to 18. So then there is what condition here? Okay, then there is what condition here? Rank, same, Echelon form, Jay. And what you are going to get, rank of A equal to rank of A is to B, but less than n. Okay, 3x plus 3y is 15, not equal to 18. Okay, that means what happens here again? Equation number 2 says that x plus y, 3x plus 3y 18 hona chahiye, but first says that 3x plus 3y 15 hona chahiye. There is a contradiction. Okay, there is a contradiction. No solution. They will never solve and no solution will be there. You cannot find any numbers. You can think like this also. If you take equation 2, x plus y is how much? 18 by 3, 6. As per equation number 2, x plus y is 6. So, Baba, x plus y can be either 5 or either 6, na? Okay, so they do not match each other. There is no solution. There is no solution. So, contradiction is no solution. Dependency means infinite solution. So, infinite solution means you will have dependent equations. You will have dependent equations, and that means if I go to that same lambda mu problem, listen to me carefully. Okay, I already say lambda is 6. I assume, suppose lambda is 6, so that the left hand sides are equal. And even if you make mu equal to 20, now next condition, dear, even if you make mu equal to 20, exactly equal to 20, then what will happen? Equation number 3 is directly equation number 2. That means you have only two information. You have only two information. This is lost. But this is same as equation number 2. For 3 variables, you have only two information. Only 2 information. You will get multiple solution. Whenever there is dependency, you will get infinite solution. Okay, so there is a dependency. 3 equal to 2. Okay, there is a dependency. And whenever there is a dependency in the equation, always 100%. See guys, as a homework, you want, try Echelon form on this. You will get the same answer. That for mu equal to 20 and lambda equal to 6, system will have infinite solution, but not required. I'm not going for it because this is how you can deal with the problem simply. But on the same hand, let me repeat once again, lambda is 6. Okay, lambda is 6. Okay, these two are equal. Okay, equation says that x plus 4y plus 6z should be 20, but equation number 3 says that x plus 4y plus 6z is not equal to 20. Agar mu not equal to 20 hai, to see, isn't it contradiction? Now everybody see once again. X plus 4y plus 6z 20. X plus 4y plus 6z not 20. They are clearly opposite each other. Ek bol raha hai 20, ek bol raha hai 20. Nahi hoga. They are fighting. That is contradiction. Contradiction. No solution. Contradiction. No solution. So you have all your answers, I guess now. With a very simple technique, you have all your answers. Okay, even with the unique wala, very simple. Okay, and if this is settled into mind, let's try one more. Yeah, can you tell me? This is only on infinite solution. Unique to bata diya tha na Manasvi. Mod A not equal to 0. The given system of equations has unique solution if A equal to what? Again, if you go with rank method, it'll take time. You can go, nobody stops. But can you try with the dependency? It's going to be solved in seconds if you try dependency. These are the answers, na Gitika? Acha, if you want to write down proper answers, chalo, I'll write down the answers. So what is the answer for unique solution? Unique solution means lambda not equal to 6, mu can take any real value. What is the answer for infinite solution? Infinite solution means lambda should be 6 and mu should be 20. This is the answer for infinite solution. I'll conclude it like this. And for no solution, lambda equal to 6 but mu any value other than 20. Mu any value other than 20. Any value other than 20. Clear? Okay. That is the proper answers. Tell me. We need infinite solutions and that can be possible if A is how much? Okay. Dekho, I have a motivation here. Motivation here is 1 plus 5 equal to 6. That is my motivating point. I am getting the motivation ki right hand sides are added. 1 plus 5 gives me 6. 1 plus 5 gives me 6. So I can try. That is my motivating point. See how I think, how I approach. Okay, my motivating point is let me try 1 plus 2 equal to 3. Because infinite solutions ke liye I need a dependency. I need a dependency and for that I am trying 1 plus 2 equal to 3 because right hand sides are clearly matching. Okay, so if you try 1 plus 2 equal to 3. So x ka coefficient 1 plus a should be 5. That gives a equal to 4. Okay, but it should match with every term. Just don't blindly say a is 4. Yahan se blindly nahi bolenge. You should be careful in everything. Y coefficient 1 minus a will be 1 minus 4 minus 3. Perfect. Now it match. एक से value निकाला बाकी में match करेंगे. Z coefficient 1 plus 3 equal to a. A is 4. Correct. So everywhere 4 satisfies. So that means if I take A4, I clearly prove 1 plus 2 equal to 3. There is a dependency, infinite solution. Answer is A. फटाफट से solve हो गया. Within few seconds solve हो गया. Within few seconds I am able to solve it. Everybody, within the few seconds I am able to solve it. Okay, within the few seconds I am able to solve it. Okay. Chalo, cool. Very cool. Very cool. Very cool. And I think we have crossed the 300 likes also. Great, guys. Great going. Great motivation. Okay, share the session. Let's make it 250 plus watching, guys. Come on. Okay. Okay. Mod A written equal to 0. अच्छा कुछ typo error हुआ है क्या? Let me see that. Oh. So that's a typo error, guys. I've already explained with the problem. Unique means mod A not equal to 0. Very clear. Even same thing I applied to the problem, not equal to 0. That was just a typo error. Thanks for the correction, Lajashin. Thank you. So now, one more thing I need to tell you here. Okay. Normally, if there are three variables, we need three equations. Okay. For n variables, okay. To solve for n variables, normally what we need n informations. Okay, we need n informations. Informations means equations. Every equation is nothing but an information. We need n equations, correct? And whenever you have n variable and n equation, you were getting the matrix A, which is n cross n, correct? The matrix A was n cross n, like 3 cross 3. Now listen to next point. Okay. If you have, there are n variables, listen to me. If there are n variables and m equations m hai, number of variables n hai, they're not equal. Okay, they're not equal. Okay. Kabir, it should be on the app. Just check it out. Okay. If n variables and m equations, okay, with the first condition that m is less than n, that means you have the number of equations less than what you require. Okay, such a system will be, first of all, you can note down, known as underdetermined. This is known as an underdetermined system. Okay, and in the next case, you may have m greater than n over information. You need only n informations, you are given more than that. Such a system is overdetermined. Okay, acha, in each case, what is the size of the matrix A? Okay, underdetermined or overdetermined, whatever it is. Okay, how many rows depends on how many equations are there. For every equation, you have one row. So how many equations? M equations. Okay, cross, how many variables? N. So matrix A will be of the size m cross n. The general size of the matrix is m cross n. Okay, basically you can say that number of equations cross number of variables. Okay, number of equations cross number of variables. But if there are less equations, underdetermined. If there are more equations, overdetermined. Okay? Yes, Jashwant. Okay. Yes, Amrinder, marathon sessions for aptitude taken on the app last Sunday and Monday. But don't worry, I'm planning something on for YouTube community also. So very soon I will announce that. Very soon in the next, 4 or 5 days, I'm planning something for aptitude. Okay, in a different format. Okay, as a fast track revision. On the YouTube. Chalo. Now have a look into this question, dear. Have a look into this question. Okay. Given a system of equations, x plus 2y plus 2z is b1, 5x plus y plus 3z equal to b2. X plus 2y plus 2z is b1, 5x plus y plus 3z equal to b2. Which of the following is true regarding its solution? Which of the following is true regarding the solution? Bataiye. So first of all, please see. Okay, you have 3 variables but only 2 equations. Underdetermined it is. Determined. I think यहाँ पे भी spelling error किया क्या? Undetermined नहीं है, underdetermined है. It goes wrong. Underdetermined. Under and over determined. ठीक है? हाँ जी. Last year I think that is going on. What was this then? What was this? You solve it in seconds. So yeah, please patience. Okay. Whatever shortcuts I will have, I will deliver. Don't worry. Okay. If I don't have, then I cannot deliver. Okay. What is this? For you, infinite solution, solve it by Rouche's method. Okay. You take time, lot of time. This is shortcut only, Baba. Seconds में solve होगा if you know that dependency. ठीक है? चलो, underdetermined system. Underdetermined system. But guys, now, whether the system is underdetermined or overdetermined, the point is Rouche's theorem is still applicable. Okay, whether under or overdetermined, Rouche's is still applicable. Okay, what I will do, I will try to make the matrix A is to B. Have a look into it. I will just try to make the matrix 1, 2, 2. Okay, 1, 2, 2 is to B1. And then I will take 5, 1, 3. I will take the 5, 1, 3 is to B2. Okay. Okay, is to B2. Okay, now if I again take it in the Echelon form, number of starting zeros nil and nil, that is same. Okay, so I need to at least get 1 0 here. To at least get 1 0 here, I start applying R2, and R2 will be R2 minus 5 R1 because 5 minus 5 can be converted to 0. And if I apply this operation, my augmented matrix, okay, is now becoming first row unchanged 1, 2, 2, B1, and then 5 minus 5, 1 minus 10, that is minus 9, 3 minus 10, that is minus 7, and B2 minus 5, B1. Okay, this is what I have. Okay, now what it has? Unique, infinite. What does it have? What does it have? So dekho, now you can clearly say that, okay, number of starting zeros are in your increasing order. There is no starting zero in the first row, but there is a starting zero, and now there is one starting zero in the second row. So there is increasing order. There is no ROZ. Okay, but there are starting zeros in the increasing order. That means you have got the Echelon form. And dear, both A is to B and A, both are in the Echelon form. Whatever operations you apply for A is to B, same applies to A, like the previous problems. Okay, so if it is in the Echelon form, what is the rank of A? Number of, look into this, number of non-zero rows. Number of non-zero rows 2 hai. Okay. What is the rank of A is to B? Number of non-zero rows of A is to B, that is also 2. Okay, that is also 2. They are same. They are same. Is it unique solution? Is it unique solution? Is it unique solution? Dear, very careful. RA, I told you same Rouche's theorem. RA and RA is to B is equal to N is equal to 2, but is it equal to number of variables? अब देखो आप में से कई लोग यूनिक बोल रहे हैं. Trap. Both the ranks are equal. I agree, equal to 2, but it is less than the number of variables. I told you to compare with the number of variables. Here there are 3 variables. N is the number of variables clearly in the Rouche's chart mentioned. So both of them are equal, but less than number of variables. So the condition is infinite number of solutions. The condition is infinite. Correct answer B, not A. Okay, not A. Okay. No, Naruto, not exactly for you. Some of the parts will be useful, but not entirely. This is engineering maths. Future के लिए जरूर helpful होगा for future, but not exactly for your 12th. For 12th, some topics will be helpful. Okay, but for future, definitely it will be helpful for you. ठीक है जी, चलो. So correct answer is B. Everybody, I think, agreed. Correct answer is B. And now, next one. Chalo guys, now let me give you one homework. This is one homework. X, Y, Z. Okay, X, Y, Z. There are 3 variables. Okay, yes, Vignesh will plan that. Okay, X, Y, Z. There are 3 variables, but there are 4 equations. So I call this system as overdetermined. Okay, so one homework for you. The number of solutions. Same method, Rouche's theorem. I told you whether it is under or over. Under or over. Parth, टाइम निकालना पड़ेगा, इजी तो हो जाएगा. ओके. Yes, for underdetermined unique solution never possible. That means underdetermined, very correct mark. Unique solution never possible for underdetermined at least. Over में हो सकता है. Okay, under में I will mention this point. It's actually a good point. Underdetermined में unique solution not possible. Okay, so it may be infinite or no, but in underdetermined unique not possible. It may be possible in over. Okay, ठीक है, ठीक है, चलो जी, correct. So correct analysis mark. Unique solution not possible because last row is always zero, na, one row is missing. देखो, for rank Govindrao they are applicable column operations, but I told you clearly when you are solving equation, linear system of equation, don't think about column, because you know why we are thinking about rows, because it is about equations. We need to try solve equation, and where is every equation? See, like there are two rows. This first row is what? This is first equation. This is second equation. So we need to learn equations. So that is why rows will matter here. Okay. Rows will matter here. Manohar, I told you na. Sometimes there may be dependency जो आपको directly नहीं दिख रहा है. जो आपको directly नहीं दिख रहा है. There may be any numbers like 5 times या 5.7 into this plus 2.7 into this. Okay, that can be figured out. Okay, that can be figured out, but not required. Na? That is not required. That is not required. Sometimes the relations may be complicated, so you don't need to worry about them. चलो आते हैं. Okay, and one homework I have given you. Why I am giving as homework? Because the method remains to be same. Okay, break दूंगा बीच में, but not exactly right now. Now let's come to the homogeneous system of equation. So when I talked about AX equal to B, this was non-homogeneous. We started with non-homogeneous system of equation. But if you take the matrix B to be a null matrix, okay, a null matrix, then you get AX equal to null. Okay, and that is known as the homogeneous system of equation. Okay, homogeneous. Then it is no solution, na, Amrender. Okay. AX equal to null. Okay, if B is the null matrix, AX equal to null makes it a homogeneous system of equation. Okay, that means null means what? See, what was B? B means the right side constant matrix, and null matrix means all elements 0. So all the right side elements are 0. Okay, all the right side elements are 0. Okay, such a system is null, is a homogeneous system. Now, one very important thing about homogeneous system. Dekho dear. Whatever may be the coefficient, 1, 1, 1, 2, 1, 3, etc. 1, 1, 1, 2, 1, 3, etc. Okay, when you multiply, when you take x, y, z all 0. By what is the solution of a system? Solution means the values of x, y, z which satisfy all the three equations. So let's try 0, 0, 0. So a1, 0, a1, 0, a1, 0 equal to 0. Try in the second. Okay, a21 into 0 plus a22 0 plus a23. Anything into 0 is 0. 0. Similarly, it is applicable for. So without even looking into the numbers, blindly, okay, I can say that 0, 0, 0 is always a solution. That is one pattern about homogeneous system you should remember. 0, 0, 0 is always a solution. Clear, everybody? 0, 0, 0 is always a solution. 0, 0, 0 is always a solution. Okay, but is that solution giving you any information about the system? Is that solution giving you any information about the system? Now let me add on one more point here. Let's look into this example. Now let me bring on some numbers. Okay, x plus 2y minus 3z is 0, x minus y is 0, 2x minus 4y plus 2z equal to 0. Once again, 0 plus 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 plus 0 is everything 0, na? Is everything 0. So here also 0, 0, 0, okay, is a solution. Independent, whatever homogeneous system I gave, okay, Jashwant, it will be unique. Whatever, homogeneous system I gave, 0, 0, 0 is always a solution. It is always a solution. Undoubtedly. But that solution is independent of the system. I mean, it is something which is not giving you any information about the system. The reason is, dear, when you take 0, 0, 0, na, okay, that means what is the vector x? Vector x itself is 0, okay, and you are talking about ax equal to null, you are talking about ax equal to 0, so a into 0 is 0 always. So Baba, whatever may be the system, whatever may be the matrix, uska role hi nahi hai. It's like you apply 0 input and you get 0 output. You get 0 input, you apply 0 input, you get 0 output. It's like meaningless theory, yaar. Ye to bachpan se pata hai. Anything into 0 is 0. Anything into 0 is 0. That is what we know from childhood. Such a case when 0, 0, 0 is the only solution, dear, for a system which has 0, 0, 0 as the only solution, as the only solution, then it is known to have trivial solution. Trivial is something which is not very meaningful. Meaningless bolenge. Not giving you any additional information about the system. It is meaningless information. It is a meaningless discussion. A into 0 is 0. ये discuss करने थोड़ा ना है यहाँ पे. You already know this. Okay. Are you getting it? So when a system has only one solution, that is 0, 0, 0. When a system has only one solution, that is 0, 0, 0. Then it is said to have trivial solution. Then it is said to have trivial solution. Okay, if 0, 0, 0 is the only possible solution, then it is said to have trivial solution. So one thing I can say you, I am telling you that 0, 0, 0 is the only possible solution. Only possible means I am also telling you one thing, that system has unique solution. When the system has only one solution means unique solution. So I am also telling you that this system has unique solution. And when the system will have unique solution, when the determinant equal to 0, because when the determinant not equal to 0, because for unique solution that is what you need, na, determinant not equal to 0. Determinant not equal to 0, that is what you need. Okay, that is what you need. Okay, determinant not equal to 0 for unique solution. Right, everybody? Determinant not equal to 0 for the unique solution. For the unique solution. ठीक है, done है, ये हो गया. I think clear. Okay, clear. ठीक है. So, whenever determinant not equal to 0, the system will have trivial solution. Means 0, 0, 0 is the only possible solution. Okay, next aate. Okay, so I told you, this is always a solution. Okay, x equal to null is always a solution. Okay, now, look into this system. Here also 0, 0, 0 will exist. Here also 0, 0, 0 will exist. Okay, but now, here, these equations are intentionally framed by me so that you understand some clear relations. Okay, intentionally I have taken simple numbers. Now, try it here, 1, 1, 1. Everybody, please try now 1, 1, 1. Please try 1, 1, 1. Okay, look into it. 1, 1, 1. 1 plus 2 minus 3. 0, correct. 1 minus 1, correct. 2 minus 4 plus 2. Everything is 1, na? X, Y, Z 1. So, यहाँ पे मिला 2 minus 4 plus 2, 0. Satisfied. 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 So, 1, 1, 1 is also a solution. Okay. So I can say that here 1, 1, 1 is also a solution. Let me complete, guys, for any doubts. थोड़ा सा समझ लेंगे अभी. There are many things related. Let me complete first. So here 1, 1, 1 is also a solution. Okay. So will this system is said to have trivial solution? No. Trivial means unique. When 0, 0, 0 is the only solution. See, this is always there. But if this is the only person existing in the system, then such a system is trivial. Okay. But here there are more than one solution. Definitely, ye to always there, but more than one solution. And I told you, more than one means always infinity. Okay, more than one. Whenever any system has more than one solution, it will always have infinite solution. It will have always infinite solution. दिखाऊं कैसे? दिखाऊं? ये देखो. It will always have infinite solution. ये देखिए. Okay. So 2, 2, 2. If 1, 1, 1 is a solution, na? 2, 2, 2. Baba, try 2, 2, 2. 2 plus 4 minus 6 will satisfy. 2 minus 2 satisfied. 2 2s are 4, 4 2s are 8, 2 2s are 4. 4 minus 8 plus 4 satisfied. Satisfied. So 2, 2, 2 be satisfy karega. Not only 2, 2, 2. Okay. Try 5, 5, 5. Okay. This will be solution, etc. etc. The simple reason is, dear, Ax equal to 0. If x is a solution, even if you take a into kx any times, if x is a solution, now you take kx, k is a constant outside, so that becomes k into ax. Okay, that becomes k into 0. Ax to 0 hai na? That becomes k into 0. That is also 0. So if x is a solution, then k into x is also a solution. Very simple. So that is why, right, 2 times this solution, 5 times this solution, 100 times this solution. Agar isko x liya, to this is 2x, 5x, anything you can take, that is also a solution. That is also a solution. That is why the system is said to have infinite solution. Okay. And for infinite solution, now here we don't need any rank. Why I don't need any rank? Number one thing I told you, there is always a solution. There is always a solution. So will there be the condition of no solution? In the homogeneous system of equation, will you have no solution condition? Not possible. Na? One solution always existing. One solution always. No matlab not at all, no solution. But one solution always there, independent of the numbers. Independent of the numbers. So there is no possibility of no solution. So either unique or infinite. So what is the condition for unique? I told you. Unique matlab trivial here. And if it is not unique, it is infinite. और कुछ बचेगा ही नहीं. If it is not unique, it will be infinite only. Okay, so what is the condition for non-trivial solution? Opposite to it. Mod A equal to 0 because there is nothing else left. Either unique or infinite, no solution नहीं हो सकता है. ठीक है? So if there are some non-zero values, like I took 1, 1, 1. If there are some non-zero values of x, y, z which satisfies the equation, which satisfies the system, then the system is said to have non-trivial solution. Which satisfies the system. If there are some non-zero values of x, y, z which satisfies the system, then the system is said to have non-trivial solution. So very clearly guys, in homogeneous system of equation, you will never use and you never need what? You never need what? You never need ranks. I mean to say you never need rank. It is just solvable by a determinant problem. It is just solvable by a determinant problem. So have a look into this flowchart once again. You are solving Ax equal to null, homogeneous system of equation. You are solving homogeneous system of equation. Okay? Whenever determinant not equal to 0, rank will be equal to n. Whenever determinant not equal to 0, rank will be equal to n. Okay, and system will have unique solution. I told you, don't focus on rank. Let's focus on the conclusion. Determinant not equal to 0, unique. Unique matlab trivial. Okay, x, y, z equal to 0, only solution. Mod A equal to 0, just now I told you, mod A equal to 0, non-trivial. Okay, non-trivial means infinite solution. Mod A equal to 0 means non-trivial or infinite solution. Then, okay, there are n minus r independent solution. Okay, we are not deriving it, but please note down. Okay, if there are non-zero and non-trivial solutions, there will be n minus r independent solutions. Okay, where n is the number of variables, r is the rank of the matrix. Let me explain this actually. What is this n minus r independent solution? Look into it. I am telling you there are infinite solutions here. I am telling you there are infinite solutions here. Okay. What is the value of rank of the matrix A? Let me form the matrix A, dear. What is the matrix A here? 1, 2, minus 3. Then 1, minus 1. Z 0 hai second wale mein. And 2, minus 4 and 2. 2, minus 4 and 2. Okay. What is the rank of this matrix? What is the rank of this matrix? Let us see. What is the rank of this matrix? What is the rank of this matrix? Can you say the rank of this matrix? Acha, to say the rank of the matrix, you can check the determinant also. What is the determinant? Chalo, ek baar mein nikal lete hain. 1, minus 2, minus 0, minus 2, 2 minus 0, cross multiply, and then this is minus 3, minus 4, minus plus 2 ho gaya. Okay, so this is equal to minus 2, 2 2s are 4, minus 4, minus 2 into minus 3 plus 6, and this is equal to 0. Minus 2, minus 4 plus 6. Mod A equal to 0. What is the value of mod A? That is equal to 0. What is the value of mod A? That is equal to 0. What is the value of mod A? And that is equal to what? That is equal to the 0. Clear, everybody? What is the value of mod A? And that is equal to the 0. That is equal to 0. Acha, if mod A equal to 0, that is the reason you should have non-trivial solution. Yahi maine bola na. Mod A equal to 0, you should have non-trivial solution. You should have non-trivial solution. Already I explained you. Infinite means non-trivial. Infinite means non-trivial. In homogeneous, infinite solution means non-trivial. That already we have proved by the basic logic. Okay. So, non-trivial solution, mod A equal to 0. Now, if mod A equal to 0, how many independent solutions? So, how many independent solutions, dear, tell me? What is the number of independent solutions? I told you the number of independent solutions is given by the formula n minus r. Okay, n minus rank of a matrix A. Now, what is n? Number of variables. 3 variable case hai? 3 variable case. What is the rank of the matrix A? Now, determinant to 0 hai. Acha, determinant to 0 hai. That means rank cannot be 3. Square matrix, 0 determinant, rank cannot be 3. But if I take any 2 cross 2 minor, minus 1, minus 2. Okay. 1, 2, 1, minus 1. If you check, this is non-zero. Okay, so rank equal to 2. There is one non-zero minor of order 2, the rank will be 2. There is one non-zero minor of order 2, the rank will be equal to 2. Okay, so that is 3 minus how much? The rank is 2. So how many independent solution? 1. How many independent solution? 1. So that means ये जो solution है ना, this is going to be the one and only independent non-zero solution. All other solutions are dependent on it. यही तो हुआ. All other solutions are dependent on it. So this particular solution, okay, is the only independent solution. Is the only independent solution. This is the only independent solution. Others are dependent. Others are dependent, like k into x. So if this is x, okay, this is 2x. This is 5x, 10x, 100x, anything. So there will be only one independent non-zero solution, others will be dependent. Okay. So there can be multiple things जो यहाँ पे पूछ सकते हैं वो. Okay, कि whether it is trivial or non-trivial. Okay, if it has non-trivial solution, so how many independent solutions? So there are n minus r independent solution. N is the number of variable. R is known as the rank of the matrix A. R is known as the rank of the matrix A. Okay. R is known as the rank of the matrix A. Now one more important point here. Everybody focus. One more important concept. अब concept ये है कि I have a matrix A. Okay, let me rewrite this matrix. What is the matrix? 1, 2, minus 3. 1, minus 1, 0. And then 2, minus 4 and 2. I have a matrix. Okay, and I take x equal to, what is the solution I have obtained? 1, 1, 1. Okay, what is one of the solution I have taken? 1, 1, 1. इसकी बात करते हैं. Okay, I have 1, 1, 1. Okay. When I multiply this by matrix A, listen to me very carefully. First, let me complete. When I multiply these two, A into X, because this is a solution, I told you, when you try 1, 1, 1, all the equations are satisfied and you get 0, 0, 0 on the right side. Okay, you get 0, 0, 0 in the right side. 0, 0, 0 in the right side. So when you multiply these two, then the answer is 0. Okay, then the answer is 0. Guys, a humble request. Okay, even if you comment right now, you ask the doubt right now, I don't mind. But that doubt will go away. Let me complete, I will allow you to ask doubt. If you keep asking right now, I will not be able to stop in between. Now let me complete in a flow. अगर मैं हर second पे stop करूंगा तो rhythm will be breaked. So even if you comment right now, no problem for me. But that comment will go above. Comment miss हो जाएगा. So I'll allow you for doubts. Wait for a few minutes. Okay. देखो. So then I have ax equal to 0. Then I have ax equal to 0. So x is a vector. Listen to me carefully now. X is a vector which when multiplied by A converts into a null matrix. Okay. X when multiplied by A, this vector x when multiplied by A, okay, what is this doing? What is this guy doing? It converts the matrix A. What is the output of the system? It converts the matrix A into null. It converts the matrix A into null. Clear, everybody? It converts the matrix A into null. Such a vector, okay, such a vector which converts a matrix A into null comes under the null space of the matrix. Comes under the null space of the matrix. Okay, so this vector x, okay, will come under the next term that you need to know. Concept सारे बताऊंगा, मैंने आपको बोला था. Will come under the null space of the matrix. Okay, will come under the null space of the matrix. Null space of the matrix. Okay, so what is this null space? Now what is the complete null space? This comes under the null space. What is null space? Null space is that space. Space से मतलब होता है set in a sense. Null space is that space or that set which contains all these independent vectors, which contains all these independent vectors x, which converts a matrix A into null. Which converts a matrix A into null. Let's go through the definition. I'll come back to that point. Okay, the set of all non-zero independent vectors, okay, which converts a matrix A into a null matrix. All those independent vectors will form the null space. All those independent vectors will form the null space. the dimension of the null space is known as the nullity. The dimension of the null space is known as the nullity. Okay, so dear, with respect to this matrix, let me continue. Okay, with respect to this matrix, okay, what is going to be the null space? How many independent vectors, how many independent solutions to Ax equal to 0? Abhi maine bataya na. How many independent solutions to Ax equal to 0? Actually, there is only one independent solution. Okay, so if I ask you to write down the null space, let us say the null space is S, okay, what will the null space contain? It will only contain this vector, which is 1, 1, 1. It will only contain 1, 1, 1 transpose, because it is a column vector. No, I simply write transpose. Okay. Here you only need to write down, chalo transpose ke form mein likh deta hu, let it be like this. Okay, it contains only the vector 1, 1, 1. Okay, should I write 2, 2, 2 here? By even if I take 2, 2, 2 na, even if I take 2, 2, 2, it satisfies Ax equal to 0. Listen to me very, very carefully, that even if you take 2, 2, 2, it is a vector, it is a particular vector, which when multiplied by A, that also converts the matrix A to 0. But then there can be 5, 5, 5. Then there are so many people standing in the line. But what I told you, we will only write down the independent vectors. Us pe dependent to infinite cases honge. So we will not write down all such case. Okay. So how many non-zero independent vectors are there? So maine nikala na. How many independent solutions? Only one. Okay. So only one will come up here. Okay. Only one will come up here. Okay. Now, what is the dimension of this? Dimension of this set. I repeat again. Space means a set only. Okay, null set you can say. Null set, ये null space है ना? You can also call it as null set. अगर कोई भी confusion हो तो याद रखना, this is a null set. It is a set containing all those independent vectors which are the solution of Ax equal to 0. ठीक है? So what is the dimension? How many such independent vectors come up? Only one come up. Okay, and this dimension is known as the nullity. Sometimes you can get the question on the nullity. This dimension is known as the nullity. This dimension is known as the nullity. Everybody okay? Okay, so have a look into the definition once again. The set of all non-zero independent vectors which convert the matrix A into the null matrix, they will form the null space. Okay, and the dimension of the null space, dimension means how many vectors are coming inside it. Okay, that dimension is known as the nullity. Okay, that dimension is known as the nullity. So what is the formula for nullity? Nullity formula is this only, then n minus r independent solutions. That is the formula for nullity also. That is the formula for nullity also. So what is the nullity? L minus R. Okay, ये general है non-square matrix. If it is a square also no problem. N minus R. N is the number of variables या number of columns. Number of variables याद रख लीजिए. In short, combining these two, just remember. Nullity of A, put it as N minus R. Forget columns and etc. Earlier also I have told you what is N. What is N? Okay, number of variables. What is R? R means rank of A. Simple, बस ये याद रखिए. Okay, number of variables. Okay, 0, 0, 0 नहीं count करना ना. Look into this. The number of non-zero independent vectors. 0, 0, 0 is trivial, meaningless यार. Whatever may be the system, A into 0 is 0 ना. That is what. So उसको count नहीं करेंगे. I only want a non-zero, clearly written. I only want a non-zero, clearly written. I only want a non-zero. ठीक है. This is known as the nullity and null space concept. Nullity and the null space concept. So suppose say there is a question. If a 4 cross 4 matrix has rank 2, just a simple question, almost a factual question. Okay, if a 4 cross 4 matrix has rank 2, now 4 cross 4 mein what is the number of variables? Okay, number of equations cross number of variables. So this is known as n. Okay. Okay. So if it has rank 2, okay, so rank equal to 2, then it has how many independent solutions? Then it will have, okay, 4 minus 2. Okay. N minus R. How many independent solutions? 4 minus 2. Answer is C. So sometimes there can be one marker. It's like just a factual question only, dear. It is nothing but just like a factual question only. Okay, there are 2 independent solutions. There are 2 and 2 and only 2 independent solutions. There are 2 and only 2 independent solutions. बहुत ही बढ़िया. There are 2 and only 2 independent solutions. Fantastic. Let's move ahead to the next. यहाँ पे आ जाते हैं. Okay. If n cross n is a matrix in which all elements of A are 1, then the number of linearly independent solutions. Okay, then the number of linearly independent solutions in AX equal to 0. Homogeneous system of equation, number of linearly independent solution is n minus r. Okay, now n cross n matrix, n का value तो n ही लेना है यहाँ पे. All elements are 1. What is the rank of such matrix? आपको ये बताना है. All the elements of A are 1. What is the rank of such a matrix? All elements of A are 1s. What is the rank of such a matrix? A is a matrix in which all elements are 1. So dear, if all elements are 1, if all elements are 1, simply means all rows are identical. It simply means that all rows are same. All rows are nothing but identical to each other, and for any matrix where rows are identical, the rank of matrix is 1. Rank पहले पढ़ के फिर ही तो आए ना यहाँ पे. तो rank is equal to 1. Okay, so my answer is n minus 1. So my answer is answer C. बताइए, clear ना? Discuss this point in the rank. A matrix having all identical rows will rank 1 because R2 is R1, R3 is R1, R4 is R1. Every row is equal to R1. Only one independent row. Only one independent row R1. Rest all are dependent. Rest all are dependent. Clear, everybody? So these simple concepts can also be there. Okay. Now, what is the condition for non-trivial solution? Tell me the answer quickly, and now I allow you to ask the doubts, guys. Those of you who were having the doubts. Vishwanathan, what is independent solution? If 1 1 1 independent and 0 0 0 0 0 0, first of all count ही नहीं करना है non-trivial में. What I'm telling you, Vishwanathan, 0 0 0 is meaningless because you take any matrix in the world, separate 0 0 0. We are talking about something other than 0 0 0. Take any matrix in the world, multiply by 0, it will always be 0. That is meaningless argument, ना? ये तो पता ही है आपको. But is there any non-zero value? Non-zero vector which converts matrix A into null, that comes under the null space. That comes under non-trivial solution. Clear? So that is why 0 0 0 को अलग कर दीजिए. That is meaningless. That is trivial solution. Okay. चलो. Now, yeah, doubts please. Sir, if there is no independent solution, that is not possible. Akhilesh, why that is not possible? Number of independent solution is n minus r, and you say n minus n. Okay, you say n minus n. Listen to me. N minus n कब possible होगा? Okay, when there is trivial solution. Because you are taking rank equal to n. Rank equal to n, mod a not equal to 0. Mod a not equal to 0 means trivial. सोच के देखिए ना. तो trivial में तो बात ही नहीं करना independent या dependent की. We talk about dependent or independent solution, dear. ये देखिए ना. In this flow chart, यहाँ पे तो story over. There are n minus r independent solutions. We talk if there are non-zero solution. Clear? 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 Okay. Chalo. Then it's not unbounded. Unbounded means there's a difference akansha between unbounded and non-zero. Unbounded means infinity. Yes, Govind Rao. 0 0 unique means 0 0 0 is the only solution. थोड़ा और स्पेसिफाई कर दीजिए. 0 0 0 is the only solution. If 3 cross 4, then n is 4. If 3 cross 4, then n is 4. I told you, na, matrix A is written as what? Number of equations cross number of variables. I told you earlier. ठीक है? ठीक है? ठीक है? ठीक है? Okay, Anwar. So 3 cross 4, n is equal to 4. इसीलिए मैंने यहां पे लिख भी दिया. देखो, number of columns. If you don't want to remember by variables, remember it as number of columns. ठीक है ना? ये है, यहां पे लिखा हुआ है फिर भी. ठीक है? हाँ जी, come here. अच्छा, now this is a very simple question. The system should have non-trivial solution, and non-trivial solution means infinite solutions mod a equal to 0. You have to only solve mod a equal to 0. Nothing is there in the question. You have to only solve mod a equal to 0. 1 minus k 1. Okay, k 3 minus k. This determinant I am taking, and 3 1 minus 1. Determinant of this not equal to 0. Okay, so 1 minus 3 minus minus plus k. ये हो गया minus, second element we take with minus sign, तो minus minus k minus 3k. Okay, and then last element 1 and k minus 3 3s are 9. This should be equal to 0. Equal to 0 we are solving, na? ठीक है. So I have, this is like minus 3 plus k minus 3 minus minus plus This is 2k into k, so 2k square, then plus k minus 9 equal to 0. So I think we're getting a quadratic equation. So 2k square plus 2k minus 12 equal to 0. Cancel the 2 also. The k square plus k minus 6 equal to 0. K plus 3, simple factorization. K minus 2 equal to 0, leading you to the answer k equal to 2 or minus 3. 2 or minus 3. So answer should be D. Everybody, D, 2 or minus 3. Okay. Okay, 2 or minus 3. Prabhanjan. Okay, so just a second. Chalo. By that time, there is only trivial solution now. There is only trivial solution. I think now you can take this as homework. Okay, with similar type of question. Dekho, kahan gaya doubt? Okay, so when we find the rank, what using matrix, when we get magnitude of minus 0, then we should think for next minor of same order, na? Yes, yes, ideally. Okay, because even if at least one minor is non-zero, then the rank is equal to the size of that minor, na? So yeah, ideally, theoretically, yes. Okay. Then nothing, go for PYQs extra, only Govind Rao. Okay, chalo. So unique solution, yes, what you have to do is mod A not equal to 0 to be solved here. Okay, please try it out. Na? Simple determinant based question hai, yaar kar loge. There is nothing so great here. Okay, and now in the linear system of equation, dear, in the linear system of equation, we have seen two categories till now, non-homogeneous and homogeneous. Okay, first of all, we saw non-homogeneous. दोनों ही अच्छे से देख लिया है. We saw non-homogeneous system of equation in which the vector x when multiplied by a gives a constant result b. Okay, gives a constant result b. Okay, okay. Yes, you can, Adarsh. Okay. When you apply any input vector to the matrix A, to the operator A, what you get is b, some constant b. But now what we were looking, अभी हम लोग देख रहे थे homogeneous. Homogeneous, where we talked about null space also. Okay, you apply input vector x to a system or to an operator A, and that input vector x converts the matrix A into null. Okay, into null. Okay, all those independent non-zero vectors which converts the matrix into null, they come under the null space. They come under the null space. They come under the null space. Okay, so special case when AX converted to 0, that is known as the homogeneous system of equation. Okay, so listen to me now very carefully, one important word. You take some input vectors X, apply to the matrix A, apply to the linear operator A. You may get the answer as 0 or you may get the answer as B. Okay, you may get the answer as 0, you may get the answer as B. Okay, okay, answer as 0, answer as B. Oh, thank you, Manasvi. You may get the answer 0 or answer B. It produces some constant. Sometimes it converts the matrix into null. Sometimes it gives you some constant vector. Sometimes it gives you some constant vector. Clear? ठीक है. अच्छा जी. Special, super special case. Super special case. Super special case. You take an input vector x, apply to the linear operator A, and you get a result, okay, which is neither any constant or nor null. You get a vector, you get an output which is proportional to the input itself. You get an output which is proportional to the input itself. Okay, let's say this is the output produced by the system and you are getting the output lambda x which is proportional to the input. Okay, so the output produced by the system is just very similar to the input applied to it, just multiplied by, okay, just multiplied by some constant, just multiplied by some constant lambda. Okay, just multiplied by some constant lambda. So I can say that the output produced, now what is in general output? AX. If you apply x to the operator A, you get AX. And AX is proportional to x. AX is proportional to x. To remove the proportionality constant, okay, we introduce the constant of proportionality. Suppose lambda. Suppose lambda. Suppose lambda. Okay. Yeah, A is a linear transformation operator, okay? Now, all those special vectors X, these special vectors X, which produce the output similar to themselves, proportional to themselves, all those non-zero vectors x known as eigenvectors. Again guys, non-zero. Baba, again non-zero. If you again think with respect to zero, you apply zero input, you get zero output. That is meaningless talk. If you apply zero input, you get zero output. And then you can say, Arey, zero is identical to zero, so this is also eigenvector. No. Okay, that is meaningless. You apply zero input, you get zero output because A into zero is zero. So don't again talk meaningless things. Let us be meaningful. And meaningful means non-zero. So if there is any non-zero vector x for which output is proportional to itself, are known as the eigenvectors. The proportionality factor, the scaling factor, the magnitude scaling factor, the multiplication constant, जो भी बोल दीजिए, known as the eigenvalue. Okay. All those very clearly specified non-zero input vectors x for which output is parallel to or proportional to the applied input vector. Those are known as eigenvectors. And that proportionality constant, okay, that proportionality constant will be known as the corresponding eigenvalue. Right. The corresponding eigenvalue. Okay, so the next most important topic, eigenvalues, eigenvectors. Now, how to solve it up? Okay, how do you solve? Whether it is 2 cross 2 or 3 cross 3 in general. What I am telling, yahi se start kar sakte na? Okay, what is the eigenvalue eigenvector equation? This is the most important equation you need to remember. Ax equal to lambda x. Okay, so eigenvalue eigenvector relation is Ax equal to lambda x. Very, very important. Ye dhyan rakhna, because many questions are solvable only by this equation. Okay, now what I will do is, dear, very simple explanation you have. Okay, bring the lambda x to the left side. Ax minus lambda x is 0. Now I take x common. So what is left here is a. And then this is minus lambda. Now this is a minus lambda. Matrix minus number, not possible. Matrix minus number, not possible. Okay, the matrix minus matrix. So I multiply lambda by a identity matrix. Identity matrix equal to 0. Okay, so this is like a minus lambda I, suppose is b. So you have bx equal to 0. So again, what is the type of equation? I have converted this to homogeneous. इसको मैंने homogeneous जैसा बना दिया. Isn't it looking like homogeneous? And what you want? You want non-zero solutions. Okay. So what you want? Non-zero, or I can say non-trivial solution. So how do you get non-trivial solution? For homogeneous system, abhi solve करके आए. For homogeneous system, for the non-trivial solution, here it is B matrix, not A. Okay, the determinant of this matrix B should be equal to 0. The determinant of this matrix B equal to 0. Now you can put down B equal to A minus lambda I. So determinant of B means determinant of A minus lambda I equal to the 0. Determinant of A minus 0I equal to the 0. Clear? What is this known as? The very, very important equation known as, I will write down C in short. That is nothing but characteristic equation of the matrix A. Nothing but, in short, known as the characteristic equation of the matrix A. Now, roots of this characteristic equation. Now, when you solve, you get lambda. Okay, roots of the characteristic equation, okay, will be equal to lambda. So, eigenvalues, you can say one more thing about eigenvalues. Eigenvalues are nothing but known as the roots of characteristic equation. Eigenvalues are basically known as the roots of the characteristic equation. Eigenvalues are basically known as the roots of the characteristic equation. ठीक है? Known as the roots of the characteristic equation. ठीक है? Cool है? चलो. Now move ahead. They are known as the roots of the characteristic equation. Okay. So now let's talk about a 2 cross 2 matrix. Let us talk about a 2 cross 2 matrix. Oh, sorry. Now, 2 cross 2 and 3 cross 3, they are the common problems, na? Okay, they are the common category of questions. So that is why for them, what is the characteristic equation? Usko thoda simplify kar lenge. So for a 2 cross 2 matrix, dekho, anyways the characteristic equation is always modulus of a minus lambda I equal to 0. Okay, but especially for 2 cross 2, simplified characteristic equation, everybody, very important, simplified characteristic equation, lambda square minus trace into lambda plus determinant equal to 0. That one is the important characteristic equation here. Lambda square minus trace into lambda plus determinant equal to 0. Okay. Okay. Minus determinant equal to minus trace lambda plus determinant. Trace, everybody knows trace, na? Trace is sum of diagonal elements, and determinant you all know how to calculate for 2 cross 2. That makes a very simple problem to solve. Okay. Now we will take a question also. Forget, abhi ab 3 cross 3 ka bhi batata hu. Let me tell you for both and then questions together. Okay. For 3 cross 3, dekho, characteristic equation in general is always known as modulus of a minus lambda I equal to 0. But when you solve modulus of a minus lambda, you see many people solve directly mod of a minus lambda I. Okay. Many people solve directly mod of a minus lambda I. Okay, that is lengthy, na? We can directly, I'll give you the direct result. So when you solve for 3 cross 3, matrix characteristic equation, you are going to get, write down this lambda cube, because it is 3 cross 3, you will have cubic equation, lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Now, sir, what is this beta 1, beta 2, beta 3? I will explain you. What is beta 1? Beta 1 is once again the trace factor. Now, what is trace? एक बार यहाँ पे लिख देता हूँ. Trace is sum of all the diagonal elements. Trace of a matrix is nothing but all diagonal elements. Sum of all the diagonal elements. Clear, everybody? Okay. Now, what is going to be the beta 2? Kylie Hamilton पे भी आएंगे. Just wait. We will come to Kylie Hamilton also. Okay, what is going to be beta 2? Beta 2 will be known as, see, what is beta 1? Sum of the diagonal elements. Okay, diagonal elements A11, A22, A33. Okay, now beta 2 is sum of minors. Sum of minors of the diagonal elements. Sum of the minors of the diagonal element. Just remember this language. No need to remember the formula. So if you want to write down beta, I will help you here. देखो beta 2 कैसे निकालना है? This is the first diagonal element. How do you calculate minor of any element? A11 है ना? Delete the first row and first column. Okay. Remaining numbers are arranged in this determinant. A22, 23, 32, 33. Plus how much? बताइए. Plus how much? Okay, now next diagonal element is A22. So I delete the second row and second column. I get 1113. I get 1113. I get 3133. 1113, 3133. Okay. Plus what? Plus what? Next will be A33, and then the diagonal, the matrix corresponding will be A11, A12, A21, A22. See guys, I'm not asking you to remember this expression. Okay, but just remember, beta 2 is the sum of the minors of every diagonal element. Sum of the minors of the diagonal element. Okay, and then what is beta 3? Beta 3 is nothing, again determinant of A. The last term will be again determinant, modulus of A. The last term is again known as the determinant or the modulus of A. What happened, guys? Tired? Very important topic started and attendance started dropping. No problem. Important topic में गायब हो गए तो loss आपका है. If you're tired, let me know when to stop. You guys let me know when to stop if you are tired. Okay, so when you apply this, na, question really becomes simple for you. Question really becomes simple for you. ठीक है? अब आइए बताइए. Let's apply to both 2 cross 2 and 3 cross 3. चलो. Let us apply to both, and guys quickly tell me the answer for both. Quickly tell me the answer for both. Quickly tell me the answer for both. चलो जल्दी से. Come on, everybody. Yes, done है. चलो, so this must be done. ये तो simple है. Okay, so yeah, what is the characteristic equation? Directly, okay, no modulus of a minus lambda, directly lambda square minus trace. Trace is sum of diagonal elements, so 1 plus 4 into lambda plus determinant. Okay, cross multiply 1 into 4 minus 2 हो गया, so directly determinant का value लिखा. Okay, 4 minus plus 2 equal to 0. So I have lambda square minus 5 lambda plus 6 equal to 0. Factorizable, either apply the quadratic formula or you can factorize. So we have lambda minus 2 multiplied by lambda minus 3 equal to what? Equal to the 0. Okay, and lambda will be equal to 2 or 3. These are the two eigenvalues. Done hai? Simple hai. Simple and self-sufficient. Next question. Simple and self-sufficient. Next question, 3 cross 3. Okay, again, now for 3 cross 3, apply the beta 1, beta 2, beta 3 method. What is the characteristic equation? That is given by lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Alternate plus minus का ध्यान रखना है, ठीक है? Then what is the value of beta 1, dear? Beta 1 is actually sum of the diagonal elements. 1 plus 8 plus minus 3. That is a trace and that is equal to 6. What is beta 2? Sum of the minors of diagonal elements. Okay, so your first diagonal element minor will be minus 24, minus 12. Okay, minus 24, minus 12. For the second, okay, minus 3, minus 6. For the third, okay, 8 minus 8. Third wala 0 ho gaya, but beta 2 overall minus 36 and minus 9, minus 45, and then eventually beta 3 is known as dot. That is the determinant of the matrix. So what is the determinant? You calculate normally also it will be 0. You even calculate normally determinant will be 0. Okay, by the formula, or even if you see 1 plus 1, 2, 4 plus 4, 8, 6 plus minus 3 is 3. Okay, why the determinant is 0? Because I am able to see a dependency. R1 plus R3 will be R2. R1 plus R3 will be R2. R1 plus R3 will be the R2. ठीक है, R1 plus R3 will be R2. ठीक है, break करेंगे but not immediately. R1 plus R3 will be the R2. R1 plus R3 will be the R2. ठीक है, so whenever dependency is there, determinant is 0. Okay, so now I have all the values. I will just substitute here. So I have lambda cube minus beta 1, that is 6 lambda square, plus beta 2 lambda, that is minus 45 lambda, and beta 3 is 0. Okay, so if I take lambda common, I have lambda square minus 6 lambda minus 45 equal to 0. Okay, taking solving it, quadratic equation, देखो एक तो है lambda 0. Okay, and then okay, you solve by the equation minus b plus minus root over b square minus 4ac, to minus plus 144, 45 4 is 180 divided by 2a. Okay, so what is getting is lambda is 0 and ये हो गया 6 by 2 3 plus minus under root 216, 6 cube है 6 root 6 by 2, to 3 root 6. Okay, 0 and 3 plus minus 3 root 6. 0 and 3 plus minus 3 root 6. 0 and 3 plus minus 3 root 6. Okay. Now, before I discuss anything else, okay, I'll take more problems, but before I discuss that, okay, some very important properties, before I add on some concepts. Dekho, have a look into this. Okay, two of the properties are very crucial, very simple but very crucial, which will be helping you in many questions. Okay, no, don't simplify Aniruddha by rows. Dekho, I'll tell you why. Never apply row or column transformation for eigenvalue. Simple reason is the row and column transformations are for determinants, not for matrices. If you apply row column transformation, determinant value is unchanged, but the matrix is changed. You have a new transformed matrix, eigenvalue changed. Okay. Okay, so please don't apply any row column transformation. You will get incorrect answers. पहले ही मैंने बता दिया है. अब यहाँ पे ध्यान देंगे. ठीक है, यहाँ पे ध्यान देंगे. Sum of eigenvalues equal to trace. Okay, is it true? Product of eigenvalue equal to determinant. Is it true? देखना जरा यहाँ पे. what we have discussed right now, okay, should be applicable everywhere. Now, let us see here, and it's going to help you in, guys, many problems. It is going to help you in many problems. Many problems it is going to help you. तो ध्यान देना यहाँ पे. Okay, 0, 3 plus minus 3 root 6. 0, 3 plus minus 3 root 6. Okay, अब देखना यहाँ पे. Okay, what is the sum of them? ये जो रिजल्ट आया, सम. Okay, 0 plus 3 root 6. Okay, plus 3 minus 3 root 6. So 3 root 6 cancelled, answer is 6, and the sum is equal to trace also. क्योंकि trace भी तो 6 है. The trace is also 6. Okay, the product of them. The product, see, one of the eigenvalue 0, product is 0. And why the product is 0? Because determinant is also 0. Product always equal to determinant, sum always equal to trace. Very helpful for many of the questions. अभी केवल record करते चलेंगे, then we will see the question also. ठीक है. अच्छा dear, now tell me. Okay, ये तो हो गया product. Let me add on one more property here. Dear, tell me, product तो 0 हुआ because determinant is 0. Okay, इसको छोड़ दीजिए. Okay, now guys, determinant is 0. What is the rank of this matrix? Can anybody tell me what is the rank of this matrix? Determinant 0 है तो rank cannot be 3. Rank cannot be full. But is the rank equal to 2? Look into this. Look into this minor. 4 3s are 12. 8 6 are 48. When you solve, you get non-zero answer. You solve, you get non-zero answer. So you have a 2 cross 2 minor which is non-zero. You have a 2 cross 2 minor which is non-zero. The rank is equal to 2. Okay. Rank is equal to 2. Now please look into this. Rank of the matrix is 2, and how the rank is related with the eigenvalue. Rank is related with the eigenvalue. Out of the 3 eigenvalues, how many are non-zero eigenvalues? Out of the 3, how many are non-zero? One of them is 0, rest 2 are non-zero. Rank is equal to 2, and that is equal to number of non-zero eigenvalues. Number of non-zero eigenvalues. Always true. Okay, except one case. चलो वो भी बताता हूँ मैं आपको. We'll come to these questions later. थोड़ा सा पहले property से relate करेंगे. So very important property. Sum of eigenvalue is trace. Product of eigenvalue determinant. A and A transpose will always have the same eigenvalue. A matrix and a transpose, remember, they will always have the same eigenvalue. Now, rank of a matrix is equal to number of non-zero eigenvalues. यही मैंने बोला. Rank equal to number of non-zero eigenvalues of the matrix. ठीक है. अभी ये वाला matrix भी देखेंगे. Fine. I am supposed to go for one more problem which will explain you a lot of concepts. So there is a matrix. We will find out the eigenvalues. Just wait for some time. And when you find out the eigenvalues of this, now it will come out to be -1, -1, 2. Okay. There are 3 non-zero. There are 3 non-zero. Exception to this property is triangular matrix. Okay. वो भी written है. Okay. Now, when you go and find the rank of this matrix, ना, when you try to find the determinant of this matrix, करेंगे अभी इसको भी solve करेंगे. The determinant will be 0. The determinant will be 0. The rank of this matrix will be, okay, because determinant non-zero आएगा. Sorry. Determinant will be non-zero. The rank of the matrix will be 3 because you have 3 non-zero eigenvalues. Because you have 3 non-zero eigenvalues. Clear, everybody? चलो कर ही लेते हैं यार. Why to, delay this? Let's solve this problem also for a moment. Okay, let us solve this problem also for a moment. Come. Oh, stop. Determine the eigenvalues and the eigenvectors. Eigenvectors छोड़िए अभी. Find out the eigenvalues at least. Find out the eigenvalues at least. Okay. Yes, Jay. Coming to that also. Find out the eigenvalues at least. Eigenvalues at least. Okay, so for this matrix, okay, when you start calculating beta 1, beta 2, beta 3, देखो beta 1 is just trace, sum of diagonal elements 0, beta 2 is equal to how much? Okay, the minors, okay, the first होगा 0 minus 1, next second diagonal element का again 0 minus 1, third diagonal element again 0 minus 1. Okay, so all these 3 minus corresponding to all the 3 diagonal elements are -1. So beta 2 is -3. What about the beta 3? Beta 3 is simply known as the determinant of the matrix. And when you check the determinant, okay, the determinant will turn out to be, okay, पहला तो 0 ही है, then -1 into 0 minus 1, and then +1 into 1 minus 0. Okay, तो ये हो गया -1 -1 1 +1. The determinant is 2, not equal to 0. That is why I can say that, I told you, na, determinant not equal to 0, the rank will be 3. Whenever determinant non-zero for a square matrix, it has full rank. So rank will be 3. Okay, now let us come to the characteristic equation part. So dear, what is going to be the characteristic equation of this? Lambda cube minus beta 1 lambda square plus beta 2 lambda, beta 2 minus 3 hai, beta 2 lambda minus beta 3, okay, equal to 0. Okay, so I have lambda cube minus 3 lambda minus 3 equal to 0. Now reason I have taken this question for you is, the reason that I have taken this question for you is, some of you might think now, ki sir, where is the cubic calculator allowed in GATE? I mean, the virtual calculator in GATE does not involve, you know, the cubic or quadratic equation. It is there in the traditional calculator, but not in virtual calculator. So are you stuck here? Are you stuck here? Beta 2 minus 2 nahi aaya na? -1 -1. No, it's minus 3 only. Correct hai. Jesse, please take it out. Okay. So what you might be thinking is, okay, how to solve this equation? There is no cubic calculator and you stuck. Such problem cannot come. See, if it is actually non-solvable directly, they will not give that question also. They also know ki the cubic equation facility is not in the virtual calculator. But sometimes there can be simple factorization. Ye beta 3 tha, beta 3 2 hai. Okay, ye to 2 hai, sorry. Okay, ye to 2 hai. Okay, ye 2 hai. Okay. Now what you can do is, okay, just break it. 3 lambda को break किया lambda and 2 lambda में, तो lambda cube minus lambda minus 2 lambda minus 2 equal to 0, lambda outside, lambda square minus 1 minus 2 outside, lambda plus 1 equal to the 0. What? Equal to the 0. ठीक है. Now if I take lambda square minus 1 will also have a lambda plus 1, a minus b, a plus b. Okay, so lambda plus 1 can be taken common. If you take lambda plus 1 common, you're left with lambda into lambda minus 1. And then, yahan pe aaya minus 2. Now it is factorizable and hence you can solve. You have lambda plus 1. Okay, lambda square minus lambda minus 2. Is quadratic ko bhi factorize kar dete hain quickly. I have lambda plus 1. Okay, lambda minus 2 and lambda plus 1. Okay, eventually you have lambda plus 1 ka whole square. After complete factorization, lambda plus 1 whole square into lambda minus 2 equal to 0. So lambda is -1 plus 2. Without table calculator, we have solved it. Okay. Nahi Prabhanjan, no. Okay. If the determinant is 0, rank will not be full. It may be 2 or 1 depending on the dependencies, na? Rank mein wahi to discuss kiya tha Prabhanjan for so much time. Okay. ठीक है. चलो. So we have the eigenvalue -1 and 2. Okay. अच्छा. How many non-zero? All 3 non-zero. And that is what is the property I was telling you. ये हमने solve कर लिया है completely. Look into it now. Here. Okay. Look into it now. Everybody, please look into it. Okay. The same matrix I was explaining. -1 -1 2. There are 3 eigenvalues. All 3 non-zero. And the rank will be 3. Because determinant non-zero, the rank will be 3. So there is a clear connection. Between rank and eigenvalues. Rank equal to number of non-zero eigenvalues. Only exception to this property will be triangular, upper or lower triangular matrices. Don't apply there. Achha, if there is a triangular matrix, then ye bhi important hai. Very simple for triangular matrix. The eigenvalues are just equal to the diagonal elements. For a triangular matrix, eigenvalues are just equal to the diagonal elements. A11, A22, A33. Whatever are the diagonal elements and whatever may be the size, dear. Whatever may be the size. So, dekho, suppose if a question, find the eigenvalues of whatever may be the size. Suppose if there is a question of the form, find the eigenvalues of matrix A given to you as suppose 2, 0, 1, 8, 9, okay, 0, -1, 1, 1, 0, 0, 0, 4, 2, 3, 0, 0, 0, okay, -3 and 1, 0, 0, 0, 0, 5. It's a 5 cross 5 matrix. Will it be lengthy? Synthetic division is also possible, but even they will not give that case. They will not give any case where it is time consuming. They will give factorization mostly. Otherwise, they will not give cubic. Okay, so yes, synthetic division is possible, but I think such question will not come because of lengthy. They don't want you to test on synthetic division. Okay. Chalo. So this is what type of matrix, dear? This is a upper triangular matrix. This is a upper triangular. Whether it is upper or lower triangular. Whether it is upper or lower triangular. Okay, what are the eigenvalues? Just equal to the diagonal number. So that is 2 and -1 and 4 and -3 and 5. That's it. 2 and -1, 4 and -3 and 5. That's it. इतना ही करना है. इतना ही करना है. Very simple. Whatever may be the size. Whatever may be the size. Clear? That's simple. Whatever may be the size. ठीक है. Now, okay, we will learn more properties. There are many properties actually. There are many properties. We will learn more properties. But before that, let me come to the next concept here. Break abhi nahi ho raha hai. Yeah. Okay. Now, determine the eigenvalues and eigenvectors. Determine the eigenvalues and eigenvectors here. Listen to me. Determine the eigenvalues and eigenvectors. Eigenvalues we have determined. -1, -2. -1, -1 and 2. Okay. -1, -1 and 2. Okay. Now, what are the eigenvectors? Now, whenever you want to solve for eigenvectors, conventional method abhi nahi bataunga because that is not required. But what is the conventional method is? Conventional and lengthy method is, okay, solve ax equal to lambda x or bring the lambda x on the left side. A minus lambda to nahi kar sakte, so we write lambda I. A minus lambda I into x equal to 0. You need to solve this non-homogeneous system of equation. Non-homogeneous system of equation. Okay. It is a non-homogeneous system of equation. Characteristic equation to eigenvalue ke liye use hoga. I am talking about eigenvectors. Eigenvectors are the solutions of, I can say that eigenvectors are the solutions of the equation, homogeneous equation, a minus lambda I into x equal to 0. Okay. A minus lambda I into x equal to 0. Okay. Acha ji. Then what is the shortcut? I will tell you the eigenvectors of this directly by the conventional method. I will not solve conventional method, but I will give you the result. जो बिल्कुल required नहीं है उसकी बात नहीं करेंगे. Because in GATE absolutely you don't have to think about conventional method. I have told you what is the method, but you don't need to solve even a single % question using this. That is why जिसको बिल्कुल use नहीं करना है उसको discuss नहीं करेंगे. Clear? But what are the solutions of conventional method? I will tell you. But उससे पहले shortcut की बात करें. What if you get a question on eigenvector? Just one and only one rule. Just one and only one rule. Let's learn here. Come to the question. And it's a MSQ question. Such questions come repeatedly. Very, very important. Recent years में भी देखोगे almost every year such questions are coming. Which of the following is or are eigenvectors? And multiple select means one or more than one answer can be correct. One or more than one answer can be correct. ठीक है. Beta 2 -3 correct, Rajiv. ठीक है. One or more than one answer correct. Okay. Now, how to apply on MCQ or NAT question? Okay. Whether guys it is MCQ or NAT or MSQ question. Okay. The trick is just you have to check, verify. Dear, what we know, definition, concept verify करेंगे. If x is an eigenvector, it should satisfy ax equal to lambda x. Na? I mean, whenever you multiply, suppose this is an eigenvector. If you multiply by x, you should get the answer. Okay, which is proportional to it, which is a multiple of it. Okay, apply karte, then it will be more clear to you. Okay, so option number A. If I apply, it will be more clear to you. So what is the option number A? Okay, I try ax. A is 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, 0, 1, 1, 1, 0, 1 and 1, 1, 0. Clear? Okay, now and multiplied by x. What is the x? Option number A check करेंगे. That is 1 and 2 and 5. 1 and 2 and 5. तो देखो 0 into 1. Okay, then plus 2 plus 5. This is 7. First row and first column multiplied. Then 1 plus 0 plus 5. That is 6. Then 1 plus 2 plus 0. That is 3. Now dear, tell me, is it equal to lambda into x? Is it equal to lambda x? Tell me na. Tell me, is it lambda x? nahi Govind Rao, not all 4 correct. Maybe up to 4 correct. Maybe 1 correct, 2 correct, 3 correct, 4 correct. Okay. Now tell me, is it lambda x? Suppose this is lambda x, मान लेते हैं. So if this is equal, all elements should be equal, all corresponding elements equal. So lambda into 1 should be 7, so lambda is 7. But Baba, if lambda 7 hai, so lambda into 2, 7 into 2 should be 14. Not matching up. Not matching up. So this is not equal. And if this is not equal, this is not an eigenvector. Okay, if ax not equal to lambda x, it is not an eigenvector. ठीक है जी? That is what you have to apply. Option number B. Now matrix multiplication is easy only, na? So that calls for a easy method. This is a easy method. You have to apply a into x. What is the x for me in the option number B? 1 1 1 1 1 1 1 1 1. चलो multiply करेंगे. First row, first column. 0 plus 1 plus 1 is 2. 1 0 1 is also 2. 1 1 0 and you add, that is also 2. Clear? आंखों के सामने की बात है. It is clear that in the 2 2 2, if you take the 2 common, in the 2 2 2, if you take the 2 common, you are left with 1 1 1. Okay, you are left with 1 1 1. Okay, you are left with 1 1 1. So very clearly in front of your naked eyes that ax is 2x. You apply the input x, you get the output 2x, multiple of x. Okay, multiple of x. Multiple of x. Okay, so this is clearly an eigenvector. X is an eigenvector. अच्छा देखो, वैसे तो we need to only check eigenvectors. We need to only check eigenvectors. But suppose they can ask you, what is its corresponding eigenvalue? There can be different eigenvalues. Now, what is the corresponding eigenvalue? So, dear, lambda equal to 2. That multiplication number, that is the eigenvalue. Na? So, lambda equal to 2 is its corresponding. ये इसके corresponding eigenvalue है. Lambda equal to 2 is the corresponding eigenvalue. ठीक है, what is the corresponding eigenvalue? Lambda equal to 2 is the corresponding eigenvalue. अच्छा, हमें ये भी पता है, already we have calculated for this question. Let me repeat. Lambda was -1, -1 and 2. Already we know the eigenvalues, -1, -1, 2. ठीक है, so 2 is eigenvector. For NAT also it will work, don't worry. NAT में they can't ask the vector, na, they will ask some numerical quantity. This method will work. I will show you NAT question also. I am telling you, na, this will work for all questions. Just trust me, it will work for all questions. परेशान नहीं हो, ठीक है? So lambda is due to corresponding eigenvalue. Now देखो, if it is a MCQ question, if they tell you it is a MCQ question, MCQ means only one correct. Now I will stop here. But MSQ more than one correct. So I will try others option also. Option number C. Now I will try option number C. Okay, for option number C, what is AX? So A matrix is 0 1 1 1 0 1 1 1 1. Oh sorry, 1 1 0 multiplied by the X. What is the X? 1 2 minus 3. Now multiply this, guys. First row 0 2 minus 3. I am -1. 1 0 minus 3. That is -2. 1 plus 2 plus 0. That is 3. Okay. Are they related to each other? Are they related? Take minus outside. If you take minus outside, you get 1 2 minus 3, which is the applied input vector. You apply AX, you get minus X. But even the coefficient may be plus or minus, but output is similar to input. Na? It is -1 into X. Okay, this is correct eigenvalue with the corresponding, this is the correct eigenvector. Corresponding eigenvalue is -1. Corresponding eigenvalue -1. ठीक है? Option number D. अच्छा, तो C भी correct है, C को भी tick mark कर देंगे. Option number D. Now I try AX. -2, 9 and -7. Please multiply this. So this is 0, 9, -7. This is 2. Okay, -2, 0, -7. -2 -7, -9. Third, -2 plus 9 and 0, 7. Okay, and this is equal to, again if I take minus outside, now I get -2 plus 9 and -7, which is same as the input vector X. So AX is -X. AX is -X, correct. This is also eigenvector with the corresponding eigenvalue -1. Okay. For a particular eigenvalue, there can be multiple eigenvectors. They are not unique. Okay, they are not unique. ठीक है, they are not unique. ठीक है, चलो जी ये हो गया. So D is also correct. D is also correct. So this MSQ question, okay, the correct answers are B, C, D. Except A, all three are correct. Except A, all three are correct. ठीक है. Now I will tell you some more things here. This is what is the approach you have to follow in the exam. Okay, okay. Up to 2 decimal place, take 3.5655. See, they will always check it in the range, Govind Rao. Okay, so whether you write 3.55 or 54, it's not going to affect your answer. If it is a fractional answer, they will check in the range. Don't worry, they will check like from 3.4 to 3.7, like that, like that. ठीक है. चलो अभी middle में break नहीं. I will give you break. Don't worry. Okay, I will give you break. Don't worry. NAT पे भी apply होगा. आगे question practice करेंगे अनवर. Don't worry. Okay, okay. So I'll give you break, but not immediately. I don't want to stop anything in between. Okay. So देखो guys, there is a matrix whose eigenvalues are already calculated. Eigenvalues are calculated. Okay. Now eigenvectors के लिए I told you conventional method we have to solve equations. Not required any time in any type of competitive exam question. What is required? Ax equal to lambda x. वो जो approach मैंने बताया. But if you solve it, what are the roots coming up? I will tell you the result directly. Okay, you have to solve and there are 3 eigenvalues. Okay, actually 2 unique eigenvalues. ये तो repeated है. Okay, actually 2 unique eigenvalues. If I take lambda equal to 2 first of all. If I take lambda equal to 2, I have the result Ax equal to 2x, correct? Ax equal to lambda x. Bring it on the left side to a minus 2y. You cannot write a minus 2. So a minus 2y into x equal to 0. Okay. Now, this is clearly homogeneous system of equation, isn't it? This is clearly homogeneous system of equation. Okay. How many independent solutions will it have? At least can you tell me this one, na? How many independent solutions? What is the solution? Solution means eigenvector. Solution means eigenvector here. How many number of independent eigenvectors? अब इसका ये मतलब हुआ. What is the number of independent eigenvectors? N minus R. Homogeneous आज ही पढ़ा था. Okay, homogeneous आज ही पढ़ा था. तो N minus R. ESE mains के लिए yes you have to. Ashish. Okay, n is the number of variables. 3 की बात चल रही है. N is 3 and rank of the matrix. अच्छा, rank of which matrix? Please take care. Rank of the matrix which is there in the homogeneous. A minus 2y. A minus 2y. Okay, A minus 2y. Okay, what is going to be A minus 2y? चलो ये मैं बता देता हूं आपको. थोड़ी सी मेहनत कर लेते हैं. Okay, so what is going to be A minus 2y? Okay, we have the matrix A. Okay, when you minus with 2i, identity matrix, unity matrix, where only diagonal elements are present and they are all 1, others are 0. Okay, now when you subtract it, you get how much? 0, minus 2, then 1 minus 0, 1 minus. Diagonal elements to non-off diagonal elements to affect nahi honge. So 1, and then minus 2 and 1, and then 1, 1 and minus 2. What is going to be the rank of this? What is going to be the rank of this? What is going to be the rank of this? Diagonal में minus 2 आ गया. Okay. Now what is going to be the rank of this? Please tell me. Okay. Let me try any 2 cross 2 ना. Let me try any 2 cross 2. देखो determinant तो 0 ही होगा. Modulus of A minus lambda is always 0. Okay. The rank of this matrix will be 2. Again I am repeating, because I have taken A minus lambda, तो determinant A minus lambda is always 0 ना, characteristic equation है. तो determinant तो 0 होगा, rank will not be 3, but rank will be 2. Why rank is 2? Check any 2 cross 2 determinant in front of your eyes. Yeah, maybe addition जो भी करना है. Minus 4, sorry, plus 4 minus 1, non-zero आया, non-zero आया, non-zero आया, non-zero आया, तो rank equal to 2. Okay. Okay. Non-zero आया, तो rank equal to 2. So 3 minus 2 and that is equal to 1. So how many independent vectors will it have? It will have the independent vector equal to 1. What is that independent vector? What is that independent vector? That is 1, 1, 1. Sorry, that's not 1, 1, 1. Let me put it like that. That is the form of KKK. Sir, how it is KKK? I'm not solving and I'm giving you the result. We don't need to solve equations. We don't need to spend time here solving equation. Okay. X will be KKK. Means what are the eigenvectors here? Listen to me. What are the eigenvectors here? The eigenvectors could be 1, 1, 1, or it could be 2, 2, 2, or it could be 10, 10, 10, anything. Any of these eigenvectors will be there corresponding to the eigenvalue lambda equal to 2. Okay, corresponding to the eigenvalue lambda equal to 2. Okay? And for any eigenvalue, there can be multiple eigenvectors. Okay? But how many independent eigenvectors corresponding to eigenvalue? That is equal to 1. That is equal to 1. That is equal to 1. Now please listen to me. Now please listen to me. We had 3 eigenvalue, -1, -1, 2. Out of which the eigenvalue 2 comes how many times? Okay. The eigenvalue 2 comes only one time, na? How many times it is repeated? Only one times. How many times it is repeated? Only one time. ठीक है? Write down 2 important terms here, AM and GM. कभी इस पे भी question आ सकता है. Complete repetition, complete revision कर रहा हूं मैं यहाँ पे हर एक point का, तो base focus here. There are 2 concepts related to eigenvalue, eigenvector, AM and GM. AM and GM. Okay. Yeah, negative also, Shivani. It can be negative also, bhai. You can also take it like this. -3, -3, -3. Anything, any value of k. ठीक है? AM. Okay. Algebraic multiplicity. If lambda is repeated m times, then AM equal to 1. If lambda is repeated m times, the AM equal to 1. Okay. So please listen to me. If I talk about lambda equal to 2, okay, if I talk about lambda equal to 2, its AM equal to 1. How many times it is repeated? Only one times. Its AM equal to 1. And what is its GM? Now, dear, what is the meaning of GM? Okay, what is the meaning of GM? Known as geometric multiplicity. Geometric multiplicity of an eigenvalue is the number of independent eigenvectors corresponding to it. If lambda has p linearly independent eigenvectors corresponding to it, then the GM is P. And how many independent eigenvectors? वो formula तो पता ही है. That formula is coming up from homogeneous discussion. That formula is coming up from homogeneous equation. N minus rank. किसका rank? A minus lambda I. N minus rank of A minus lambda I. So what is the GM here? What is the GM? N is 3. Rank of A minus 2i. Rank of A minus 2i. जो मैंने अभी solve करके आपको बताया. Okay, we solved the rank. We got the rank 2, and that is why the GM equal to 1. GM equal to 1. GM equal to 1. GM equal to 1. Clear? That was for the eigenvalue of lambda equal to 2. Okay, now next. If the eigenvalue is lambda equal to -1. Okay, so what we need to solve then? We need to solve AX equal to -x. Hold the doubts for a few minutes. We need to solve AX equal to -x. We need to solve AX equal to -x. Yeah, bringing on the left side, AX plus x. X को कॉमन लेंगे तो a plus I into x equal to 0. A plus I into x equal to 0. Equal to 0. Again homogeneous. Again we get homogeneous. ठीक है. And for homogeneous system, how many independent solutions? How many independent solution? Okay. How many independent solutions? So we have number of independent solutions. That means number of independent eigenvectors equal to the formula n minus rank. Rank of which matrix? Rank of A plus I. In general, rank of A minus lambda I. Here it is A plus I because lambda is -1. So n minus rank of A plus I. Dear, n is 3. Rank of A plus I. Chalo. What is A plus I? What is A plus I here? A is 0, 1, 1, 1, 0, 1, 1, 1, 0. इसमें add किया मैंने identity. So all diagonal elements will be added with 1. ठीक है? That means I think we have solved this question. I think we have solved the question. Whenever all the elements of a matrix are 1. अभी हमने एक question solve किया था. Whenever all the elements of a matrix is 1, rank of such a matrix is 1. Because actually all rows are identical. Because actually all rows are identical. Because actually all rows are identical. And because all rows are identical, rank will be 1. So Baba, ये आ गया rank equal to 1. Okay. So 3 minus 1, it will have 2 independent eigenvectors. It will have 2 independent eigenvectors. Clear? It will have 2 independent eigenvectors. Okay. Now, what are those, like I told you, eigenvectors here? What are those eigenvectors? The solution of this will turn up to be in the form k1, k2 minus k1 plus k2. Okay. How to solve? I'm not discussing here, but yeah, not required also. Okay, after solving, you will get the solution in the form of k1, k2 minus of k1 plus k2. Okay, that means what are the solutions? एक बार देख लेते हैं. Okay, that means k1, k2 can be anything. So maybe I take 1, then 1. So it will be minus of 1 plus 1. 1, 1 minus of 1 plus 1. So that is minus 2. Or it could be 1, 2 minus 3. देखो, let me go to that MSQ question. There was one option. ध्यान देना. There was one option. 1 minus 2 and minus 3. 1, 2 and minus 3. ये ऑप्शन देखा था and it was the correct option also. This was the correct option also. That is what I am taking here. 1, 2 minus 3. K1, K2 negative of K1 plus K2. So negative of 1 plus 2, that is negative 3. ठीक है. Or it may be something of this kind. Suppose it may be 2 and then 8 and then minus 10. Or etc. 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 But अब ध्यान देना. But how many such solutions you can write? Infinite possibilities. You can write infinite possibilities. You can write infinite possibilities. But out of those infinite possibilities, any third will be dependent on any two. Any of the vector will be dependent on any other two. ठीक है? These are relatable. These are relatable. अगर थोड़ा मेहनत करेंगे तो निकल के आएगा. I don't want to spend time on to that. But these are relatable. Okay. These are relatable. ठीक है? These are relatable. 100% they have to be relatable. ठीक है? These will be relatable for sure. For sure. You can spend time and you can calculate. Yeah, let me give you एक dependent वाला direct ही बताता हूँ मैं आपको. चलो, it may be also in the form of, ध्यान देना. It may be also in the form of 14, so minus 23. देखो, 4 times this plus 5 times this. 4 times this plus 5 times this. Okay, 4 plus 5, 9. 4 into 1 plus 5 2s are 10, 14. 4 into minus 2, minus 8, and then minus 15, minus 23. Okay, or etc. 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 Okay, so when I say there are only two independent eigenvectors, means any eigenvector can be related with other two. Only two will be independent. The third can be taken as the dependent one. ठीक है? ठीक है? अच्छा, even if you go to the MSQ question again, okay, look into this. This is also that category only. K1, K2 minus of K1 plus K2. इन दोनों को add करेंगे. Minus of 2 plus 9, 7. Negative of 7. ठीक है? And this is of the first category, KKK. This is of the first category, KKK. ठीक है? So whatever we have matched, okay, by our shortcut, clearly works for us. Clearly works for us. Clearly works for us. Okay. ठीक है? So now let me write down one more answer. ये हो गया. Now let me write down the answer for lambda equal to minus 1. Dear, lambda equal to minus 1. What is the AM? What is the AM? We go back to the problem again, dear. We go back to the problem and lambda equal to minus 1 minus 1. How many times? Lambda equal to minus 1 minus 1. How many times? How many times it is repeated? 2 times. How many times it is repeated? 2 times. Take a hold for doubts. Few more minutes. It is repeated 2 times. Okay, so that is known as the AM. That is known as its AM. Okay, so AM equal to 2. AM corresponding to lambda equal to minus 1 is 2. How many times it is repeated? 2 times. And what is the GM? GM is the number of independent eigenvectors corresponding to it, and that is given by n minus rank of a minus lambda I. और ये अभी मैंने solve किया. Rank of a plus I turned out to be how much? Turned out to be 1, and the GM is equal to 2. अभी देखा था ना? What is the rank of a plus I? Turned out to be 1, and 3 minus 1. How many independent eigenvectors? 2. The number of independent eigenvectors corresponding to eigenvalue is known as its GM. The GM of this eigenvalue is 2. Geometric multiplicity of this eigenvalue is nothing but equal to 2. That is nothing but equal to 2. All okay? All good? Next question. ठीक है जी? Yes, yes, let's target the 4th century of likes. Let us target the 4th century of likes. We are at 378, guys. At least before lunch, the 4th century. Let it be a T20 race. Let's not be a test match race. ठीक है? ठीक है? अब देखो. Okay. नहीं राज. A minus that lambda I for any lambda, mod of A minus lambda I always 0, na? For any lambda, Raj. For any lambda, mod of A minus lambda I always 0. Then only lambda is eigenvalue, na? Eigenvalue is the solution of this. Okay, so determinant without checking has to be 0, Raj. इसीलिए मैंने बोला था. ठीक है? नहीं AM GM always equal. No, not required. They are independent. Okay. अरे बहुत अच्छा, 5th सेंचुरी कर देंगे तो बहुत बढ़िया, ग्रेट, बिफोर लंच 5th सेंचुरी, करेक्ट, ठीक है ना। AMGM नॉट ऑलवेज इक्वल, और क्या डाउट है अंकित? दैट आई हैव नॉट सॉल्व्ड, ओके, आई एम टेलिंग यू व्हाई k1 plus k2, okay, when you solve na, see this is multiply this by x y z, try to solve the equation, okay, the solution of the equation will be in this format, but I'm just saving time, that is not required. After solving, all the equations will be in this format, all the solutions will be in this format, clear? ठीक है, आप थोड़ा सा ट्राई करोगे, within a 2 minutes you will get, ठीक है। चलो, now let's jump back to some more properties, let us jump back to some more properties, ठीक है। So yeah, we were into property 1, 2 done, 3 done, 4 done, 5 done, triangular matrix wali. Okay, now next one, 6. This is also important. Lots of questions you will feel from here. Lots of question you will feel from here. The lots of question you will feel from here. Okay. So, if matrix A has the eigenvalue lambda and eigenvector x, suppose for a matrix you know the eigenvalue and eigenvector, then some operations applied on A. Then some operations applied on A. A power n, eigenvalue lambda power n, eigenvector is x. Eigenvector remains to be same, but A power n, eigenvalue will also be lambda power n. Same power. If A plus I, the lambda plus 1. If A into k, the lambda also multiplied by k, but eigenvector not affected in any of them. Some more results let me add on here basically. Some more results. So with respect to same, continuing the same, if it is A inverse, so eigenvalue will be lambda inverse. Now, Baba, A power n, if I take A inverse, eigenvalue will be 1 by lambda, but same eigenvector. Okay, same eigenvector. Okay. Then, what about A transpose? Already I told you, A and A transpose have the same eigenvalue. A and A transpose have the same eigenvalue, but eigenvector will not be same. Okay. Eigenvector will not be same. So I am putting a question mark, means there is no property. We need to separately calculate if there is an eigenvector. For transpose of the matrix, we know that A and A transpose have the same eigenvalue. Okay, but not the eigenvector. Eigenvector, अगर question है तो अलग से बताना ही पड़ेगा, solve करना पड़ेगा, efforts करना पड़ेगा, ठीक है? There cannot be a property, ठीक है? अच्छा, similarly, if they talk about adjoint A, see what is adjoint A? Adjoint A is known as, we know the formula A inverse. A inverse is adjoint A upon mod A, na? So what is adjoint A? Adjoint A is known as mod A into A inverse. Okay, mod A into A inverse. Mod A multiplied by A inverse. Okay. So what is the eigenvalue for adjoint A? Okay. If there is a question, eigenvalues of adjoint A. Mod A is just a number. If you multiply a matrix by K, yeah, चलो पहले A inverse की बात करते हैं. What is the eigenvalue for A inverse? Lambda inverse. But then A inverse is multiplied by modulus of A. That is constant. Na? When you multiply any matrix by K, the eigenvalue also multiplied by K. So here eigenvalue also multiplied by mod lambda. That means the eigenvalues are modulus of A divided by lambda. Okay. कैसा क्वेश्चन आ सकता है यहाँ पे? Suppose A is a 3 cross 3 matrix and it has the eigenvalue, suppose 2, 3 and 5. Okay. What are the eigenvalues for adjoint A? What are the eigenvalues for adjoint A? The eigenvalues for adjoint A will be mod A by lambda. Now, dear, what is mod A? Only matrix is not given, only eigenvalue given. So, what is mod A? Product of eigenvalue, na? What is mod A? Product of eigenvalue. So, 2 into 3, 6, 6 into 5, 30. Okay, divide by 2. There will be 3 eigenvalues. One will be 30 by 2, one will be 30 by 3, one will be 30 by 5. Clear? Okay, so that is 10. Sorry, 30 by 2 से start किया तो 15, then 10 and then 6. These are the eigenvalues of adjoint A. Clear? 15, 10 and 6. ठीक है? ये कैसे निकाल दिया मैंने? Okay, this is product of the eigenvalues. Property number 2, determinant is product of eigenvalue. ठीक है ना? Done है. Now, एक example इसके support में already है. Look into this matrix. Okay, we will have several other questions also, but look into this matrix already solved, na? Okay, what is the sum of elements of every row? What is the sum of elements of every row? 0 plus 1 plus 1, 2. Second, 1 plus 0 plus 1, 2. Third, 1 plus 1 plus 0, 2. Sum of elements of every row is same. Sum of elements of every row is same. sum of the elements of every row is same. Of every row is same. Whenever the sum of elements of every row is same, look into this property. If the sum of the elements of every row is same, then one of the eigenvalue is equal to that sum. Okay, then one of the eigenvalue, one of the lambdas is equal to that sum, is equal to that sum, is equal to this sum. Okay, did we have one of the eigenvalues as 2? हमने निकाला हुआ है ना. What are the eigenvalues? -1, -1, 2. One of the eigenvalues is always equal to that sum. One of the eigenvalues is always equal to that sum. Clear? Okay. I think students automatically gone to break. No problem. Then my headache is solved. If you automatically take the break, good. I think students have started taking break automatically. They are feeling hungry. Okay, no problem. I will continue. Okay. Next. Okay. For a real matrix, then some fundamental property. For a real matrix, if alpha plus I beta is an eigenvalue, then alpha minus I beta is also an eigenvalue. Okay. If alpha plus I beta is an eigenvalue, alpha minus I beta will also be an eigenvalue. Alpha minus I beta will be also an eigenvalue. Okay. Okay. For a real matrix, eigenvalue appear in complex conjugate pair. If it is complex, it can be real also. It can be real also. Okay. Okay. If alpha plus I beta eigenvalue, alpha minus I beta is an eigenvalue. Okay. They will be occurring in the conjugate pair. They will be occurring in conjugate pair. But if it is a complex matrix, above property not necessarily holding. Okay. Okay. Real matrix means what? What is a real matrix? Real matrix means those matrix in which all elements are real. All elements are real. ये ध्यान रखना. ठीक है. 9th. Now some important properties. यहाँ पे एकदम complete list के साथ. Okay. Some important properties which are important for factual and conceptual question. Factual and conceptual question. Factual and conceptual question. Yes, real matrix can have complex eigenvalue, but if it is having complex eigenvalue, it will be in the conjugate pair. Okay, आएंगे ऐसे cases भी आएंगे. Okay, if it is complex, it will be in conjugate pair. That is what I want to say, Amrut. But definitely it can have complex eigenvalues. हाँ, but if it is a real symmetric matrix, first important point. If it is a real symmetric matrix, ठीक है. Don't worry, a vector space, subspace, basis, dimension. I think I can plan a separate session on that. Is only EC syllabus. Now, EC and data science syllabus. Okay, it is not common syllabus. Okay, just one branch syllabus. Now, so I will take it separately. One session, small session I will take for it. Okay, upcoming days में plan करते हैं उसको. Vector space, basis. That is why I am not covering here. That is only one branch EC and then data science also. ठीक है. चलिए. Eigenvalues of a real symmetric matrix are always real. Next, eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal to each other. Will be orthogonal to each other. अब ध्यान देना है कि example लेता हूं मैं यहाँ पे. Very important property है ये. Okay. Okay. Let us say the matrix again. Same matrix. Let's copy 0 1 1 1 0 1 1 1 0. Okay. Okay. Isn't it real symmetric? Isn't it real symmetric? What is symmetry? Elements above and below the diagonal are identical. Elements above and below the diagonal are identical. Mirror image of each other. Mirror image of each other. They are identical. They are mirror image of each other. So this is known as real symmetric matrix. This is known as real symmetric matrix. This is known as the real and the symmetric matrix. Clear everybody? Okay, real and the symmetric matrix. ठीक है. Real and the symmetric matrix. ठीक है. ठीक है. चलो. Real symmetric matrix. Now what are the eigenvalues? देखो. Eigenvalues obtained is -1, -1 and 2. Okay, all real. It will be always real for a real symmetric matrix. ठीक है. अब देखो. Corresponding to distinct eigenvalues. Corresponding to distinct eigenvalue. These two are distinct. इन दोनों का देखते हैं. Corresponding to lambda equal to -1. What is the solution I have given you? I have given you in the form of k1 k2 minus of k1 plus k2. ठीक है. Corresponding to lambda equal to 2, I have given you the solution of the form of k k k. अब एक एक example ले लेते हैं. ठीक है. Take an example. Okay, k1 k2 and minus. Let's take 1 2 minus 3. Okay, and let's take one example here as simple 1 1 1. What I told you, if two eigenvalues are distinct, if two eigenvalues are distinct, lambda 1 not equal to lambda 2. Minus 1 and 2 are distinct. Okay, minus 1 not equal to 2. Okay, so x1 and x2 क्या बोला है? x1 and x2 should be orthogonal. Proof कर ले. Hey, orthogonal means dot product. Hey, orthogonal means dot product. x1 dot x2 is 0. Dot product in matrix is also represented as x1 transpose x2. In the matrix form, dot product is also known as x1 transpose x2. Yeah, simple mathematical dot product. What is the mathematics dot product you calculate? In the mathematics, dot product is simply corresponding x to x component, y to y component, z to z component. Okay, so 1 into 1, भाई कितना हो गया? 1 into 1, then 2 into 1, then minus 3 into 1. Dot product कैसे निकालते हैं वेक्टर्स में? Okay, so when you take 1 plus 2 minus 3, it is 0. Perfect. They are orthogonal. Dot product between the vectors 0, so it is orthogonal. Okay. Okay. See, Rajiv, if it is any doubt related to what we are discussing, you post it here. Any other doubt, you post to the app. Okay, or to the Telegram. Okay. Any other doubt other than this discussion? Separate doubts, post it on the Telegram or app. Any doubt related to any question taking right now? Because otherwise, if I start taking personal doubts here, then when will I complete the revision? Simple ideas. Okay. Okay. Na, Tithi. If it is a real matrix, eigenvalue may be real or complex. If there is complex eigenvalue, it will be in the pair. But if it is real symmetric, na, if it is real symmetric, eigenvalue real होगा, तब तो conjugate symmetry need नहीं है, तिथि साहा. If it is real symmetric, eigenvalue will be 100% real. 100% real, okay? Then there is no conjugate property here. Clear, everybody? Yeah, very soon I think I can give you the break, but just wait. Okay. Eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal to each other. Eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal to each other. ये already हमने देखा अभी, ठीक है? Eigenvalue, similarly, for a real skew symmetric matrix, eigenvalues are either 0 or pure imaginary. Remember, direct factual questions, theoretical questions भी sometimes can be coming from this. Eigenvalues of real skew symmetric matrix may be either 0 or pure imaginary. Okay. Then, eigenvalues of a Hermitian matrix are always real. Okay, eigenvalues of a skew Hermitian matrix are either 0 or pure imaginary. Symmetric matrix, let a quick revision. A transpose is A. Skew symmetric matrix means A transpose equal to minus A. Similarly, Hermitian matrix means AQ equal to A. AQ bole to, what is AQ? That is the A conjugate transpose. AQ means the conjugate of the matrix and then transpose. Okay. And then, okay, for a skew Hermitian matrix, what is skew Hermitian matrix? AQ equal to minus A. Eigenvalues are either 0 or pure imaginary. Next property to be learned is, okay, the eigenvalues of a unitary matrix or a real orthogonal matrix. See, orthogonal matrix is the one satisfying AA transpose equal to identity, that is in the real domain. Unitary matrix is the concept for complex matrix AAQ equal to I. Okay, whenever you talk about orthogonal or a unitary matrix, okay, the eigenvalue, okay, satisfies mod lambda equal to 1. Okay, that means eigenvalue lie on the unit circle. Their magnitude is 1. They will always lie on the unit circle. Okay. Last but not the least property, okay, then we move forward. Okay, the number of linearly independent eigenvectors, total. I'm not talking about corresponding to a particular eigenvalue. In the GM, we talk about the number of eigenvectors, independent eigenvectors of a particular eigenvalue. Now, in total, the number of linearly independent eigenvectors of a matrix, total, is equal to the number of distinct eigenvalues of the matrix. Is equal to number of distinct eigenvalues of the matrix. Is equal to the number of distinct eigenvalues of the matrix. Is equal to the number of distinct eigenvalues of the matrix. ठीक है? Is equal to the number of distinct eigenvalues of the matrix. ठीक है? We can go. Just let me check. Okay, let me just check for the feasibility as of now. For the break, just allow me 1 minute. Just a second. No, we'll not have. This is engineering maths only, not discrete maths here. Okay. Chalo, done. Ready for break? Okay, properties part done. Okay. Few different variety of questions. Then we will start the new chapter. Acha, whatever is the new chapter, dear, na? Whatever is the new chapter. Okay. Kylie Hamilton bhi karna hai. Kylie Hamilton, I think, also there after this. Okay, Kylie Hamilton is there. Okay, so last property, number of linearly independent eigenvectors are equal to distinct eigenvalues. Acha, suppose, देखो, A is a n cross n matrix. ठीक है, just one more point, 2 more minutes. Kylie Hamilton break के बाद कर लेंगे. Okay, if you have a n cross n matrix, okay, if you have a n cross n matrix, lots of time went in the linear algebra only. Okay. Suppose it has n eigenvalues. Okay, suppose it has, okay, suppose if there are n distinct eigenvalues. Okay, चलो 3 के एस्पेक्ट में समझते हैं. ठीक है, suppose you take a 3 cross 3 matrix, easy to apply, easy to understand with 3. Okay, if it has 3 distinct eigenvalues, okay, and if it has 3 distinct eigenvalues, so what I am trying to tell you is, okay, there will be 3 linearly independent. There will be 3 linearly independent eigenvectors also. Okay, suppose the independent eigenvectors are x1, x2, x3, and the 3 distinct eigenvalues are lambda 1, lambda 2, lambda 3, all not equal. All not equal. Okay, whenever a matrix has all distinct eigenvalues, the matrix is said to be diagonalizable. The matrix is said to be diagonalizable, and we can write down the matrix. Which matrix? A. We can write down the matrix A as P inverse dP. We can write down the matrix A as P inverse dP. Now, what is P? Sorry, we can write it out as P d P inverse. Okay, P d P inverse. Okay, what is the D matrix and what is the P matrix? Okay, where D is the diagonal matrix. Where D is a diagonal matrix containing the containing all the diagonal elements as eigenvalues. Lambda 1 0 0 0 lambda 2 0 0 0 lambda 3 0 0 lambda 3, correct? 0 0 lambda 3. ठीक है? Okay. Probability will also be there anywhere within 2 days. I cannot guarantee what is covered today, but within the 2 days I will cover it. Okay. And P is a matrix containing all the 3 eigenvectors. Eigenvectors are x1, x2, x3. So suppose all the 3 eigenvectors are 1 1 column. Suppose all the 3 eigenvectors are 1 1 column, x1, x2, x3. Okay, that is known as the 3 cross 3 matrix P. Matrix A can be written as P d P inverse. Okay, P d P inverse, where D is the diagonal matrix containing all the eigenvalues. Okay, so a matrix is diagonalizable. Condition क्या लिखा? Okay, if it has n distinct eigenvalues. Yeah, basically if it has n, basic definition is if it has n linearly independent, if it has n linearly independent eigenvectors, if it has n linearly independent eigenvectors, if it has n linearly independent eigenvectors, ठीक है? If it has n linearly independent eigenvectors, clear? Then it is said to be diagonalizable. For n linearly independent eigenvectors, it should have n eigenvalues. It should have what? N eigenvalues. Clear, everybody? It should have the n eigenvalues. ठीक है? ठीक है? Only for CS, congrats. Only for CS. Not very big, not very much important, but it is there for CS. ठीक है, चलो जी, चलो 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 चलो. Okay, so I think time to call for a break. Time to call for a break, and we go for a lunch break. I thought of completing linear algebra, but yeah, I think Kylie Hamilton is left. Kylie Hamilton is left. बहुत ज़्यादा time लग रहा है, but no problem. A lot of time is being spent here, but no problem. Let's do it. Okay, so we call for a lunch break now. Okay, we call for a lunch break now. ठीक है, we call for a lunch break now. Don't worry. Evening नहीं तो evening से ज़्यादा पढ़ेंगे, but we'll try to cover more. Idea, see guys, I'll tell you my problem, whether it is problem or what I don't know. But when I start teaching any topic now, automatically थोड़ा उसमें depth चला जाता है. Okay. Otherwise, I can just tell you property, formula, and over. That also I don't want. So if a topic is taking time, let it take time. But at least it should be thorough. It should be thorough. It should be complete. Okay. It should be thorough or complete. So how much time lunch break? Yeah. Let's not take it more. Let's not make it more. Yeah. Lots of things to study. So let's make it 20 minutes. Let's not extend it. Okay. I hope you will all be ready after 20 minutes. I hope you are all ready after 20 minutes because lot of things to study. Okay. 30 minutes का नहीं करेंगे, 20 minutes करेंगे. Okay, 20 minutes करेंगे. And yeah, before I leave, let us set the timer. Okay, for 20 minutes. Okay, so we resume at 2:05 p.m. Okay. 2:05 p.m. भाई पहले लीनियर अलजेब्रा थोड़ा सा कवर करेंगे, then I will decide the next chapter. I told you ना. Okay, next chapter and all, don't ask me. हाँ, I can only tell you next chapter, whatever is there, it is common for all. So everybody, whatever your branch is, civil, mechanical, electrical, electronics, computer science or whatever, it is common for all. Everybody is invited. If whenever I start a topic which is not in any particular branch, I will tell you that. Okay, आप उतना मान के चलो. But right now, okay, it is going to be for all branches. Okay, जी, so guys, see you in the 20 minutes. Okay, yes, break over. Yes, the break is over, guys, and come on, let everybody join back completely and quickly so that we continue our discussions. Okay, so चलो continue करते हैं. Linear algebra going on, vanilla. We are into the middle of linear algebra in a way. Okay. Hope audio video is clear, guys. Okay, perfect. Chalo, then I think it's good to go. Chalo. So let's resume the class. It's 2:10, I think. Yes. Yes, I also had my lunch quickly, Satya. Hope you all had your lunch, students. Hope you all had your lunch. Chalo guys, a quick review of some of the questions and then we move towards Kylie Hamilton and then we move towards the next topic. The minimum and maximum eigenvalues, just as a practice because it's important topic, so let's cover up some practice. So minimum and maximum eigenvalues of the matrix are given to you. What is the other eigenvalue? Now this question intent is not calculating all the eigenvalues. The other one is suppose lambda 3. So we have the sum of eigenvalues, that is sum of the eigenvalues, that is lambda 1 plus lambda 2 plus lambda 3 should be equal to the trace. That is the intent of the question. So we have minus 2 plus 6 and plus lambda 3 equal to the trace, and trace is sum of the diagonal numbers, that is eventually 7. So solving it, this is 4, 7 minus 4. The other eigenvalue is nothing but 3. Okay, so we can be expecting such simple cases also. Okay, sum of eigenvalues is always equal to the trace. That's what I told you. Next one. Two eigenvalues of a 3 cross 3 real matrix are 2 plus root minus 1 and 3. What is the determinant of P? What is the determinant of P? Now, dear, number one, determinant of any matrix. Okay, two of the eigenvalues are given, but we know that determinant is the product of eigenvalues, out of which two of them are given to me. Okay, now it is a real matrix. What is the important property applicable? It is a real matrix. Okay, real matrix means, okay, eigenvalues, if it is complex, it should be in conjugate pair. Okay, so the eigenvalues are, okay, 2 plus root minus 1 and 3, and if 2 plus root minus 1 is there, okay, that is 2 plus, under root minus 1 is imaginary iota. Okay, so then there will also be 2 minus I. Then there will also be 2 minus I. 100% if alpha plus I beta is there, alpha minus I beta must also be there. Okay, and then in that case, it is given by 2 plus I multiplied by 2 minus I multiplied by third eigenvalue, which is 3. This is gonna be 2 square minus I square, and 2 square is 4, I square is minus 1, so minus minus plus. So 5 multiplied by 3, final answer is 15. Clear everybody? Yes. The final answer is simply 15. The final answer is 15. Okay. Chalo. If K0 minus K transpose is an eigenvector, see, it's an NAT question. Eigenvector NAT question, but still we can do it by the same approach, same shortcut I told you. Okay. the corresponding eigenvalue for this eigenvector is. Now we know that whether you need to find eigenvector or if eigenvector is given, what you have to apply. Whenever you get a competitive level question, MCQ, NAT, anything, or MSQ question like we solved earlier, AX equal to lambda x, yaad rakhna. AX equal to lambda x, that is the fundamental you have to apply. So if I start with the AX calculation, I have 1 and minus 1 and 0. I have minus 1 and 2 and minus 1. I have 0 and the minus 1 and 1. Now when this is going to be multiplied by x, okay, what is the eigenvector? K, 0, minus k, where k is not known but k not equal to 0. Okay, so let's multiply them. Let's multiply. First row, first column. So k, 0, 0. So this is only k. Okay, this is minus k, 0, minus minus plus k. So ye 0 ho gaya. And this is 0, then 0 and then minus k. Okay. Now k is not required. That's what I told you. K is not required. Okay, but definitely it should be corresponding to lambda into x. Ax should be equal to lambda x. That is what you need, na? What you have to match is now, dear, Ax should be lambda x. What is that corresponding eigenvalue? Okay, so Ax after multiplication is k0 minus k. Okay, should be lambda into x. Okay, x is k0 minus k. Same numbers have been obtained. K0 minus k. Okay, so solving it, it is lambda equal to 1. Everybody? Yes, correct. Okay, lambda equal to 1. Meghna, if it is a 5 cross 5 any general matrix, then the conventional method mod of a minus lambda equal to 0. But such problem will not come for gate. It will be some using some properties. Maybe it may be a triangular matrix or sum of every element, sum of elements of every row, something like that. Some property based only. Now, what property depends on the matrix given? That I can't generalize. But don't worry, conventional question full mod a minus lambda for 5 cross 5 will not be there for you. Okay, will not be there for you. Don't worry about that. Okay, don't worry regarding to it. Okay. Next question. Okay. Let there be a matrix. There's a MSQ question, dear. There is a MSQ question. Okay, multiple select. Let there be a matrix 4x, x9 and determinant of m equal to 0. Which of the following is or are correct? Okay. Which of the following statement is or are correct? Okay. So, is it a symmetric matrix? Is it a symmetric matrix? Tell me. Is it a symmetric matrix? Of course, elements above and below the diagonal are identical. They are mirror image. Okay. Whatever diagonal forget, elements above and below the diagonal are equal. So it is definitely symmetric. Okay. It is definitely symmetric. Yes, A to correct hai. Okay. Now, is it invertible? No. Okay. For matrix to be invertible, what is invertible? Inverse should exist. And inverse will only exist if the mod A not equal to 0. Okay. So mod A equal to 0, it cannot be invertible. It cannot be invertible. Okay. One of the eigenvalue is 13 and the eigenvectors are orthogonal. Okay. Chalo. Now determinant m0 hai na. So how to proceed forward is for the other two options. Okay. First two options are straightforward. Basic fundamental pe hai. Okay. Next two are eigenvalue, eigenvector. Determinant m0 given hai. Determinant means 36 cross multiply. If I cross multiply, I am getting 36 minus x square equal to 0. Giving you x is square 36, x equal to plus or minus 6. So giving me x is equal to plus or minus 6. Okay, so what is the m? It may be then equal to 4 and 9. This is plus minus 6. This may be plus minus 6. Either both 6 or both minus 6, but that is not conclusive as of now. Okay, but whatever symmetry is there, it is non-invertible. Now, one of the eigenvalues 13 and eigenvectors are orthogonal. So, dekho, if you now try for the characteristic equation, lambda square minus trace, so 4 plus 9, 13. Okay, trace 4 plus 9. Okay, 2 cross 2 characteristic equation. Ready? Lambda square minus trace into lambda plus determinant. Now, what is the determinant? Is 0. Baba, ye to bola ye is 0. Okay, so you have lambda into lambda minus 13 equal to 0. So, lambda is 0 and 13. Achha, determinant 0, one of the eigenvalue is 0. वो तो ऐसे भी बोल सकते थे. Okay, so one of the eigenvalue is 13. Yes. Okay. Now, eigenvectors are orthogonal. Eigenvectors are orthogonal. Yes or no? Tell me. Eigenvectors are orthogonal, yes or no? Dekho, now this matrix becomes a real symmetric. Symmetric to pehle hi bol diya tha, but all elements including x are also real. So it is real symmetric. The given matrix is real symmetric. and you have lambda 1 not equal to lambda 2. You have lambda 1 not equal to lambda 2. Eigenvalues are distinct. Eigenvalues are distinct, 0 and 13. Okay, so that simply means whenever you have distinct eigenvalues, corresponding eigenvectors are orthogonal. That means the eigenvector, whatever it is, x1 and x2, they will be perpendicular to each other. Dot product 0 hoga, so D is also correct. A, C, D. Okay, so it's a fundamental and conceptual question. I would put it like this. Okay, but good question. Good question for MSQ. It's A, C, D. It is going to be A, C, D. Okay. It is going to be the A, C, D. Next question. Okay. If A is a matrix given to you 1, 5, 6, 0, 3, 4, 0, 0, 2. Okay. MSQ question again. Okay. MSQ question again. Then the eigenvalues of 2A inverse plus 6 adjoint A plus A square are this. Eigenvalues of the matrix A. Acha dekho, A is directly known to me. What is the matrix A, dear? What is the matrix A? Upper triangular? Isn't it? Very clearly seen that all elements fit in the upper triangle. Elements below the diagonal are 0. Okay. For any triangular upper or lower, lambda is 1, 3, 2. Diagonal entries. For upper or lower triangle, no efforts required, na? Okay, no elements required. Kaun sa wala, Shivam? Definition of eigenvalue means, Manasvi, that is discussed, na? What is that now? Okay. 1, 3 and 2. For upper triangular matrix, we already know eigenvalues are diagonal elements. Already discussed 2 cross 2 eigenvalue characteristic equation kaise hota hai. Watch it before the break. The concepts are discussed before the break. You can watch it out. Okay. So eigenvalue 1, 3, 2. B to correct hai. Now, if the eigenvalues of A are known to you, dekho. Eigenvalues of A, that is 1, 3, 2. Correct. So what is the eigenvalue of option C? Chalo, simple wala start karte hain. For 2A plus 5I, what I told you, any algebra, any operation you apply on A, same applicable, okay, same applicable to the eigenvalue also. Okay, so 2A, what is the eigenvalue for 2A? Okay, it is 2 into 1. एक एक करके करेंगे. 2 into 1. Okay, plus 5 into I. So plus 5 into I. Numbers में I will be 1. So simply plus 5. Okay. So eigenvalue will be simply, yeah, if you want to generalize, it can be written as eigenvalue will be corresponding to lambda plus 5, I will be 1. So eigenvalues will be 2 lambda plus 5. That is corresponding now, but lambda 1. So 2 plus 5, 7. Okay, 2 3s are 6, 6 plus 5, 11. 2 2s are 4, 4 plus 5, 9. 7, 11, 9. Correct. C is also correct. Okay, C is also correct. Okay. Eigenvalues of A cube are, अरे ये तो simple है. Eigenvalues of A cube are lambda cube. Okay, so 1, 3 cube 27, 2 cube 8. Okay, so BCD तो correct है. A में adjoint A भी है, no problem. Okay, how do you write down adjoint A? So now I have, okay, option number A पे चले जाएंगे, and that is 2A inverse plus 6 adjoint A. 2A inverse plus 6 adjoint A plus A square. I told you what to do for adjoint A. This is 2A inverse plus 6 into adjoint A. Adjoint A is known as mod A into A inverse. Okay, plus A square. This is further equal to 2A inverse plus 6 into adjoint A. What is the adjoint A? Okay, what is the adjoint? What is the determinant of A basically? Product of eigenvalues. So determinant of matrix A is 6. Determinant is 6. So 6 into 6. A inverse plus A square. So this final calculation is like 2A inverse plus 36A inverse. अच्छा तो 2 plus 36 ऐड कर देते हैं. So this is eventually 2 plus 36, 38A inverse plus of A square. 38A inverse plus of A square. So eigenvalue will be 38 upon lambda plus lambda square. Put 1 by 1. Lambda is how much? 1, 2, 3. Put 1 by 1, 1, 2, 3. So 38 by 1 plus 1, 39. Okay. 3 को रखेंगे. 38 by 3 plus 3 square. ये cancelable नहीं है. Is everything going fine in the place? That was 2A inverse plus 6 adjoint A. Adjoint A के लिए mod A चाहिए था. That is 6, 6, 6 are 36 and that is A inverse. Perfect. So it is not divisible. So ये answer. अच्छा, it is in the fraction only. Good, good. So this is how much? Okay, next is 38 by 3 plus 9. Okay, and next is 2. 38 by 2, 19. Okay, plus 2 square, that is equal to the 4. Okay, so the final answer are 39. Okay, 27 plus 38. Okay, that will be 65 by 3, correct? And 19 plus 4, 23. 39, 65 by 3 and 23. So that is also correct. So basically MSQ means Sometimes all options correct, sometimes one correct, sometimes two correct, sometimes three correct. Like last question, three correct. Here it is all four correct, A, B, C, D. But these are important properties. I told you property number 6 pe hai, and I already told you 6 is the important property. 6 is the important property. Okay. Okay, next one. Tell me the next one. If A belongs to M3, that is a set of all matrices of size 3, be such that determinant of I equal to 0, okay, where I denotes the 3 cross 3 identity matrix, trace of A is 13, determinant of A is 3. Now see, देखो, one by one, statement by statement चलेंगे. If A belongs to the set of all real matrices of size 3, मतलब A is 3 cross 3 real matrix, सबसे पहले तो ये बोला है. A is a 3 cross 3 real matrix such that determinant of I equal to 0, modulus of A minus I equal to 0. I'm sorry. So determinant A minus I equal to 0. Okay. Okay. No problem, Bhanu. After lunch break, maybe 100 people slept. No problem. I always telling you, this, sometimes numbers demotivates me also. But how many apply? How many fill the gate form? Okay. How many appear? How many seriously prepare? Okay, seriously prepare means 80%, yeah, at least 80% syllabus complete. How many do the revision, mock test, everything? Okay, that always shrinks. That always shrinks. Okay, that always shrinks. So no worries. I know that is a mentality, that is a temperament of gate student. Now see, only studying linear algebra before the break part is not going to excel 13 marks. I told you for 13 out of 13, you have to score any maximum number in maths. You have to stay for the entire 2 days. Okay. Chalo. So I is a 3 cross 3 identity matrix. Determinant of A minus I equal to 0. If the trace of A is 13 and determinant 32, then sum of the squares of the eigenvalue. It's a good question. It's a good question. It's a good question. Okay? It's a good question. No, Priyanka. Any partial correct answer, 0 marks. Okay. No. You don't get any partial marks in MSQ. Okay. No partial marking, no negative marking also. Okay. Chalo ji. So देखो, what does the statement say is determinant of A minus I equal to 0, but we know determinant of A minus lambda is also 0. Okay. So we can say that one of the eigenvalue is 1. One of the eigenvalue is 1. At least one of the eigenvalue is 1. Clear? Okay. Now trace of A is 13. Trace is sum of all eigenvalues. Trace of sum of all eigenvalues, suppose lambda 1 plus lambda 2, and one of them is known to me is 13. Okay, so sum of the two eigenvalues will be 12. Determinant is 32. Determinant ka matlab hua lambda 1, lambda 2 into third one. This determinant is 32. So lambda 1 into lambda 2, the product is 32. Clear everybody? Sum is 12, product 32. Okay, by combining these two, you can even get the values. Easy guess, yaar, 8 and 4. Easy guess, 8 and 4. Lambda 2 equal to 8. Lambda 1 है ना ये? Lambda 1 equal to 8. Lambda 2 equal to 4. 8 and 4. 8 plus 4, 8 into 4. 8 plus 4, 8 into 4. Done है. This is 8 into 4. और बताइए. This is known as 8 into 4. Tell me anything else. This is 8 and 4. Because modulus of A minus lambda is 0 and modulus of A minus I is 0. So you can compare and say lambda 1. Na? Okay. So sum of the squares, yaar. Question is sum of the squares. Question is complete. 64 plus 16, answer is 18. Sum of the squares of them is 80. Answer is D then. None of them is matching up, na? Correct? Sum of the squares of the all eigenvalues, not the other two only. Okay. For all. Sum of the squares of all. Okay. So plus 1 bhi aayega. Okay. So that is going to be 81 then. 80 nahi, 81. B is the correct answer. ठीक है. Okay. Anwar, I just explained how one of the eigenvalue is 1. Look into this. Modulus of A minus lambda I is 0, na? Okay, hope that is correct. So answer is 81 then. Okay, answer is known as the 81. Chalo. Okay. Now one question from GATE exam. Okay, 5 cross 5. 5 cross 5. कैसे solve करेंगे 5 cross 5? How will I be able to deal with 5 cross 5? I can deal with that easily. Not a big worry. I can deal with that easily. Because they are not asking all eigenvalue. I told you, na, when it is higher size, it may be some property involvement. Okay. Tell the doubt, Mayur. Tell the doubt. Consider the matrix 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 4, 5, 1, 2, 3, etc., etc., etc. So what you're able to see that all elements are identical. They are just rotated. 1, 2, 3, 4, 5, then right rotate. Right shift. 1, 2, 3, 4, 5. You have a circular rotation basically. 1, 2, 3, 4, 5 here. So that means all elements of a row is identical. They are just rotated, rotated, rotated. Okay. That means if all the elements are identical, their sum will be same. Sum of elements of each row is 1 plus 2 plus 3 plus 4 plus 5, and that is 15, and that is equal to same. Sum of elements of every row is same. Sum of elements of every row is same. Then one of the eigenvalue is equal to that sum. Okay, and that is 15. अच्छा, अब क्या बोला है? It is given that A has only one real eigenvalue. It will have 5 eigenvalue, but it is given that it has only one real eigenvalue. Rest 4 will be complex. What is that real eigenvalue? So definitely that real eigenvalue, already the eigenvalue that you have got is 15, and they are telling there is no other real eigenvalue. So this is the only real eigenvalue, 15. Answer is C. That is why it is one marker, because it is pure property based. One marker, pure property based. Next one. Number of distinct eigenvalues of this matrix. Again, a matrix coming up where all elements are 1. Okay. Rank of the matrix is 1. Yeah, already discussed, Baba. Already discussed. Isko repeat nahi karenge. Matrix has all elements 1. That means all rows are identical. All rows are identical to rank 1. All rows are identical to rank 1. Ab distinct eigenvalues kitni hogi? Baba, eigenvalue pucha hai, not rank. Okay. Eigenvalue pucha hai, not rank. But what is the relation between rank and eigenvalue? I am able to talk about rank. Okay. What is the relation between rank and eigenvalue? What is the relation between rank and eigenvalue? Okay, great, Alok. Okay. What is the relation between rank and eigenvalue? Rank is also equal to number of non-zero eigenvalues. Number of non-zero eigenvalues. Okay. So, dear, for this matrix, what will be the eigenvalues? Okay, it is an n cross n matrix, na? So it will have n eigenvalues. N cross n matrix, it will have n eigenvalues, but out of them, only one non-zero eigenvalue. The rank is number of non-zero eigenvalues, so only one non-zero eigenvalue, and suppose that one non-zero eigenvalue is lambda, but rest all, 110%, rest all is 0. Okay, rest all is 0. Okay, rest all is 0. Only one non-zero, rest all 0. Rest all 0. Now apply the property. Okay, sum of eigenvalues is equal to trace. And here, what is the trace of this matrix? All diagonal elements are also 1. So 1, 1, 1, 1, 1, 1, 1 n times. It will be n. 1, 1, 1, 1, 1 n times, it is n. So lambda ka value bhi aa gaya n. Lambda bhi aa gaya n. So what is the eigenvalues of this matrix? Eigenvalues of this matrix, it is n 0, 0, 0. But how many of them are distinct? Ab batao, distinct kitni hui? Okay, how many of them are distinct? Even if you don't calculate lambda, that is okay. But all of these are 0. Okay, and 1 is lambda. So how many are distinct? Ek hai lambda, ek hai 0. Ek hai lambda, ek hai 0. How many are distinct? It's only 2 independent of the value of n. Okay, it's only 2. Okay. Okay, these are only 2 distinct eigenvalues. Okay, these are 2 distinct eigenvalues. Okay. But yeah, in general, if any such matrix is given where all elements are 1, okay, the eigenvalues are given by lambda. Lambda ki jagah aa gaya n. The eigenvalues, if it is an n cross n matrix, okay, the eigenvalues of this matrix are now known to you. You can remember. Eigenvalues are simply given by n and 0, 0, 0, 0, 0. Okay. Say for example, okay. Say for example, if such a matrix is given to you. What are the eigenvalues? What are the eigenvalues? Tell me. What are the eigenvalues? Okay. So again, all elements 1 and it is a 4 cross 4. So eigenvalues are only n and 0. N here is 4. Okay. So 4 and rest 3 0. 4 triple 0. The eigenvalues are 4 triple 0. The eigenvalues are 4 triple 0. अब यहाँ पे एक और good question बनाते हैं. Sometimes the question may be on determinant, but it has to be solved using eigenvalue if you want to solve it quickly. Find the determinant of Find the determinant of this matrix. Tell me, बताइए. Find the determinant of this matrix. Yes, Banu. Eigenvalue only for square matrix. Chalo, now, देखो, how to solve this problem? There, the given matrix A, can I break it into two parts? See, all the elements are 1 except diagonal. Nahi, Baba, if you are giving 32, you are multiplying diagonal numbers. How can you do so, dear? The determinant is equal to product of diagonal numbers only for a triangular matrix. You cannot use any property blindly. Every condition has been mentioned. That is only for diagonal elements. If you say 32, it is wrong. Okay. Now, all the elements are 1 except the diagonal. Except the diagonal. Diagonals are 2. One more except the diagonals. So let's say diagonals are also 1. For a moment, let us say the diagonals are also 1. Okay. But then our diagonals are 2. So what I can do, I should add 1 to all the diagonal elements. Okay. So that means now I take another matrix which has only diagonal elements as 1, and that is the simple identity matrix. That is the simple identity matrix. Correct. Add 1 to all the diagonal numbers, you get the above matrix. Okay. You get the above matrix. Okay. Now, okay, let this matrix be, dear. Let this particular matrix be some matrix B. Okay. So I have the matrix A. I have the matrix A, which is B plus I. I have the matrix A, which is B plus I. Okay. What are the eigenvalues for B? What are the eigenvalues for B? Eigenvalues for B will be equal to, B is the matrix, okay, in which all elements are 1. So eigenvalues will be size of 5. So 5 and 0, 0, 0, 0. Okay, n minus 1 zeros and one of them is n. Okay. Determinant add nahi karne wale. No, determinant we are not going to add. Very clear, I am not going to add the determinant. Okay. I am not going to add the determinant. I am using eigenvector property, eigenvalue property. So this is 5 and 0, 0, 0, 0. That is lambda. So what should be the eigenvalue for B plus I? Again, guys, property number 6. Again, property number 6. If eigenvalue of B is lambda, for B plus I it is lambda plus 1. Okay, so all eigenvalues added with 1. So it is 6, 1, 1, 1, 1. Okay, it is 6 and 1, 1, 1, 1. Okay, so now this is known as matrix A. Okay, so what is the determinant of any matrix? Is product of eigenvalues. Okay, product of eigenvalues. So determinant of the matrix is 6, and we are not going to add it. Whenever two matrices are added, determinants is not added. ये proof भी हो जाता है ना यहाँ पे. Determinant of this matrix will be 0. Determinant here is 1. So 0 plus 1, 1 आना चाहिए. My answer is 6. So you cannot add determinant. You cannot add determinant. Remember, देखो, you can do it like this. Determinant of A plus B, is it equal to determinant A plus determinant B? Please don't apply this, not equal. But हाँ, multiplication में it is applicable. Determinant of AB is determinant A, determinant B. ये use कर सकते हो. Okay, ये use कर सकते हो. ठीक है? Okay, चलो. That's it. That's it. Say the doubt, Ravi. Okay, the answer is 6 into 1 into 1 into 1 into 1. That's it. ठीक है? So this matrix where all elements are 1, okay, this becomes a special case. I mean, we can build questions around this. And whenever all elements are 1, the eigenvalues are n and 0, 0, 0, 0, 0, where n is the size. N and remaining all zeros. How many total eigenvalues? We know, na? We know, na? How many total eigenvalues? Total n. So one of them non-zero, remaining n minus 1 zeros. Clear, clear, clear. Okay. Done. This is done. Let's move ahead to the next question. Yeah. The number of linearly independent eigenvectors of the given matrix. Tell me. Number of linearly independent eigenvectors of the given matrix. The number of independent eigenvectors of given matrix is equal to how much? Is number of distinct eigenvalues. Property number 16, जहां पे diagonalization concept की बात की थी. That is equal to number of distinct eigenvalues. Number of distinct eigenvalues, and distinct eigenvalues, how many? देखो, what are the eigenvalues? This is again upper triangular. Elements below the diagonal are 0, 0, 0. It is an upper triangular matrix. Okay, so what are the lambdas? For any triangular matrix, eigenvalues are just the diagonal numbers. That is 2, 2, 3. That is 2, 2, 3. So how many of them are distinct? 2, 2, 3. 3 eigenvalues, but ये एक repeat हो गया. Distinct में count होगा only 2 and 3. So how many? That is 2. That is your answer. That is 2 and that is your answer. ठीक है? That is 2. That is the answer. चलो. Next area to be related with. Next area to be related with. Okay, the eigenvalue, eigenvector theory only. That is the Cayley-Hamilton. You know, again an important area. Questions are expected only on the Cayley-Hamilton part also. Okay, only on the Cayley-Hamilton part also. Okay. Now, it states that every square matrix, okay, every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. Okay. Now, how to apply it? Let's understand directly by a problem. Whether it is 2 cross 2 characteristic equation, maybe 3 cross 3. I'll explain you directly with the problem. Only thing is, you know, where to apply Cayley-Hamilton, that is not mentioned with any question. You have to understand. So whenever question talks about higher powers of a matrix, yeah, whenever question talks about inverse calculation of a matrix, you can think about Cayley-Hamilton. Example, given the matrix A, find A power 9. Now you may think matrix A is given and I know how to multiply. So I'm multiplying, I can form A power 9. But that is a calculative and lengthy approach. There is a calculative and lengthy approach, isn't it? So what is A power 9? That is a calculative and lengthy approach. So what is the A power 9? Okay. So for A power 9, higher power, think about Cayley-Hamilton theorem. Question will not tell you that you have to apply Cayley-Hamilton theorem. Okay. So, but for Cayley-Hamilton, always what you need is the characteristic equation. This is 2 cross 2, lambda square. Okay. Minus trace lambda. Okay. Minus trace into lambda. So what is the trace? What is the trace? It is 3 minus 3. Minus trace into lambda plus determinant. Determinant हो गया minus 3 minus 3 minus 3 minus 9 and then minus 1 equal to 0. Trace part 0 हो गया. So we have lambda square. Okay, minus 10 equal to 0. This is only the characteristic equation here. Now what does Cayley-Hamilton says? Cayley-Hamilton says that every square matrix will satisfy. Every square matrix will satisfy its own characteristic equation. Okay, that means in place of lambda, you can replace A. The matrix A will satisfy this equation. To satisfy karenge in place of lambda, so you have A square. Only thing is, guys, be very careful. A and, you know, with any matrix, whether A or A square, you can't add or subtract a number. It has to be matrix only. So whenever there is a simple number, multiply by unity matrix. So minus 10i equal to 0. So this is giving you A square equal to 10i. But my question is A power 9. So how will I build A power 9? First of all, I can break it as A power 8 into A. And A power 8 is A square, then power 4. Okay. A power 8 can be written as A square power 4. That is 10i power 4 multiplied by A. And 10i power 4. 10 power 4 is 1000. 10,000. I power 4 is I only. No need to write. It's just 1 and then A. 10,000 A. Answer is option number A. 10,000 A. That is how simply you can solve. This is known as the 10,000 A. This is known as what? This is known as the 10,000A. Clear? This is the 10,000A. Chalo, done. Next question then. Okay, 10,000A. Done. Next question. Okay. If a matrix A, 4 cross 4 matrix it is, okay, then what is A power 4? Then what is A power 4? Again, higher power. Higher power means think about Cayley-Hamilton theorem. It's not you have to multiply it. 4 cross 4 multiplications will even be more lengthy. Think about Cayley-Hamilton. Since it is a 4 cross 4 calculation, you can start thinking about Cayley-Hamilton now. You can start thinking about Cayley-Hamilton. So let's do it. Let's do it. 2, 0, 0, 1, yeah, whatever it is. But one property that you're able to feel here is all the elements below the diagonal. All the elements below the diagonal are 0. It's an upper triangular. It's an upper triangular matrix. Upper triangular. So directly I know the eigenvalues. I don't need eigenvalues, but okay, let me see. Because it is upper triangular, at least I know the eigenvalues. What are the eigenvalues? All the diagonal elements. That is 2 and minus 2. 2i and minus 2i. But for Cayley-Hamilton, I don't need eigenvalues. I need the characteristic equation. I need the characteristic equation. Now, characteristic equation क्या होगा? I need the characteristic equation. So, eigenvalues are nothing but roots of characteristic equation. Na? Okay, so what will be the characteristic equation? Equation whose roots are 2, minus 2, etc. Okay, so suppose, how should be the factor if the 2 is the root? I should have the factor lambda minus 2. Similarly, I should have lambda plus 2. Similarly, I should have lambda minus 2i. Similarly, I should have lambda plus 2i. This is equal to 0. This is equal to 0. So, a minus b, a plus b, a square minus b square. So, lambda square minus 4. Again, a minus b, a plus b. So, lambda square minus 2i ka square. I square is minus 1. So, that becomes plus 4 basically. Okay, this is equal to 0. Again, a minus b, a plus b. So, lambda power 4 minus 4 square. That is 16 equal to 0. A minus b, a plus b. Now, apply the Cayley-Hamilton. Cayley-Hamilton says that every matrix will satisfy its characteristic equation. Okay, so substitute the matrix A here. Okay, so you get A power 4. Minus 16. Only difference is you should not write 16. You should write 16i with the matrix. Okay, so directly your answer is known. A power 4 is 16i. 16i. Answer is C. Everybody okay? The answer is known as the C. Right, everybody okay? Answer is the 16. Okay, next question dear for you. Here it is. Okay, 1 minus 1, 2 is the eigenvalue of a 3 cross 3 matrix. The matrix is not given, but directly the eigenvalues are given. 1, minus 1 and 2 are the eigenvalues. Okay, now write the equation. A inverse is 1 by k a square plus b a plus ci. Okay, then find the value of k into a plus b plus c. Convert it into numerical answer type. Tell me the answer quickly. Converted this one into the numerical answer type. So please tell me the answer quickly. Chalo, tell me the answer guys quickly. Chalo, tell the answer guys quickly, just a second. Yes, by the ax equal to lambda x minus p, corresponding eigenvalues can be determined. Na? Chalo, tell me. So guys, again, inverse and higher power involved. Okay, inverse and higher power involved. So we can think about Cayley-Hamilton theorem. Okay, Now eigenvalues are given, which are the roots of characteristic equation. So what should be the characteristic equation? Just like the previous question, I can form lambda minus 1, lambda plus 1, and then lambda minus 2. This should be the factor so that you get the eigenvalues as 1, minus 1 and 2. Okay, so we have lambda square minus 1, a minus b, a plus b, then into lambda minus 2 equal to 0. Now keep multiplying, you have lambda cube, okay, minus 2 lambda square minus lambda plus 2 equal to 0. Lambda cube minus 2 lambda square minus lambda plus 2 equal to 0. Correct hai? Correct hai? Now apply the Cayley-Hamilton theorem onto it. So as per Cayley-Hamilton theorem, you can replace, you can substitute a here, so a cube minus 2a square minus a plus 2i, again plus 2i equal to 0. Okay. So dear, now let me take this. I want in the form of inverse. Okay, let me take this a cube minus 2a square minus a, और क्या है? A cube minus 2a square minus a plus 2i equal to 0. Multiplying throughout by a inverse. चलो यहीं पे कर देते हैं. Multiplying throughout by a inverse will not affect the right hand side because a inverse into 0 is 0. This is anyway 0. A inverse into 0. Okay. So a inverse into a square. A inverse into a cube. A inverse into a will get cancelled. A square बचेगा. Then a inverse into a. Once cancelled, 1a is left. A inverse into a is I. Okay. Plus 2a inverse equal to nil. So here we can write down the expression. Now what is going to be the a inverse? This is 2a inverse. So when you write a inverse 1 by 2 of how much? All the other terms पहले start करेंगे a square के साथ. So when you shift it on the other side, this is minus a square, then plus 2i and plus a, plus 2a, sorry. This is plus 2a and plus I. This should be the answer, and this is what is known as the value of k, a, b, c. Question is k into a plus b plus c, correct? Write down the answer k into a plus b plus c. That is the numerical answer type question. So 2 into minus 1 plus 2 plus 1. 1 cancel. 2 2's answer should be the 4. Everybody? Okay, correct. The answer is 4. Numerical answer type data 4. Correct answer Bhanu, Arin and Nishu. Yes, it's going to be 4. Everybody. The correct answer is 4, no doubt. Let's move ahead to the next question then. Okay, let us move ahead to the next question. The answer is 4. ठीक है, डन है. चलो, either by the beta 1, beta 2, beta 3 if the matrix is given power, otherwise by the factors, by the roots given. The roots of characteristic equation are the eigenvalues. Here the eigenvalues are given directly. ठीक है. So yes guys, just a quick and an important reminder for all of you. A quick and important reminder for all of you. Here it is. Okay, the T20 series. Okay, for all ECEE aspirants. Okay, mathematics guys, whatever we are studying is common for all branch, but exclusively for ECEE students on the same BYJU'S exam prep ECEE ECS YouTube channel. Okay, we are beginning a T20 series from 23rd January. Wherein we will cover 20 important questions. 20 important questions from every subject. So different subjects will be taken and 20 important questions will be there for all. Okay. Okay. Timing and complete chart I will bring tomorrow. I don't have it right now, but if you are asking the timing, the schedule, okay, I'll tell you tomorrow. Okay, I'll confirm with the team and I'll tell you tomorrow. Okay. So here the target will be technical subjects. Here the target will be technical subjects. Okay. Chalo. Different technical subjects. Chalo. So guys, this is the mathematics. Yes, date for signal system marathon I'll announce tomorrow. Okay, it will be there for you. I'll announce that tomorrow. Exact date. Okay, so engineering maths complete revision mathematics going on 21st of January. Today is the first day, 21st of January. We are into the part 1. We started at 10 a.m. Okay, we are going to continue till whatever time we can. There is no end. There is no end to it. But yes, the part 2, okay, will be happening tomorrow 10 a.m. Okay, tomorrow 10 a.m. Whatever we leave, okay, the remaining topics we'll do tomorrow. You have to give me the entire 2 days, okay, to ensure you get maximum in maths. Okay, to give maximum in maths. Chalo. Okay, ji. Now, beginning up with the concepts of calculus. Important concepts from calculus. The important concepts from calculus. Okay, continuity and differentiability se start karenge, of course. the continuity and differentiability to be taken up first of all. Again, this is a topic there for all branches. Okay, this is a topic there for all the branches. Chalo ji. Okay, conditions for continuity. Okay, the first condition for continuity is all branches. Bhai sabhi ke liye hai. When I say all branches means whatever your XYZ branches, don't ask me separately. All means all. If it is not there for any branch, I will tell you. But this is for all engineering branches. Okay, so calculus is there for all branches. Now. Say for example, you talk about a function. Let me take a specific example. An important function like floor function. Okay, known as the largest integer function or also known as the GIF function. Commonly GIF बोल देते हैं इसको. GIF is greatest integer function. Like largest integer function, we also call it as greatest integer function, GIF function. ठीक है, GIF function. Okay, that is the floor function. Okay, that is the floor function. Okay, fx equal to floor x. Now, what is the meaning of the floor function? Floor means the floor, whatever is below me, where I am standing, that is floor. And whatever is above me is the ceiling. Clear, na? Okay, the other function will be the ceiling function. So, simple logic is, okay, कुछ functions भी पता होने चाहिए, तो वो भी बता देता हूँ मैं simply. If I ask you, if I give you a number, 2.83, what is the floor value of this? 2.83, what is the floor value of this? Okay. It's 2. What is the floor means below? Integer which is below it is 2. Okay. And if I ask you the ceiling, the integer which is above it, that is equal to 3. That is equal to 3. Simple, na? That is what I mean. Acha, if it is any integer, suppose if I take 10, whether you take floor of 10 or whether you take ceiling of 10, it remains to be 10. If you are at integral value, floor or ceiling is same. You are already at that point. That will be 10 only. If it is negative, कभी कभी नेगेटिव में गड़बड़ करते हैं स्टूडेंट्स. सो इफ इट इज -5.6, what is the floor of -5.6? What is the ceiling of -5.6? What is the floor and ceiling of -5.6? Tell me. What is the floor and ceiling of -5.6? Tell me, everybody. For -5.6, what is the floor and ceiling? देखो, the negative number, okay, we always talk with respect to increasing value of x. Okay, negative number line में -6 पहले आएगा, then -5, -4, -2. That is how we advance. And -5.6 in between them. So नीचे -6 आएगा. Be very careful. What is below is -6. What is above is -5. Okay? Okay? ठीक है. Now, okay. Okay. Ceiling of 2.3, 3. Just like this. 2.83 ceiling is 3. Even for 2.3 it is 3. ठीक है रवि? नहीं 4 नहीं आएगा विनय. -5 only. It is between -6 and -5. अब ये देखिए, this simply means that if I take, like this is 2.83 ना, if I take any value, whether it is 2.1, 2.222 या 2.83 जैसे लिया या even up to 2.99, if you take any of the values and try to calculate the floor, answer will be 2 only na. Answer will be 2 only. Okay, the integer below them is 2. Acha, if you touch 3, then the ceiling will be 3. Otherwise, it's going to be 2. Okay, if you touch 3, then the ceiling, sorry, floor की बात कर रहा हूँ. I'm sorry, not ceiling, floor. Let me fix to one function, floor. So, for 2.1, 2.22, etc., up to 2.99, the floor is 2. The integer below them is 2. But when you touch 3, the floor will be known as 3 only. The floor will be known as 3 only. Clear? That means if you take any integer between 2 to 3, but less than 3, the floor will be 2. If you take any integer between 2 to 3, floor will be 2. But as soon as you touch 3, floor value will change. So, when you plot this function, dear, when you plot this function, okay, when you have any value between 2 to 3, isko dekhna. Okay, the floor of 2 is 2, we know. But even if you take any value between 2 to 3, floor will be 2. But as soon as you reach 3, floor value suddenly becomes 3. Okay, suddenly becomes 3. Okay? Okay, now, any value between 3 to 4, 3 to 4, floor will be 3. Okay, and then when you reach 4, the value suddenly becomes 4. Okay, the floor value suddenly becomes 4. Similarly, 4 to 5, answer will be 4. When you achieve 5 and you remain up to 6, answer will be 5. And etc., etc., etc. Similarly, मैंने 2 से start किया. If you take any value 1, Okay, but less than 2. One state starting from 1 but less than 2. Floor will be 1. Similarly, if you had taken any value, okay, starting from 0 but less than 1, floor value will be 0. Okay, so this is what I'm trying to plot floor x. And when you plot floor x, you get a staircase function. This is also known as a step function because the function is increasing in step, or also known as a staircase function. Step function or staircase function. Now, the function or the name of the function is not important here. Concept. What is the concept we are trying to pick up? Suppose here, let me pick up any value, say for example, x equal to 3. Let me pick up any value, say for example, x equal to 3. Say for example, x equal to 3. Say for example, x equal to 3. What is going to happen? See, when you see the function graphically from left side, when you approach x equal to 3 from left side, or when you approach x equal to 3 from right side, now approaching a value is represented in the form of limit. Okay, now I want to calculate the value of the function fx, okay, when x tends to 3. Okay, but limit is broken into two parts, left hand limit and right hand limit. Any limit is broken into two parts, left hand limit and the right hand limit. Okay, so when I say limit x tending to 3 minus fx, that is known as the left hand limit. That means you are approaching x equal to 3. But from where? नीचे से भी आ सकते हो, ऊपर से भी आ सकते हो. So when you are approaching x equal to 3 from the left side, that is left hand limit. Okay, limit x tending to 3 minus, what is the value of the function? So when you are approaching x equal to 3 and you look into value of the function, थोड़ा left की तरफ से देखोगे, dear everybody observe, थोड़ा left की तरफ से देखोगे, the value is 2 ना, थोड़ा left की तरफ से देखा तो value equal to 2, value equal to 2. But थोड़ा right की तरफ से देखें, थोड़ा right की तरफ से देखें, so when you take limit x tending to 3 plus fx, okay, जब थोड़ा right से, when you are approaching the same value x, that is 3, but from right side, what is the value of the function seen? The value of the function seen is 3. Okay. Now the point is, we are approaching the same value x equal to 3. एक बार left, एक बार right से, but we come to a different values. Okay, left hand limit not equal to right hand limit, and whenever this is happening, see, the function is also broken here. देखो, the function is taking a constant value, suddenly it jumps. But this is a sudden jump. That means the function is broken here. And any broken segment, any broken point is what is a discontinuous point. इसको उल्टा समझो, what discontinuity is, so that I can explain you continuity. Any broken point on the curve represents a point of discontinuity, and hence the function is not continuous here. This is broken here. Okay. Left hand limit not equal to right hand limit, there is a discontinuity. And this discontinuity, this discontinuity is known as a jump discontinuity. Jump, because the value of the function suddenly takes a jump. Sudden jump. So at any point when you see a sudden jump matlab up or down, anything, when you see a sudden jump or maybe a sudden fall, it is a discontinuous point. Because at that point 100% left hand limit will not be equal to the right hand limit. And staircase is an example of such case. Okay, staircase is an example of such case. Okay, everybody? Okay, so that is known as jump discontinuities. So first thing required for continuity is left hand limit equal to right hand limit. But now have a look into another function, y equal to modulus of 1 by x. Guys, what is y equal to 1 by x? When you take y equal to 1 by x, you say that xy equal to constant. Xy equal to constant is what is known as a rectangular hyperbola. Xy equal to constant is the equation of rectangular hyperbola. This also means that y is inversely proportional to x. If x increases, y will decrease. Okay. If x will increase, तो देखो यहाँ पे आगे जाओगे तो y में नीचे आओगे. That is what it means, na inverse relation. If x increases, y is decreasing. Okay. Similarly on the third quadrant. Okay. Similarly with respect to the third quadrant also it is true. Magnitude of x. This is negative, but if you increase the magnitude of x here, the magnitude of y is decreasing. That is inverse relation. That is what inverse relation. Rectangular hyperbola. Okay, now what I have only done is I have taken the modulus of this function. Modulus means what? Any negative value of y will also be converted to positive. Modulus means negative. -5 also becomes +5 when you take the mod. So this will come to the plus side. This negative y will also come to the plus side and you get this equation. ठीक है? Now dear, what is the left hand and right hand limit here? ठीक है, इसको छोड़ दीजिए आप. Now come to this function and talk about x equal to 0. Come to this function and talk about x equal to 0. Talk about x equal to 0. Okay, when you approach the function, देखो, when you approach the function from left, नीचे की पीछे की तरफ से आएंगे, when you approach the function, okay, from the left or even from the right, it's like we are going to a common point. It looks like we are going to a common point. It looks like we are going to a common point. So at x equal to 0, left hand limit equal to right hand limit. But is the function continuous? A continuous matlab it should be without a break, na? But problem kya hai actually, you know, problem is 1 upon 0. When you actually put x equal to 0, 1 upon 0 is infinity. 1 upon 0 is infinity. Okay, you approach from left or you approach from right, you are going to a common point. It looks like you are going to common point, but where? You are going to a common point which is infinity. Does anybody know where infinity is? Can anybody reach infinity? Okay, you are trying to go to a common point, but you are trying to go to a point where you can never reach. Infinity is something nobody has seen. किसी ने देखा नहीं है infinity को. So you can never reach the point means the graphs will never meet. Graph will never meet means it is broken. Means it is broken. If suppose, ulta सोचना, if suppose you know the value of infinity, by chance, मान लीजिए you are very great and you know what is the value of infinity. Suppose you are a great person and you know this is the value of infinity. If suppose you know what is the value of infinity, then your graph will be something like this. तब तो graph ऐसा होगा ना, then it is continuous. There is no break. If you knew what is the value of infinity, then your graph is continuous because left hand limit, right hand limit, wherever you go, you reach to this point. Okay, you reach to this point whose value you know. ठीक है, अगर आपको infinity पता होता तो, but reality is we don't know where infinity is. Okay, infinity is. That is why left hand and right hand limits are equal, but you are going to a points which can never be attained. Okay, so graph can never be connected. Can never be connected. Broken hai. Okay, broken hai. So left hand limit, right hand limit equal, but the problem is f of 0. I am checking at 0. The f of 0 is undefined. आप ऐसी जगह जा रहे हो जिसका आता पता ही नहीं है. Okay, ठीक है. You're going to a place which nobody knows where is that place, and that is why f0 is undefined, and ultimately you have a broken curve. Okay, ultimately you have a broken curve. Discontinuous hai. Any broken curve is discontinuous at that point. Everybody clear? Everybody clear? Chalo. So that means not only left hand limit equal to right hand limit we need. We also need that the value of the function at that point must be known to us. 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 ठीक है? अच्छा. Next. One more problem. Have a look into this curve. Have a look into this curve, which is the floor of sin x for 0 less than x less than 2 pi. Let me not explain the entire curve. Curve you know about sin x. Okay, let me not explain you the entire curve, but let me explain you one calculation here. Look into this curve from 0 se pi by 2. Dear, when x is between 0 se pi by 2, okay, what is the value of sin x? What is the value of sin x? What is the value of sin x? We all know how sin x behaves. One period, okay, from 0, this is pi again, ये pi है, and this is pi by 2, maximum at pi by 2, ठीक है, maximum at pi by 2, this is maximum at pi by 2 and this is pi, ठीक है. So dear, when x is between 0 but less than pi by 2, okay, x is between 0 से pi by 2 including 0, what is the value of sin x? Sin x is between 0 to 1 less than 1. Only at pi by 2 it becomes 1. Only at pi by 2 it becomes 1. ठीक है ना? So it is less than 1 right now. So what is the floor sin x? By any value between 0 to 1, you are trying to take the floor of sin x. It is between 0 to 1, not equal to 1. The floor will be 0, na? 0, 0.1, 0.2, 0.9999. Floor will be 0. Explained already. ठीक है, explained already. ठीक है. अच्छा. Even now if you take the x is between pi by 2 but up to the pi. Pi by 2 up to the pi. Okay. At pi by 2, it takes the value which is 1. But again, after pi by 2, I am taking after pi by 2, but up to the pi. What is the value of sin x? Again, positive but less than 1. Again, positive but less than 1. So, sin x is again positive but less than 1. So, what is going to be the floor of sin x? Sir, again 0. That is why it has been drawn. Na? Up to pi by 2, floor of sin x is 0. Pi by 2 se pi, floor of sin x is 0. So, here, definitely left hand limit is right hand limit. When you come from left or when you come from left, okay, talk about x equal to pi by 2. Okay, left hand limit equal to right hand limit. No problem. Okay, what about f of pi by 2? Ab ye dekho. What about f of pi by 2? The f of pi by 2, is known as the floor sin pi by 2. Dear, when you exactly take pi by 2, sin 90 is 1. So it becomes floor of 1 and floor of 1 is 1. So this is also finite. मैंने next point क्यों बोला? I told you next point f of 0 was undefined, but here f of pi by 2 is defined. It is a finite value, but still the graph is broken. The final condition is left hand limit, right hand limit equal, and it should be equal to the value of the function. Here value of function is something else. Graph टूट गया, graph break हो गया, discontinuous. Okay, discontinuous. ठीक है, तो problem here is LHL equal to RHL, both are 0. When you come from left or right, you are on the x-axis, that is 0. So LHL is equal to RHL, but not equal to FA, not equal to the value of the function at that point, and hence it is again broken, and hence it is again discontinuous. Clear? Hence it is again discontinuous. Because the value of the function only for one moment, it is 1. Yes, Lokesh. Okay. That is what is the discontinuity. Now, so to generalize, okay, I have explained you that particular slide only. To generalize, okay, what is the condition for continuity? Final condition for continuity. The final condition for continuity ye raha. Okay, left hand limit equal to right hand limit equal to the value of the function at that point. For a function to be continuous, okay, the left hand limit, limit x tending to a minus fx, equal to right hand limit, limit x tending to a plus fx should be equal to the value of the function at that point, fa. Left hand right hand limit equal and exactly equal to a. Then these were the individual conditions I explained. Okay, left hand limit should be right hand limit and f of a must be defined. Okay, and all these three should be equal. Okay, then we say that, okay, if this is true, we say that the function fx, okay, the function fx is continuous at the point x equal to a. Okay? Or this is also the condition of one more thing. When left hand limit equal to right hand limit equal to fa, we also say that limit x tending to a fx. Question may be in the form of limit also. Limit x tending to a fa exists. By what is the meaning of limit to exist? If any limit exists means either you calculate the limit from left or from the right, they should be equal, and equal to what? Equal to the value of the function at that point. ठीक है, yeah, defined means bounded. Correct. Defined से मेरा मतलब है it should not be infinity. It should be some bounded value. It should be some finite value. Or simple mathematical terms में बोले, it should be defined means it should be some finite value, but not only finite, then further it should be equal to the left hand right hand limit also. That is what is the final condition of continuity. Okay. Chalo. Next case then. Okay, we'll define differentiability also, and then we go for questions. Differentiability, isko dekh lete. Differentiability. First of all, differentiability, the basic first principle, sometimes that is also important. Okay, differentiability, dy by dx. As we know, dy by dx or f dash x is known as the rate of change of fx with respect to x when the change in x is taken to be small. Okay, y is a function of x. If x changes, y will also change. Okay, how much? By what rate? That ratio, the change in y upon change in x is taken to be the dy by dx, provided change in x should be small. So suppose x changes from x to x plus h. Suppose x is changing from x to x plus h. Okay, then the value of the function, changes from f of x plus h minus fx. Okay, that is a change in the function. Okay, change in function divided by change in x. Okay, that is the derivative. But what is the change in x now? Please calculate. X cancelled h. This change should be small. To represent it as a small quantity, we put h tending to 0. So that is known as limit h tending to 0, f of x plus h minus f of x divided by x plus h minus x. F of x plus h minus f of x upon x plus h minus 8, and that is what is known as the first principle of differentiation. Okay, this is what is known as the first principle of differentiation. I mean, all the basic differentiation formula, okay, all the basic differentiation formula that you know, like differentiation of sine x is cos x, differentiation of e power x is e power x only, differentiation of x cube is 3x square, it's commonly been obtained by the first principle. Okay. Break in the interval where? Manti, where break in the interval? See, yeah, this will also be there. This will be there. Jump discontinuity. I have not analyzed because this is case number 1 already discussed. I have not analyzed this. I have analyzed 0 to pi. Uske baad you can analyze. I want to show that there is one point in the case number 3. Okay. This will also, you know, when you check the limit at pi, this will also be case number 1 discontinuity, jump discontinuity. Okay. Okay. Yeah. Next. Okay. So this is the first principle of differentiation. Now, what are the conditions for a function to be differentiable? Dekhna. How do you calculate derivative at a point? To calculate derivative at a point, you are using the value of the function at that point. To calculate derivative f dash x at a point x, you need the value of the function at the point x. If the value of the function, yeah, if at the point x function itself is undefined, maybe it means unbounded, or it may be left hand or right hand limit not equal. So what value will you take? If the function is broken, I mean to say, you need the value of the function at that point, and if the curve is broken, you cannot use the value. Okay, and hence you cannot calculate the derivative. So what is the very first condition of derivative? Okay, that the function must be continuous. The very first condition is it should be continuous. If it is not continuous, it cannot be differentiable. Okay, then the second condition is, okay, the derivative which is solved by using a limit. Limit h tending to 0. Okay, and limit, when you calculate either from the left or the right, it should be equal. Na? So left means you can take the change as, take the change in x is very small, but maybe negative side or maybe positive side. Negative side or positive side. Okay, that means limit h tending to 0 minus or limit h tending to 0 plus. Okay, whatever you calculate should be the same. Okay, should be the same. This is known as left hand derivative equal to right hand derivative. LHD, left hand derivative, you can write down, and RHD is right hand derivative. Okay. So left hand derivative should be equal to the right hand derivative. Okay, then it should be equal to the accurate value of the derivative. That is why I'll explain you these points through example. Okay, you can just note down the function should not have a vertical line tangent at the point x equal to a. Isko baad mein dekhte hain. Forget, we can take it through an example. Okay, how you have to deal with the questions, that I will explain you with examples, but basic points are known to you now. Now, before I take up an example, some key points. Okay, that are, I think you're already aware about them, but you should know these key points. Derivative at any point on the curve also gives you the value of the slope of the tangent to the curve. Okay, derivative is equivalent to slope of tangent to any curve at that point. Okay. There are some functions which are always continuous and differentiable. You should never check their continuity differentiability. They are sin x, cos x, exponential function, and polynomial function. Polynomial functions like, okay, polynomial functions like involving x, x square, x cube, yeah, any power, any algebraic function, any power of x. These are categorized as polynomial function. So polynomial functions or exponential or sinusoid sine or x, they are always continuous and differentiable. Always means for every value of x, negative, positive, everything. The next important function is logarithm function. Logarithm function is also continuous and differentiable, but in its complete domain. That is for x greater than 0. Because for negative values of x, anyways, log is not defined. Na? Okay, and even log 0 is undefined. Log 0 is known as minus infinity. ठीक है, तो 0 और negative को छोड़ देंगे, but for any positive value of x, log x is continuous and differentiable always. Now, if there are two functions which are continuous and differentiable, okay, then the following will also be continuous and differentiable, like their addition or subtraction, f plus minus g, their multiplication f into g, and their division f by g. But division considered only at the points where g not equal to 0. Division considered only at the points where g not equal to 0. Okay, only at the points where g not equal to 0. Where g not equal to 0. Okay, where G not T. Because if the denominator is 0, then again undefined, and undefined means not continuous, and not continuous means not differentiable. Chalo. Let us start with the first and very common case, modulus function. You should always know about the modulus functions. Okay, continuity and differentiability of the following function at x equal to 0. Check the continuity and differentiability of the following function at x equal to 0. At x equal to 0. Chalo check kar lenge. The continuity and differentiability of the function at x equal to 0 to be assessed. Let us start assessing. Let us start assessing it, okay? Continuity and differentiability at x equal to 0. Okay? What f of g is f of g of x. What exactly you are asking, Lokesh, then? It's a function of function. Okay, composition of functions. देखो अब modulus of x की अगर बात करें, first let me explain, let me draw the curve corresponding to it. So I have the function f of x, which is known as mod of x. And how do I write down mod of x? Mod of x is equal to x for x greater than equal to 0. Because if x is positive, mod x will be x only, na? Mod x will be x only, na? Okay, like if I ask you mod of 5, that is 5 only. But suppose if x is negative, if I ask you mod minus 5, my modulus of minus 5 is also 5. I only want the magnitude. Okay, then this can be written as minus of minus 5. If a number is negative, place a minus in front of it. Minus minus will become plus. Okay, so it is minus x for x less than 0. Okay, now you have y equal to x. That is a straight line. Okay, if I want to plot it now, okay. Okay, for positive value of x, y equal to x. Positive value of x, y equal to x, straight line. Okay, this is a straight line passing through origin, slope equal to 1. Okay, if negative side, y is minus x plus c, again passing through origin, but slope is negative. Okay, but slope is now negative. This can be written as y equal to minus x. Okay, so guys, very clear from the graph. Okay, we need to check at x equal to 0, na? We need to check at the x equal to 0. At x equal to 0, is it broken at x equal to 0? Is it broken at x equal to 0? Is it broken at x equal to 0? First, I will tell you the shortcut. पहले shortcut graph से बना लेते. Then I will tell you the method also. Don't worry. Is it broken at x equal to 0? What do you feel? Okay, it's not broken. It is clearly okay connected here. कोई gap, कोई infinity, nothing. It's continuous here. Okay, it is continuous. No break. Okay, not broken means it is continuous. चलो मैं clear reason के साथ रखता हूँ. It is not broken here. It is a smooth curve here. Okay, it is continuous. Sorry, it is not broken. Simply means it is continuous. Simply means it is continuous. ठीक है? Now, what about derivative? Now, first, graphical shortcut. Then I will explain you the method once again. देखो, the function before this point, this is x equal to 0. Okay, before x equal to 0, you have a straight line of negative slope. At after x equal to 0, you have a straight line of positive slope. Okay. That means the nature of the function at this point suddenly changes. The nature of the function suddenly changes. It was a straight line of negative slope suddenly. All of a sudden, it becomes a straight line of positive slope. Although they are connected, they are not broken. Continuity is measured. Continuity is maintained. Okay. But at a point where the nature of the function suddenly changes, okay, maybe negative slope to positive slope, or maybe parabolic to line, anything, when the nature of the curve changes, where the nature of the curve changes, such a point will be known as a sharp point. Okay, and at any sharp point, I will just now prove it, but you can conclude at any sharp point, left-hand derivative will not be equal to the right-hand derivative. At any sharp point, the left-hand derivative does not equal to the right-hand derivative. At any sharp point, the left-hand derivative will not be equal to right-hand derivative. So the function at x equal to 0, okay, the function at x equal to 0 will be continuous, but not differentiable. Okay, but not differentiable. That is my answer. That is my answer. Now, if you want to understand with the analytical method, ये देखते हैं. Okay, if you want to understand with the analytical method, because every time graphs may not be available, na? Every times graph may not be available. Okay, I have been given the function fx, okay, which is x for x greater than equal to 0, which is minus x for x less than 0. So everybody, what is the value of left hand limit? Left hand limit, left hand limit. देखो एकदम short में लिखेंगे. Okay, short में लिखेंगे. Left hand limit means, देखो understand like this. Left hand means x tending to 0 minus. We are checking at x equal to 0. Okay, limit x tending to 0 minus fx. तो अब आपको क्या करना है? देखो quickly, what you have to do quickly. X tending to 0 minus means you are approaching x, but you are at less than 0 right now. You are before it, left side. So dear, when x is less than 0, when x is less than 0, what is the definition of the function? When x is less than 0, the function is known as minus x. The function is known as minus x. Okay, now put x tending to 0. Minus 0 is same as 0. Hey, minus 0 or 0 to same hota hai. ठीक है. Similarly, if you want to calculate the right hand limit, okay, so that is known as limit x tending to 0 plus fx. Now, when I say 0 plus, that means you are approaching the function from greater than 0 side. From greater than 0 side. Dear, if you are approaching from greater than 0, okay, when x is greater than 0, the function is fx. The function is known as fx. The function is known as x basically. Okay. Now put x tending to 0. It is 0. Ultimately plus 0 minus 0 same. Acha. Next is what is the value of fa? That is f0. We are calculating the continuity at x equal to 0. So what is f0? F0 is known as fx is modulus of x. F0 is mod 0, which is 0. So all three are equal. Na? LHL. That is what you want. Is RHL is equal to f0. So that is why I told you graphically also the function is continuous because there is no breakpoint. Okay, hence this is continuous. Okay, hence this is continuous. Okay, satisfied. Next, if I want to talk about differentiability. Next, if I want to talk about the differentiability, चलो उसकी बात कर लेते हैं. Next, I want to talk about the differentiability and let's do it. Let's talk about the differentiability. Let us talk about the differentiability. Okay, ready? Let us talk about the differentiability. देख लेते हैं. Okay, when is a function differentiable? When is this function differentiable? वो भी check कर लेते हैं. Okay, so differentiability के लिए guys, what I will do is I will start calculating the f dash x directly. Okay, we know the derivative formula, na? So what is the derivative of x? It is 1. Derivative of minus x will be minus 1. So it is 1 for x greater than equal to 0. It is minus 1 for x less than 0. Minus 1 for x less than 0. Okay, that is what is the f dash x. Okay, now what is the value of left hand derivative? Left hand derivative means the value of the derivative, okay, for x tending to 0 minus. That is what I mean, huh? So when you are approaching the function, okay, from less than 0 side, what is the value of the derivative? Minus 1. So guys, actually when you are calculating left hand derivative, you need not solve that limit. You need not solve first principle. Because why you don't need to solve first principle? Because you know the differentiation formula already. You know the differentiation formula already. Okay. Now what is the right hand derivative? Right hand derivative is the derivative when you are approaching the function from 0 plus side, and when x is greater than 0, the derivative is 1. Okay, and they do not match. I told you na. पहले ही मैंने बता दिया था. Conditions I told you earlier only. Here LHD not equal to RHD. LHD not equal to RHD. So the function is not differentiable. LHD not equal to RHD. Function is not differentiable. Okay. No, not at all, Manasvi. I told you what is the eigenvalue of inverse of the matrix. They are not same. Okay. So this is not differentiable. Already I mentioned. So dear, whenever a function has a sharp point, it will always be continuous, but LHD not equal to RHD, hence it is not differentiable. That is always true. That is always true. Okay. If a function is continuous at a point, but LHD not equal to RHD, we get a sharp point. So graphically, whenever you see a sharp point, you can say continuous but not differentiable. Continuous but not differentiable. Okay? Continuous but not differentiable. Okay? Sharp point, sometimes also known as edge point. Okay, also known as the edge point, whatever it is. Okay? For differentiability, the continuity has to be there. All conditions of continuity must meet for the differentiability. Then only differentiability will come. Then only differentiability will come. ठीक है? अच्छा, one more condition I will write down. This is about mod x, na? This is about mod x. What you know about mod x? Important case I will write down. Mod x is continuous, okay, but not differentiable at x equal to 0. That is what we have noted now. Mod x is continuous but not differentiable at x equal to 0. There can be a question something of this kind. Okay. Okay. Suppose I give you modulus of 3x, okay, minus 10, something like this, is continuous but not differentiable. At what? At? See, rather than mod x, I give you mod of 3x minus 10. Then how do you solve? Okay. The modulus function is always continuous but not differentiable when the argument is 0. Simply take the argument 0. So what is the argument here? 3x minus 10. This should be equal to 0. So x is known as the 10 by 3. That is x is equal to 3.33. That is x is equal to 3.33. Everybody, x is equal to 3.33. Done, everybody. Clear answer. X is known as the 3.33. Done. Cool. Next question then. Okay, the x is known as the 3.33. Chalo, next. Choose the correct option. Okay, for the function. It is continuous at x equal to, differentiable at x equal to 2, continuous at x equal to 1, differentiable at x equal to 1. Number one thing, ये देखना, MSQ question है ना. Number one thing, please see when is the definition broken. The function is broken into two parts and that is at x equal to 2. Something before 2, something after 2. भाई x equal to 1 की अगर बात करोगे, okay, at x equal to 1, the function is not broken. अच्छा, x equal to 1 means x less than 2. X equal to 1 comes under x less than 2. And x less than 2, what is the function? At x less than 2, it is clearly polynomial always. It is a quadratic function, polynomial. There is a change at x equal to 2, तो वही check करना है आपको. But for any value x equal to 1, which is less than 2, it is a polynomial function and polynomial is, okay, polynomials mean continuous and differentiable. So C and D to correct है बाबा. At x equal to 1, it is continuous and differentiable. Don't check that. Don't waste your time in checking that. Okay. तो ये भी एक variety हो सकता है. But now x equal to 2 is the case where the definition is broken. Can you tell about continuity and differentiability at x equal to 2? Please, I'm waiting for it. Can you tell the continuity and differentiability at x equal to 2? Please tell me quickly. Please tell me quickly. Chalo, let's check it out. Now, it's up to you whether you want to do graphically or whether you want to do by the method. Dekho, I'll tell you both the things here quickly. I'll tell you both the things here. Okay, I know fx. What is the fx given to me? Agar if you want to solve by the analytical method, x square minus 4 and x minus 2. This is for x greater than 2 and this is for x less than equal to 2. ठीक है, minus infinity से 2 and 2 से infinity. ठीक है, इतना लिख दिया मैंने, काफी है. So correspondingly, what is the f dash x? We know how to differentiate the function. So directly write down 2x and x minus 2 का derivative 1. This is for x less than equal to 2. This is for x greater than 2. ठीक है, now dear directly. Now everywhere, last question I told you, limit x tending to 2 minus fx. इतना कौन लिखेगा भाई? इतना कौन लिखेगा? Every time in gate you don't have to write this much. भाई left hand limit means apply. Okay, when we know left hand limit means x tending to 2 minus. Okay, look into this directly. When x is less than 2, what is the function? X square minus 4. So there directly put, we are checking x equal to 2 pe na. Okay, So what is the definition of the function for x less than 2? It is x square minus 4. Put x equal to 2, so 2 square minus 4, this is 0. Okay. Now right hand limit. Okay, so now nobody is going to write that left hand limit is known as limit x tending to 2 minus fx. We will directly put. Then right hand limit x tending to 2 plus. So when x is greater than 2, what is the function? X minus 2. So you will take x minus 2, and there also directly you put x ka value. How much? 2. We are checking at 2. So it is 0. Acha, then what is f of 0? One last calculation. So equal to my first definition. F of 0 is again 2 square minus 4. That is 0. So dear LHL equal to RHL equal to FA. So continuity to hai. Function is continuous. Without any doubt, the function is continuous. Without any doubt, the function is continuous. इसमें मुझे कोई doubt नहीं लग रहा है. The function is continuous. Okay. Then what about the differentiability? So LHD. So already I have differentiated, na? Okay. LHD means the value of the derivative. Okay, for left side. So when x less than 2, derivative is 2x, and then I will put x equal to 2. Okay, so left hand derivative is 4. What about right hand derivative? The derivative when x greater than 2 and it is constant 1. Unequal. Okay, not differentiable. Khatam kar do kahani. Unequal means not differentiable. Unequal means not differentiable. Okay, ho gaya. Okay, the function is continuous at x equal to 2. Is differentiable? No. Okay, it is continuous but not differentiable at x equal to 2. Correct answer is A. But not B. And then CD is anyways correct. So MS2 question answer is ACD. ACD. Acha, now और simple कर दे इसको. और simple कर दे इसको. ठीक है. Now simple कैसे होगा ये? Okay, let me go for the graph of it quickly. Okay, let me go for the graph of it. Then I'll explain you. Okay, x square minus 4. Okay, for x less than equal to 2, it is x square minus 4. देखो, this is y equal to x square. Y equal to x square is a parabola opening up. Basic graphs. Whenever basic function, you can try graph. Otherwise, method. Okay. Otherwise, method. Okay, so for y, this is y equal to x square, but I want x square minus 4. Amplitude down by 4 units. Okay, amplitude down by 4 units. But only up to x equal to 2. Only up to x equal to 2. 2 square minus 4, I will stop at 0. Then what happens after x equal to 2? It is a straight line. It is a straight line having the slope 1 and y-intercept negative. Y-intercept tak nahi jana hai, but it is a straight line having the slope 1. All of a sudden, it becomes a straight line having the slope 1. All of a sudden, it becomes a straight line having the slope 1. Okay. Now, this is the straight line x minus 2. And this is known as the x square minus 4. Now, clearly, everybody can say, what is this point now? It is not broken. It is not broken. It is a sharp point. Nature of the function changed. The parabola to line. Parabola to line. Okay, it is a sharp point. The nature of the function changed here. And because it is a sharp point, function is C. Okay, but not D. Short mein likh raha hu. At every sharp point, it is C but not D. Graph. 1 second, you draw the graph. 1 second, you have the answer. Within the 1 second, you have the answer. Yeah, sharp point, edge point, corner point भी बोलते हैं, break point भी बोलते हैं, but commonly sharp point. ठीक है जी? ठीक है जी, done है, खत्म. Put it in the Telegram, Manasvi. Simple question है what you have posted, but I'm sorry I'll not be able to take personal doubts right now because lot of content I have, lot of content. See, we are at 149 slides only. बहुत सारा है अभी तो, बहुत सारा. Okay. By this number I am able to see because I know what is the total number of slides that I have to cover for you. चलो जी, done है. So it is C and D. It is C and D. Done है. It is C and D. Cool है. So very simple from the graph you can obtain. Okay. Very simple from the graph. But this is the method. Okay. This is the proper method. This is the analytical method. ठीक है जी. Next question. Intentionally taken from gate. देखो एक good question practice करते हैं. But it's simple. ठीक है. कराएंगे, पूरा कराएंगे. Don't worry an issue. Okay. I want to go so that every topic is comfortable for you. That is what I want to maintain. So this is fx given to you. E power x for x less than 1. Ln x plus ax square plus bx for x greater than equal to 1. Which of the following is not? Which of the following is true? Okay, they are talking about differentiable or not differentiable at what point? At x equal to 1. Of course, the definition change at x equal to 1, तो उसी की बात करना है. Okay, so tell me the answer. Tell me the answer quickly. Quickly, guys, take the answer. Take the answer. Take the answer. Take it, take it, take it. I'm coming back in a minute. I'm coming back. Just let's say 2 minutes. Take it. Chalo. Arey, within 2 minutes, students are lost. What is that? Within the 2 minutes, students are lost. Chalo. Chalo, no problem. Okay, so this is the function. This is the function given to you, fx equal to e power x and ln x plus ax square plus bx. It's a 2-marker question of gate. Okay, now where the x is differentiable or not differentiable, देखो सबसे पहले तो हम यहीं पे इसका left hand और right hand limit लिख लेंगे, because whether they talk about differentiability, ultimately continuity has to be maintained ना. Without continuous it cannot be differentiable. Okay, so what is the left hand limit? Direct guys, direct left hand limit, x less than 1, e power x, put e power 1, because we are checking at x equal to 1. Right hand limit, don't write down, it is x tending to 1 plus, no need to write any definition. So right hand limit when x greater than 1. Okay, I have this function and then I will put x equal to 1 in the second part, that is ln 1 plus a into 1 square plus b into 1. Okay. Okay, so this is log 1 is 0, so I am left with a plus b. Okay, now for continuity I need, for differentiability I need continuity, and for continuity I need LHL equal to RHL equal to FA also, but LHL equal to RHL also if you take, you will get a relation that a plus b should be equal to e. Okay, a plus b should be equal to e. But this is only continuity. Now what about differentiability? So differentiability, I need to take the f dash. I need to check what? F dash x. So what is the f dash x? What is the f dash x? E power x ka derivative is e power x. Okay. And for the second part, ln x ka derivative is 1 by x plus ax square, derivative is 2ax plus bx, derivative is only b. Okay, now x less than 1 and x greater than equal to 1. Sorry, x is greater than 1 and here, ulta likh diya kya? Yeah, above x less than 1. This is x greater than 1, greater than equal to 1. So now dear everybody, what is the LHD? The value of the derivative when I see from the left, when I see from less than side, it is e power x, put x equal to 1. What is the right hand derivative at x equal to 1? So when I check the derivative from x greater than 1, it is this particular function and then I put x equal to 1. So 1 upon 1 plus 2a into 1 plus b. So this is 1 plus 2a plus b. Okay, now for differentiability, we need LHD equal to RHD. And when you compare these two, so you have 1 plus 2a plus b equal to the e. Next equation. Okay, so what you need to do is now you need to compare. Okay, you have two results now. Okay, यहाँ से आप बोल सकते हो 1 plus 2a plus b. So you can say that 2a plus b is e minus 1, and from the first equation you have a plus b equal to the e. The first result that tells you a plus b equal to the e. Clear everybody? Clear everybody? Now can you solve it? Yes, why not? If you subtract if you just subtract this, you get the 2a minus a as a, b cancelled, and you get minus 1. So a ka value minus 1. Okay, and if a is minus 1, b will be equal to e. Minus यहाँ पे plus हो गया, e plus 1. So the function is continuous and differentiable, and yes, for the continuity differentiability you get a particular value, unique value of a and b. There is only one solution, that is unique solution. So what is the correct answer? It is option number B. The function is differentiable at x equal to 1 for the unique values of a and b. That I have calculated also. That calculation not required, but yeah, answer is B. Answer is B. That is what is the correct answer. Right, everybody? Let's move ahead to the next concept then. Okay. So I hope the conditions of continuity differentiability are clear for you. And with this, there is an extension of this topic known as the mean value theorem. Although not that important. Okay, but moderately important. Okay. Okay. Even if it is important, yeah, moderately important, let's keep covering it. So Lagrange's mean value theorem. Lagrange's mean value theorem. Okay, Lagrange's mean value theorem. Okay, okay, Lagrange's mean value theorem. So let fx be a real valued function. Okay, such that, let fx be a real valued function such that it is continuous in the closed interval ab. It is differentiable in the open interval ab. Okay. Now you know what is continuity and differentiability. So let fx be any real valued function. Okay, such that it is continuous in the closed interval AB, differentiable in the open interval AB. I mean for continuity, closed interval, for differentiability, open interval is also okay. Okay. Then there will always exist a point C belonging to the interval A comma B. Acha, if a function is continuous and differentiable within the range, if you want to just take a look into a rough example, a rough graph, continuity means there should not be any broken point. And differentiability means there should not be any sharp point. There should not be any sharp point. Okay. अगर एक rough example है, have a look into it. Have a look into it. Okay. This is some point A. Okay. Where x equal to A. Another point B on the curve where x equal to B. Look into this curve. Look into this curve. This is the curve actually. Okay. And very clearly I have taken a random example. But yeah, there is a curve where there is no break point. Let me know anybody if you are able to see any break point. And then definitely there is no sharp point also. It's a clear parabolic. I've just taken a simple parabola example. Sharp point means where the nature of the function changes from parabola to line, a line of different slope. But it is a clear, continuous, smooth curve that is in front of you. Okay. That means I can say that, okay, between A to B function continuous and differentiable hai. Okay. Continuous and differentiable hai. But very important thing is, okay, differentiability is okay between A and B, but when you are checking the continuity, na, okay, it should be even at the end points also. It should be continuous at the end points. It may be differentiable at end points. That is not a condition. Minimum condition is बीच में differentiable होना चाहिए. But for continuity, it should be, of course, continuous in between, but also at the end points. Bracket, close bracket means including the end points. Why it should be continuous at the end points also? I will explain that. So, it is differentiable anywhere and derivative at a point equal to slope of tangent. ये भी हमें पता है, सब कुछ connect करना है. Derivative at a point is equal to slope of tangent. So you can draw the derivative at any point. I can draw the derivative at this point, and derivative is equal to slope of tangent. So this will be the tangent at this point. I can take the tangent at any point. I can take the tangent at any point on the curve, and slope of tangent equal to derivative. So I can define multiple. What? I can define the multiple tangents here. Everybody clear? I can define the multiple tangents here. Okay. Out of these multiple tangents, there comes a point C. Out of these multiple tangents, there comes a point C. Such that the tangent at that point is appearing what? The tangent at this point is appearing parallel to the line joining the end points. Okay, parallel to the line joining the end point. So, out of all these tangents, there is a tangent at some point, suppose C, okay, which is parallel to, okay, which is parallel to, okay, the line AB, which is parallel to the straight line, the line joining the points AB. Okay, the line joining the points AB. Parallel to the line joining the points AB. Now, two parallel lines have equal slope. Okay. Okay, so you can equate their slopes. Two parallel lines have equal slopes, so you can equate the slopes. What is the slope of tangent at C? Slope of tangent is known as f dash x. Okay, at the point C, the f dash C. Okay, is equal to, what is the slope of any line, slope of any straight line? Okay, for that let me write down its coordinates. So suppose B is having the coordinate what? X coordinate is B, the value of the function will be FB. Similarly, A coordinate, the X is A and the value of the function will be FA. The value of the function will be FA. So it is A comma FA and B comma FB. So what is the equation of the line? y2 minus y1 upon x2 minus x1. Okay, y2 minus y1 upon x2 minus x1 for any 2 points, line joining 2 points. So y2 minus y1 is fb minus fa divided by x2 minus x1, b minus a. Ye lijiye. And now I told you why I need the continuity at the points A and B. I told you, it has to be differentiable and continuous in between. But for continuity, it should be always also continuous at the end points because I'm using the value of the function at end points. So if it is not continuous at the end point, how can I define the value? It will be broken, na? So that is why continuity the end pe bhi hona chahiye, differentiability even in between at least. Okay for me. Here is the result already written. So if it is continuous and differentiable in the given condition, there will always be a point. There will always be a point C belonging to the interval AB. Belonging to the interval AB. Such that, what point? Such that f dash C is fb minus fa upon b minus a, as I explained you. What type of questions can I abhi explain karta hu? Okay. So dekho, motivational. By what time is the class? I don't know. Okay, I don't know. Break also, I will give you one more break, but not right now. By evening, I will give you the break. Okay. Evening, we took one lunch break. We will take one small tea break. We will continue. Take care. Very clear indication, I am not stopping till evening at least. Otherwise, not possible to cover more. Hai na? So at least till evening I'm not stopping. Around evening I will give you one small break, high tea. Have a high tea in the evening. Uske baad we will resume for some more time. We will resume for the some more time. After that we will resume for the some more time. ठीक है, चलो. So f dash c is known as fb minus fa divided by b minus a in that condition. fb minus fa divided by b minus a. ठीक है. Simple. ठीक है. Now one special case of this. Okay. One more condition if I add. One more condition. Then question एक साथ लेंगे. What are the questions? Let fx be a real valued function. Again it is continuous in the closed interval ab, differentiable in the open interval ab, and the value of the function at the extreme points is equal. fb equal to fa. The value of the function at extreme points is equal. That is fb equal to fa. Okay. Then there will exist a point c in the interval a comma b. By if fb equal to fa, what will happen? Same condition, but there will exist a point c in the interval a comma b. Okay, such that f dash c is equal to 0. If these two are equal, the result becomes 0. If these two are equal, results become 0. Results become 0 if these two are equal, correct? If these two are equal. So then there will exist a point C in between A and B such that f dash C equal to the 0. Such that f dash C equal to the 0, and it is again explanatory from this graph that the function is continuous and differentiable. ये होना चाहिए point B up to this point, suppose. The function, okay, this is the point B, B comma FB coordinate. This is the point A comma FA. Function is not broken at any point. It is continuous. It is not having any sharp point. It is differentiable. There will exist a point C. Okay, there will exist a point C. Okay, such that derivative at that point. Now see, what is happening here is, of course, again there will be a point in between, just like previous explanation, such that the tangent at this point is parallel to the AB, but AB is parallel to x-axis. Because FB and FA is same, because FB and FA is same, the line AB, the heights of these 2 points is same, so AB is nothing but parallel to x-axis. AB itself is parallel to x-axis. AB itself is parallel to x-axis. Okay. So that is why tangent at this point is also parallel to x-axis. Okay, so what is the slope of tangent at this point? Slope, line parallel to x-axis, 0 slope. Line parallel to this axis, 0 slope. So this tangent is parallel to x-axis. Okay, so that is why the f dash c at that point is 0. So here the result is f dash c equal to 0. Okay, one more. Okay, then we start question, Cauchy's mean value theorem. Okay, the Cauchy's mean value theorem. So dear, suppose fx and gx are two real valued functions such that they are continuous in the closed interval ab, they are differentiable in the open interval ab. Now there are two functions f and g, both of them continuous in the closed interval, both of them differentiable in the open interval. Okay, then there will exist a point c in between the interval a comma b such that f dash c will be given by, both of them follow the LMVT, na? fb minus fa upon b minus a. Okay, such that g dash c will be equal to gb minus ga upon b minus a. Both of them follow the LMVT. So that is why f dash c upon g dash c will be equal to fb minus fa. b minus a hata denge. That will be equal to fb minus fa divided by gb minus ga. fb minus fa divided by gb minus ga, provided gb not equal to ga. Denominator 0 nahi hona chahiye, otherwise the result will become undefined. Okay, that's it. So because both of them individually satisfy the conditions I explained you for LMVT, so we can just copy the results. Okay, first let's see a direct question. Find the C for Rawley's theorem. There can be direct question also. Find the C for Rawley's theorem. Okay, for fx equal to e power x sin x in the interval 0 comma pi. Okay, in the interval 0 comma pi. Of course, they are asking C for the Rawley's theorem. That means they are assuming Rawley's theorem should be satisfied. Okay, and it will be satisfied. I'll tell you why. Whether the interval is 0 comma pi or something. Dekho, e power x exponential, always continuous and differentiable. Okay, sinusoidal, sin x and cos x also always continuous and differentiable. Sin x also always continuous and differentiable. Okay, so both of them are always continuous and differentiable. So if two functions are continuous and differentiable, their product is also always continuous and differentiable. Always continuous and differentiable. Always. That means always to hai. Always to hai. One thing I can say is it is continuous in the given interval, closed given interval. Hamesha hoga, any interval given. Okay. Second, for any given interval, it is differentiable also. It is differentiable in the open interval 0 pi. Yes, it is differentiable. Okay, but third condition is f0 equal to f pi. Is f0 equal to f pi? वो check कर लेंगे. f0 is 0 and f pi, sin pi, that is also 0. So that is also true. That means what I'm telling, if they are telling that find C for Rolle's theorem, so they are assuming Rolle's theorem is satisfied. Now find a C for Rolle's theorem. Okay, so that C is what C? It is the C such that f dash C is equal to 0. And Rolle's theorem result is f dash x equal to 0. F dash C will be equal to the 0. So what is the f dash C? Okay, what is fx given to me? Fx is e power x sin x. Okay, so what is the derivative of this function? Product rule apply करेंगे. Product rule if you apply, तो e power x derivative is e power x sin x constant. Okay, then e power x constant sin x derivative will be cos x. Okay, so now what I am looking for is f dash c equal to 0. Okay, f dash c में e power c common. I have sin c plus cos c equal to 0. Okay, e power c cannot be 0. Okay, because e is a positive number. Again, sin c plus cos c 0 करेंगे. So now you have the relation sin c equal to minus cos c. Okay, or that is tangent c, divide by cos, tan c equal to minus 1. So what should be c? What should be c? Positive angle hai. Okay, so c should be 3 pi by 4. Because minus 1 is the value of tan 135 degree, tan 3 pi by 4. So c can be 3 pi by 4 within the given interval. See, there can be, tangent is a periodic function. There can be other values so that tan x is minus 1. But I want the value within the interval 0 comma pi, that is 3 pi by 4. That is the correct answer. That is the value 3 pi by 4 and that is the very correct answer. That is the very correct answer. Achha, now listen to one more question here. Listen to one more question I need to frame. इसी के through समझाते हैं. Okay, question is, at least one of the roots, एक application based question, at least one of the roots of the equation x into cos x plus sin x, x into cos x plus sin x equal to 0 lie in the interval. At least one of the roots of the equation x cos x plus sin x equal to 0 lie in the interval. I'll give you 4 options. It can have multiple roots, but at least one of the roots will lie in which equation? At least one of the roots will lie in which equation? At least one of the roots lie in which equation? चलो इसको अगर देखा जाए, okay, so what can be the answer corresponding to it? Have a look into it. Whenever there is a theme, na, at least one of the roots of a given equation, okay, lie in an interval. Mark these words. At least one of the roots of the equation lie in interval. Okay, let that equation be f dash x equal to 0. Let that equation be f dash x equal to 0. Assume that this is derivative of some function. Ye method fix kar lo brain mein. Whenever you read a language of this form, at least one of the roots of the equation. So let that be f dash x equal to 0. Let that be f dash x equal to 0. Okay, so here I have let that f dash x be equal to x into cos x plus sin x. Now this is the derivative of some function. Whose derivative it is? It is the derivative of some function. Whose derivative it is? Tell me. Whose derivative it is? See, I can explain you like this. This is x and cos x is the derivative of sin x. यहाँ पे sin x है, उसका derivative है यहाँ पे. Plus. In the next part you have only sin x. X is not there, means sin x into derivative of x, because d by dx of x will be 1. So what is this now? It is simply product rule basically. Once you differentiate sin x, so x is constant. Once you differentiate x, so sin x is constant there. Okay, so I can say that here the value of the f dash x is nothing but the d by dx of, it is nothing but the d by dx of x sin x. Okay, it is the derivative of x sin x. Okay, now f dash x is the derivative of fx. Right, f dash x is what? It is the derivative of fx. Okay, so I have f of x is equal to x sin x. I have f of x is equal to x sin x. Clear? Acha. Now, once again, okay, when you talk about x also, or when you talk about sin x also, this is polynomial category, this is sinusoidal category. Okay, they are always continuous and differentiable, right? Polynomial and sine, for whatever interval it is always continuous and differentiable. ठीक है? नहीं, याद केवल ये statement रखना है. You don't have to remember any procedure, Nikhil, but only one thing is whenever such question arises, at least one of the roots of the equation. Okay, so that particular function, call it as f dash x. This is a question solvable by Rolle's easily. How Rolle's? अब वो देखेंगे. How Rolle's? So what I'm telling you is, it is always continuous and differentiable function that is given to you. Okay, so okay, suppose there is any interval a comma b. Okay, there is any interval a comma b, but fx to always continuous and differentiable hai. Always continuous and differentiable hai. So I can tell you that the given function fx is continuous. It is always continuous. So it is continuous in the interval a comma b. ठीक है? It is also differentiable. Okay, in the interval. ठीक है? Then if fx, देखो, okay, if fx satisfies fa equal to fb, if by chance fx satisfies fa equal to fb, that means when you combine all three, you are coming to Rolle's equation, Rolle's theorem. Okay, now Rolle's theorem says that if these three are true, then f dash x equal to 0 at least one point. Correct? At least one point c. At least one point x equal to c, we know f dash c equal to 0. Yeah, simply let me call it as f dash x equal to 0. अच्छा, यही तो चाहिए. At least one point f dash x equal to 0. Okay, in which interval? So in which interval? In the interval where fa equal to fb. Because continuity differentiability तो maintained है. Okay, so it is f dash x equal to 0 at least one point, okay, in the interval a comma b. So now you have to just try the options. Now you have to just try the options. Okay, you have to just try with the options. What interval matches this? So what is my fx? My fx is x sin x. Okay, you have to only check fa equal to fb. Because fa equal to fb, then only f dash x 0 वाला result आएगा. Okay, so option number A. Option number A, interval is 0 comma pi by 2. This is A comma B. So what is F0? F0 to 0 hoga, 0 into anything. But F pi by 2 is pi by 2 into sin pi by 2. Okay, they are not equal. So this cannot be the correct answer. Okay, I will go to option number B, which is 0 comma pi. ध्यान देना. What is F0? F0 to 0 hai. But what is F pi? What is f pi? It is pi into sin pi, but sin pi 0 hai, so both of them matches now. fa equal to fb, and that is the correct answer. It is a MCQ question, I told you. It is a MCQ question, so no need to check any other answer. No need to check any other answer. So the correct answer is option number B only. No need to check any other answer. वैसे C नहीं आएगा, even if you check, but not required. Not required. Okay, everybody? That is typically not required. Okay. Next question. Find the C of Lagrange's mean value theorem, LMVT. Like we took a question, find the C of Rolle's theorem. Here find the C of LMVT for fx equal to log x in 1 comma e. देखो fx equal to log x. Okay. Is it continuous in the interval a comma b? देखो log x is continuous and differentiable. I told you this condition also for all x greater than 0. For all positive value of x, log x is always continuous and differentiable. So here the range that is given is 1 to e, positive. So it is, without any test, I can say that it is continuous it is differentiable in 1 comma e. Acha. This also tells you that whatever the questions you are expecting on Rawley's or LMVT or any of these theorem, there most likely you don't have to check continuity differentiability. You are given functions whose continuity differentiability you already know. You have their judgment. Main thing is about the theorem. Apply the theorem. Okay. Now we know that it is always continuous and differentiable. Okay. Then there will be a C. Okay. Such that f dash C will be fb minus fa upon b minus a. Okay. Now, what is the f dash x? F dash x log x ka derivative 1 by x. Log x ka derivative 1 by x. So put x equal to c, 1 by c. What is the value of fb? What is the value of fa? Fa here is f1. Log 1 is 0. Okay. Fb here, okay, is f of e, and the value of log e, log and e inverse cancel, it's 1. Okay, so your answer is fb minus fa, 1 minus 0 divided by b minus a, e minus 1. Okay, so the value of c is e minus 1. Comparing the answer, c is e minus 1, answer is b. Answer is b. Yeah, correct answer, Bhanu, Raj, Nishu, Ankit, Sonali. Very correct answer. So answer is e minus 1 without any doubt. The answer is the e minus 1. Done hai? Cool hai? Next question then. This answer is known as the e minus 1. Let's move ahead to the next question then. Okay. Now, one question based on the application of this. Okay. Suppose that a function, okay, whose domain and range is both set of all real numbers, okay, is a continuous function on the interval minus 3, 3 and a differentiable function in the interval minus 3, 3. Okay, so there is an interval given, it is continuous in the closed interval and it is differentiable in the open interval. That means LMVT की बात कहीं ना कहीं mind में चलनी चाहिए. Okay, such that for every x in the interval, f dash x is less than equal to 3. If f minus 3 is 7, f3 is at most. At most means they are asking maximum value of f3. Or they are asking what is the range of f3. F3 is less than equal to what? Maximum it can take some value. Okay, so some inequality based questions can be handled with LMVT. What is given? For every x in the interval, f dash x is less than equal to 2. Which interval? Minus 3 comma 3. Okay, minus 3 comma 3. Okay, so if you think, okay, if you think about the function fx in the interval minus 3 comma 3, number one, I can say that it is continuous in the closed interval minus 3 comma 3 because it is given. Function to nahi given hai, but it is given that it is continuous in closed interval and differentiable in the open interval. Okay, that means it is satisfying LMVT. It satisfies LMVT. Okay, and if it satisfies LMVT, apply the result of LMVT. Okay, there will be some x. Okay, so that the derivative will be given by, okay, for at least one x in the interval, derivative f dash x or f dash c, jo bhi bol lijiye, let's call it as f dash x, will be fb minus fa upon b minus a. Okay, but now what interval to be taken here? Okay, what interval? Already I have taken minus 3 and 3, and out of which one of the value is given through b, f minus 3. One of the value is given to me. So what is the fb? Okay, f3. Minus 3 comma 3 liya tha na? Minus f minus 3 divided by b minus a. Okay, so you are known as f dash x will be f3. F minus 3 कितना एक बार देखना पड़ेगा 7. Okay, so f3 minus 7 divided by 3 plus 3 becomes 6 in the denominator. ठीक है. अच्छा, now you are given that f dash x is always less than equal to 2. Okay, for every value of x in the interval, f dash x is less than equal to 2. But I know what is the expression for f dash x. Okay, that is f3 minus 7 is divided by 6 is less than equal to 2. Okay, using this value, okay, what is the value of f3? 2 6 are 12. Okay, 12 plus 7, 19. f3 is less than equal to 19. So what is the maximum value? It is always less than equal to 19. At most, it can be 19. At most, it can be 19. Okay, some inequality based question can be expected on the LMVT, on the Lagrange's mean value theorem. On the Lagrange's mean value theorem. Right, everybody? right? Sure. Now, if this is clear to you, let me see one again decent problem. Are you able to handle or not? This is going to be a homework for all. This is a homework for you. Let me know if you have any. It's a good question. It's a good question. In case you have any doubts, let me know by tomorrow. I can discuss that. एक बार बता देना, but please do try it out. It's not difficult. It's a good question. Okay, so where are we up to? 466, guys. Come on. Time for 5th century. Correct, Nishu. Now it's really the time for 5th century. Okay, it's almost more than 6 hours of the class. We started around 10. It's 4 hours 15 p.m. approximately. Okay. No, this is MCQ only. This is MCQ only. Okay? It's a MCQ. Unless and until I mention, if there is any MSQ questions, like I'm mentioning it. Okay? Ab dekho. Yes, I'm bringing a MSQ question here for you. Okay. And coming to a very important topic, maxima minima within the calculus, maxima minima. So guys, listen to me. I will explain you the concept behind maxima minima, but through a problem. Okay, very most important topic of the calculus. Yeah, almost every year you can say maxima minima questions are there in your exam, almost every year. Now listen to me very carefully. Now listen to me very carefully. I have taken continuity differentiability and I have taken the mean value theorem. Okay. At this point, I think I am not taking the questions of limit directly. If time permits tomorrow end, I will take it. But I don't think that you need L hospital rule from my side. That you must be knowing. The questions of limits are most commonly L hospital rule. थोड़ा सा भी आपको पता है तो you don't need to spend time there. So as engineers, I am trusting you that L hospital rule you know. So why to spend time there? मतलब even if I start, then I have to finish. 30 minutes जाएगा. Better in 30 minutes, let me teach you something which you're not really clear about. So I hope I am expecting that you're all clear with, L hospital rule. The limits, they are a question. But limit is very easy, but it is important also. It is very, very easy. That is why I'm skipping it right now. Again, I'm telling, if time permits, tomorrow end. Tomorrow end, kal dekhenge. But for time being, because maximum minima, we can't compromise. Okay. But if I am not taking that topic, doesn't mean it is important. It is very frequent. That is a bonus for all of you. Limits question are very commonly asked in the exam. One marker only, of course. Okay, but that is very easy. Mostly L hospital. Okay. Just, you practice from any session, maybe one of my YouTube session also earlier, you find that is sufficient. That is sufficient. Okay. Yeah, even if you have some book where basic limit calculation is there, 15 minutes you read, it is sufficient. Okay. But in live class, if I start discussing 30 minutes जाएगा, I don't think. Tomorrow end we will see. कल रात को देखेंगे अगर time बचेगा तो limit के कुछ question करा देंगे. Okay. नहीं, it is not removed. It is, see, idea is when they say continuity differentiability, it is there in the syllabus. अच्छा, एक और बात बताता हूँ. Okay. In some of the branches, even continuity differentiability not written. But mean value theorem is written. So people are misunderstanding that continuity differentiability to hai nahi. But if they write mean value theorem means you have to study continuity differentiability, and trust me, in those branches where even continuity differentiability not written, but there are question of only continuity differentiability. There are question, recent year maybe there are question. ठीक है? So what you have to do is, when I say that this topic is not in your branch, then you can skip. If I am not telling, I told you now, whatever discussed till now is common for all. Maxima, minima also common for all. Okay, so if I say if it is common for all, trust it is common for all. I will tell you कि ये आपकी branch का नहीं है. By that time you can relax. I will tell you 1 hour I am going to teach this topic. You can leave for 1 hour. I don't mind. I will tell you the duration also. कि for this 1 hour this topic is not for XYZ branch. You can leave by that time. ठीक है? तो syllabus का मेरे ऊपर छोड़ो आप. Okay, because don't go by the words. Sometimes some topic is connected. They don't mention and you miss it. Okay, so don't go by the words. Never go by the words of the syllabus. Okay, link has to be there. Chalo aate. So guys, MSQ question. A function is defined by fx equal to 2x cube minus 3x square minus 12x plus 5. Which one of the following statement is true about this function? Which one of the following statement is true about this function? Check karte hain. Which of them is true about this function? Function is decreasing from minus 2 say 1, it has maxima, it has a minima, it is decreasing for this range. Now let us test. Okay, and I will tell you the simplest method. That is why I am starting with the question. Then theory pe jayenge, reverse. Because we have the simplest methods. Whenever it is increasing, decreasing, local maxima, local minima, anything. Okay, start by the derivative of the function. Start simply by the derivative of the function, first derivative. So what is the f dash x? What is the f dash x? Okay, 2 3s are 6x square minus 3 2s are 6x and minus 12 and put it equal to 0. Okay, the roots of f dash x equal to 0 are known as stationary points. The roots of f dash x equal to 0 are known as the stationary points. Okay. So what are the stationary points? First of all, cancel the 6 also. It is common. So x square minus x minus 2 equal to 0. Factorizable as x minus 2 and x plus 1 equal to 0. So what is the value of x that is going to come up is 2 and minus 1. The x will be equal to 2 and x will be equal to minus 1. Okay. Okay, 2 and minus 1. These are known as the stationary points. Okay. Now direct answer. Just one line answer. फिर मैं आपको ग्राफ समझाता हूं, but just look into this one line answer first of all. What you do is now you are going to draw the wavy curve. The shortcut comes in the form of wavy curve. Okay, the shortcut comes in the form of wavy curve. Okay, so here for all of you, I will describe this curve also, but for all of you, I'm going to draw wavy curve for f dash x. We don't draw wavy curve for fx here, we draw for f dash x. Okay, we draw for f dash x. ठीक है, we draw for f dash x. ध्यान देना, we draw for f dash x. First of all, what are the roots of f dash x? Okay, the roots are 2 and minus 1. 2 and minus 1. Write down the roots here. Okay, increasing order. This is minus 1 and this is 2. Now, dear, what is wavy curve? Everybody, listen to me one line. Wavy curve is a curve that will always start with the right of largest root. That will always start with the right of largest root with a plus sign. Fixed point. Fixed statement. It will always start with the right of largest root. जो भी largest है, जो भी last है. Always start with the right of largest root and with a plus sign. And keep changing the sign at every root. Keep changing the sign at every root. तो यहाँ पे minus हो गया. Then continue. Here it will be plus. If the roots are repeated, sign will not change. वो case भी आगे देखेंगे. Okay. Keep changing the sign at every root if it is non-repeated. Here both the roots are non-repeated. Repetition वाला case भी आगे देखेंगे. तो keep changing the sign at every root. Plus minus plus. Okay. Plus minus plus. Okay. Plus minus plus. ठीक है. Now this is the illustration in front of me. Now please look into this picture, dear. Please look into this picture. ये रहा आपके सामने. Okay. Look into a random curve here first of all. Look into a random curve here. ठीक है. I have taken a curve such that for some values of x it was increasing. It increases, reaches a peak value. Okay, and then it starts falling. That means it is decreasing now. That means it is decreasing. Okay. Now, when it is increasing, just one example I will explain. Okay, when it is increasing, now see what is happening. Okay, at this particular point P, let us try to calculate the derivative of the function. And derivative is most commonly calculated by the first principle rule. Basics पे जाएंगे एकदम, basics. And basics say that the derivative is limit h tending to 0, change in the function f of x plus h, okay, minus f of x divided by x plus h minus x, change in y upon change in x, the ratio. Okay, when the change in x is taken to be small, and for it to be small, what is the next point I have taken is a neighborhood point. Neighborhood कौन है? Who is your neighbor? Who is just connected to you, closer to you? आपके बगल वाले घर में जो रहता है. Okay, so when I say these 2 points, actually they are very close to each other. They are very close to each other. Okay, negligible distance, but I have zoomed it. मैं एकदम पास कर दूंगा तो आप देख नहीं पाओगे. So I have just zoomed it. It is just very close to each other, I can say. It is just very close to each other, I can say. ठीक है. अब ये देखना. Okay. Now, because it is an increasing function, I clearly showed you. First it is increasing, it reaches a peak, and then it is falling. Then it is decreasing. So because it is increasing, f of x plus h is greater than f of x. The height is greater, na? When you go to the next point, be it a close next point, but height is more, na? Okay, height is more. Okay, so f of x plus h is greater than fx. I don't know what is the derivative, but numerator is a plus quantity. And similarly, x also increased. X को मैंने increase किया, function भी increase हुआ, then only it is increasing function, so denominator is also plus. Ratio of two positive quantity. If both are plus, answer will also be plus. I can say like that, na? So if a function is increasing, there will be a condition on the derivative, that derivative is plus. Similarly, next condition, it will be how much? Just try to guess. I increase the x from x to x plus h. But because it is decreasing, अगर point Q की बात करोगे, at this point Q, because it is decreasing, what is going to happen? Height kam hai, f of x plus h minus f of x, small minus big, negative number. Okay, but x ko to maine increase hi kiya, to denominator positive, overall negative. Got this? So if a function is decreasing at a point, the derivative will show a negative value at that point. If the function is increasing at a point, so at that point derivative will show a positive value. This is about increasing, decreasing. Okay. This is about increasing, decreasing. Simple, clear explanation rakhna ekdam, theek hai? Now let me extend this more. Okay, there may be a curve which is increasing at some point and then reaches a maxima, decreasing at some point reaches a minima, and then increasing, etc. Acha. It may increase up to any point. Now let me extend the curve. It may increase to any point. Suppose it goes up to this point. Suppose this is the curve. Okay. I have drawn a local maxima also, and what is going to be this point? Ye dhyan rakhna. Okay. Look into this entire curve, the extended curve that I have drawn. Into this entire curve, is this actually the maximum? Is this actually the maximum possible value of the function? So when I say maximum, overall maximum, is this the overall maximum value of the function? No, that is even bigger. That is even bigger. That is even bigger. So when I talk about the overall value of the function in an interval, in a particular interval, overall maximum value of the function, okay, that overall maxima will be known as global maxima. This is the global maxima point. Okay, but still this is known as maxima. Still this is known as maxima. See very clearly what? Local maxima. What it is known as local maxima. ठीक है, local maxima के लिए, why it is local maxima? So when you take a local region, when you take a particular region of the function, not minus infinity to infinity, but when you do the analysis of this small region, okay, within this small region, okay, it is known as a local maxima. Maxima within a local region, maxima within the local region. Okay, ठीक है, like if this is the prime minister, this is the chief minister of a particular state. Got it? If this is the prime minister, this is the chief minister. Simple. So whenever you have a maxima for a local region, then it is the local maxima. Similarly, okay, the function may have any other minima also, but look into this region, look into this local region. Okay, the function has the lowest value within this region. It is the local minima. It is known as the local minima. Okay. Now, whether you have a local maxima or local minima. Achha, as per this graph, this is the local minima and also the global minima, can I say? Do you have any other function as per this example? Okay, let us say I am starting from here only. Okay, so is this the global minima? Nahi na? This is lesser. Ye aur chota hai. Okay, this is the local minima and also the global minima as far as this graph is concerned. As far as this graph is concerned. Okay, this is local maxima and also the local minima and also the global minima. So sometimes global points will be equivalent to local, sometimes not. Sometimes not. ठीक है? अच्छा, अब ये देखना, whether it is local minima or local maxima, one thing applicable for both is कि when you draw the tangent to the curve at that point, okay, when you draw the tangent to the curve at that point, when you draw the tangent to the curve at that point, okay, when you draw the tangent to the curve at that point, that tangent is parallel to the x-axis, right? That tangent is parallel to the x-axis. That tangent is parallel to the x-axis, and because, okay, the line is parallel to x-axis, tangent ka slope means derivative. Okay, so the slope should be 0. F dash x should be 0. Similarly for this line. Similarly for this line. So whether it is maxima or minima, one thing is sure, that f dash x equal to 0 at that point. F dash x equal to 0 at that point. That is the first reason, because the possible maxima minima candidates lie on the stationary points. Okay, lie on the stationary points. ठीक है? Lie on the stationary points. ठीक है? ये हमने सबसे पहले निकाला. Okay, so f dash x equal to 0 at maxima minima both. Now, how to classify maxima versus minima? तो देखो, before the function takes maxima, it is an increasing function. Okay, that means increasing function means f dash x positive. Then it reaches the maxima f dash x 0, then it is a decreasing function. F dash x less than 0. So what is the nature of the derivative? What is the nature of the derivative there? Okay, what is the nature of the derivative? Okay, it was positive and then converted to negative. That means there is a sign change. That means there is a sign change. Okay, if it is a local maxima point, the derivative will change the sign from plus to minus. the derivative will change the sign from positive to negative. Clear, everybody? The derivative will change the sign from positive to negative. Okay, the derivative will be changing the sign from the positive to the negative. From the positive to the negative. Right, everybody? From the positive to the negative. That is one rule. The derivative will change sign from plus to minus. Plus to minus, plus to minus, plus to minus. Okay? Acha. Now, if it is minima, the function was decreasing, then it reaches the minima, then increases. That means the derivative, okay, changes the sign from negative and again increasing means f dash x greater than 0. Okay, so at minima, the derivative changing the sign from negative to positive. This is known as, change of sign rule is known as the first derivative test. First derivative test. Okay, first derivative test. Okay. If around the stationary point, first derivative changes in sign from positive to negative, that is a local maxima point. Okay, first derivative changing sign from positive to negative. Okay, then if around the stationary point, okay, first derivative changing the sign from negative to positive, decreasing to increasing, then that is a point of local minima. Then that is known as a point of local minima. Then that one is known as the point of local minima. Everybody? Then that is known as a point of local minima. Yes, Prabhanjan. Okay. Now, the wavy curve that I have drawn for the problem, will just use the first derivative. Dekho, if you go by the regular methods, many people will solve by second derivative. Okay, many people will solve by second derivative. Here a second derivative test. But hardly we will use it. करेंगे इसको भी कुछ problem है. Okay, you should know the second derivative test also. इसको एक बार बता देता हूँ. What happened? Just a second. एक बार इसको बता देता हूँ. Then let's move back to the question that I was discussing. Let's move back to the question that I was discussing. ठीक है? That I was discussing. Okay, so stationary point. Okay, what I am trying to tell is, suppose x equal to x naught is the stationary point. Number one, calculate the stationary point. Now at the stationary point, if second derivative, now calculate second derivative. This is the second derivative test. Calculate second derivative, and if that is positive, it is minima. Okay, this also has a simple derivation, but I'm not deriving it right now, not required. Just know the rules. And if the second derivative is negative, it's going to be a maxima. If the second derivative is 0, neither plus nor minus, then go further. Further means third derivative. Go further. Further means third derivative. Dear, if third derivative is also 0, go further. Further means fourth derivative. If third derivative is 0, go for fourth derivative. Okay, fourth derivative will have the similar rule as second derivative. Fourth derivative rule similar to second derivative. Positive pe minima, negative pe maxima, 0 pe go to next. Okay. But let's come to third derivative. If it is 0, go next. But if it is non-zero, okay, if it is non-zero, okay, at the stationary point, if the third derivative is non-zero, maybe positive or negative anything, maybe positive or negative anything, okay, if it is non-zero, then that point will be the point of inflection. That means at that point, there will be neither maxima nor minima. There will be neither maxima nor minima. Neither maxima nor minima. Okay, I will explain you with the example. Point of inflection bhi aayega aage. Point of inflection will also come with the example. Don't worry. ठीक है? Now, let's go back to the question. Okay, we were talking about a function whose stationary points are calculated, and most likely I will prefer what? Most likely I will prefer the first derivative test. Most likely I will prefer the first derivative test. Okay, change of sign is easy to see from wavy curve. That is why I have drawn the wavy curve. For wavy curve, what I need the roots of f dash x. Roots of f dash x, -1 and 2, increasing order mein plot kar diye. Again I repeat, wavy curve is a curve which will always start from the right of the largest root 2 with a plus sign. And at every root, it will keep changing sign. If it is non-repeated root, if the roots are repeated, wo aage dekhenge. But here both the roots are coming one time, not repeated. So at every non-repeated root, change the sign. Plus to minus, minus to plus. Okay. Now dear, this is the wavy curve for f dash x, na? Wherever f dash x is positive, that is increasing region. Now it is very simple analysis. Wherever f dash x is positive, it is increasing region. Okay, so at this point, at this region, and also in this region, okay, also in this region, I can say that fx is increasing. In both of these regions, I can say that fx is increasing. because the derivative is positive. Okay, the fx is increasing for what? Answer, agar increasing पूछते तो fx is increasing for x less than -1 or x greater than 2. What is the values of x for which a function is increasing? X less than -1 or x greater than 2. Simple. What is the values of x for which the function is decreasing? Ye raha, minus wala. Okay, wherever the derivative, this is the wavy curve of derivative, which is negative here. Negative derivative means the function is decreasing. The function is decreasing for what values of x? Between -1 से 2. -1 less than x less than 2. ठीक है, ये भी conclude हो गया. Okay, now ये क्या है? These are the stationary points. इसकी जरा चर्चा कर लेते हैं अब. Okay, these are the stationary points. Okay, now the stationary point could be maxima, minima, or point of inflection also. Look into the first derivative test again. First derivative changing sign from plus to minus. First derivative changing in sign from plus to minus. अब देखो याद रखना है क्या? Do you have to remember plus to minus, minus to plus? Yeah, be logical. It's not you have to remember sign change plus to minus, minus to plus. You can just be logical in the approach. Okay, function, देखो first derivative plus, plus means increasing. Then it becomes minus, means then it decreases. तो बीच में क्या आएगा? Between increasing to decreasing, what will come in between? Maxima only na. Maxima only, sir. Okay, maxima only. Okay. Okay, so this is the point of local maxima. This is a point of local maxima. Okay. Similarly, what about this point? Derivative changing sign from negative to positive. Dear, negative means decreasing function. Positive means increasing. So it is decreasing to increasing. It takes a dip. That means in between. Logically, Baba, in between kya aega? Minima aega. So this is a local minima point. Okay, this is a local minima point. Everything is extracted, yeah. Nothing else is left. Any type of question you can solve here. But wavy curve is applicable for polynomials only. ठीक है? अब देखना यहाँ पे. Look into the option. Function is decreasing between -2 से -1. No, it is decreasing between -1 से 2. It is decreasing for the range -1 से 2. तो ये तो हो गया wrong. But correct answer is definitely D. Okay. Now it has a maxima x equal to -1. X equal to -1. Local maxima perfect. X equal to 2 minima perfect. B, C, D. For x equal to 2, it has a minima. Perfect. B, C, D. This is B, C, D. Done, 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 done. Very important concept covered. We'll see more variety of question, but this is a very important concept. ठीक है. अच्छा. Now, using this, let me draw a rough curve. Using this na, let me draw a rough curve of the function. Not required always, but एक बार के लिए समझ लेना. Just for one time. Just for one time explanation. Let me draw a rough curve. Okay, just me draw a rough curve here. Okay, just listen to me. What is the function? Okay, the function is given by 2x cube minus something something. देख लेते हैं एक बार. What was the function? 2x cube minus 3x square minus 12x minus 3x square minus 12x plus 5. हाँ जी, ठीक है. That is the function. Okay, that is the function. Okay, I have got local minima, local maxima. ठीक है, global पे भी आएंगे. Coming to the global. Okay, just wait and wait. Suppose, what is the stationary points obtained? Okay, -1 and 2. One of them is local max, one of them is local min. Okay, f of -1. Okay, -1 का cube is -1 का square will be plus only. तो ये -3, ये हो गया +12 and ये हो गया +5. Okay, so this part is equal to 12. अच्छा, what is the value of f2? Okay, 2 into 2 cube, that is 2 into 8, minus 3 into 2 square, that will be 4, minus 12 into 2 plus 5. So this is going to be how much? 2 into 8, that is 16, 16 minus 12, 4, 4 plus 5, 9, and 9 में से 24 गया, minus 15. This should be minus 15, just check on the calculations, है ना? Now I will bring on one more question. Let me take some data here. Question I आएंगे, चलो 0,4 ले लेंगे. Okay. Now, if I present a rough curve here, based on these points, the value at 2 The value at 2 is minus 15. Okay, chalo, no problem. Okay, minus 1 पे 12 है. Okay, say this is x equal to minus 1. It takes some value that is 12. At 2, it takes some value that is known as minus 15. Okay, this is the local maxima point. So before it would be decreasing. Before it would be increasing. Okay, it increases, reaches the local maxima. F of 0 कितना होगा वो भी देख ले. So that is going to pass through 5. Okay. Once again. Okay, it has some value that is 12. Okay, it increases. Okay, it decreases, goes to the local minima. Okay, and after the local minima, it is going to further increase and increase and increase and increase. Okay, increase and increase and increase. Okay, that is approximate plot. Based on the stationary points and maxima minima, एक approximate plot मैंने ready किया है. Okay, this value is known as the 12. This value is known as the minus 15. This is your local minima point, which is your x equal to 2. This is the local maxima point. Okay, increasing local maxima, decreasing, local minima, further increasing only. No more stationary point means it increases till infinity. It increases till infinity. So if I ask you what is the global maxima, if I don't give you any interval, simple question, global maxima, it cannot be defined. In such case, global maxima is undefined. Because the function is increasing, so global maxima can be infinity, though there is no global maxima in that case, if I don't tell you any range. Not defined. Similarly, global minima, prior to this, if you go to the left, it is coming from minus infinity. So that also is not defined. Clear? That also is not defined. But look into the next question now. A function is defined, same function, so that we can relate. Find the maximum and minimum in the interval 0, 4. So when I say maximum and minimum within an interval, that means the overall largest and smallest value. I'm not asking local, global, or I'm not asking local now. In an interval, what is the largest possible value and what is the smallest possible value? So when I say maximum, minimum in an interval, that means global maximum and minimum, and the interval 0, 4 में अगर ध्यान देंगे, okay, this is 0 and let's say this is 4. What we need to do, I don't know what is the value of the function at 0, तो एक बार निकाल लेंगे. The value of the function at 0 will be 5. The value of the function at 4, वो भी निकालना पड़ेगा. 2 into 4 cube, that is 64, minus 3 into 4 square. Okay, minus 12 into 4 plus 5. So how much is this answer turning out to be? Let me write down the answer quickly. This is 128, then okay, this one is 48, then you have 12 into, acha 4 tha, theek hai. So again a 48 and then a 5, this is 37, theek hai, 37, this is 37. So when you take the value of the function at 4 na, it should be 37. Ab dekho, iska ye matlab hai, I'll have to redraw. This was a rough karna. Now on the basis of value I have got, on the value of the basis I got, ki when I take x equal to 4, the value of the function is somewhere 37. 37, ek bar calculations recheck kar lena. Okay, that means it is increasing rapidly. ये value shall you बाद में draw करते हैं. But after this point, it is going to increase rapidly. So that if I take x equal to 4, the value of the function is something like 37. 37. ठीक है, 37. Okay. Okay, 37. Okay. Now, when I ask you what is the overall maximum and minimum in the interval 0, 4, okay. Now, can you tell me the answer as per the graph? As per the graph, can you tell me the answer? As per the graph. Okay. Within this interval, you need to do the analysis. Okay, 0 to 4. So, within 0 to 4, largest value is 37, smallest value is minus 15. Largest is 37, smallest is minus 15. Clear? So, within this interval dear, the largest value f max is 37. That is equal to end point. And what is f min? That is equal to minus 15. This is corresponding to end point. Maxima has been obtained at end point. Minima has been obtained at local point. अच्छा, it is not necessary that कि minima local पे आएगा. Everything depends on this interval. Suppose rather than 0,4, if I give you point other than this, if I had given you some point like this, ये -15 है ना. If I had यहाँ देखना, corner में देखना यहाँ पे, if I had given you the value of x, okay, where the value is more minimum, if I start before 0, if I start at suppose -4, -5, -6, then maybe that is the minimum value. So where is the minima? Maybe local, maybe endpoint, but nowhere else. Where is the maxima? Maybe endpoint or maybe the local point, but nowhere else. Nowhere else. Tell me. Yes, Bhanu, you are correct. Wherever is the overall maxima or overall minima, I can say that it is either at the stationary point or either at the end points. No other candidate can beat these two. Yes or no? No other candidate can beat these two. ये 100% सही है. This is totally and totally correct. That means, let me write down the conclusion now. Answer आ गया है. Okay. Of any given function fx, right, in any closed interval problem given, here the problem is logically closed interval only. Okay, what you have to do, shortcut, see the method. Acha, when I say interval, maximum and minimum within an interval, that means global only, overall maxima, minima. Okay, what is the first step? Okay, first step, calculate the stationary points. Okay, first step is find the stationary points. Okay, and let the stationary points be x equal to x1, x2, etc. There will be some stationary points. Okay, there will be some stationary points. ठीक है जशवंत, उसी को repeat कर रहा हूँ. What is that you have to apply? Okay, step number 2, calculate. Now, no wavy curve also. एकदम direct shortcut for global maxima, global minima problem. You have to just calculate the value of the function at the endpoints fa and fb, and also calculate the value of the function at x1 and x2. Acha, of course, only consider those stationary points which are in the interval a comma b. Otherwise, don't consider. Okay, ठीक है. Consider those stationary points which are within the interval. ठीक है. Calculate. Okay, calculator के लिए भी calculator है आपके पास. You just have the calculator. Now 4 numbers are in front of your eyes. 3 or 4 numbers will be there in front of your eyes. By looking into the numbers, you can say now who is largest, who is smallest. Okay. Look into it. Observe भी क्या बोलना, केवल देखना है. Look and decide. What is the f max and what is the f min. What is one thing I can guarantee you is, whatever is the global maxima or global minima, it is either at the end points or it is either at the stationary points. Nothing other than that. 200% true. ठीक है. Only thing is here as a precaution I will tell you, consider only those stationary points which are within A to B. Like अगर इसके बाहर कोई होगा तो उसको कंसिडर नहीं करना है. ठीक है. डन है. चलो. Tell me answer. 2 real numbers x and y are related. Okay, y equal to 3x square plus 3x plus 1. What is the maximum and minimum value of y? Okay, for x belonging to -2, 0. For x belonging to -2, 0. Tell me. For x belonging to -2, 0. Tell me quickly. 2 real numbers y are given to you. What is the maximum and minimum value for x belonging to -2, 0? Tell me the answer quickly. So simple, what you have to do is First you have to start with the stationary point. Stationary points means derivative equal to 0. So 6x plus 3 equal to 0, leading to x equal to minus 3 by 6, minus 1 by 2. That is one and only one stationary point. That is the one and only stationary point. That is known as the one and only stationary point. That is known as what? One and only stationary point. Okay? Now what you have to do is calculate. Achha, this stationary point is within the interval. Okay. So it has to be considered. Calculate f minus 2, calculate f minus half, and calculate f0. Only one stationary point. Na? See, no wavy curve. Don't decide whether it is local maxima, local minima. Kuch bhi nahi karna hai. Just calculation. F minus 2. Put minus 2. Okay, so 3 into minus 2 ka square 4. 3 into minus 2 plus 1. Okay, 12 minus 6 plus 1, 7. Okay, f of minus half. Okay, 3 into minus half ka square 1 by 4. 3 into minus half plus 1. Okay, so 3 by 4 minus 3 by 2 minus 3 by 4 plus 1, ye 1 by 4. Okay, and f0 is simply 0 and 0 and 1. So f0 is 1. Okay, सबसे बड़ा कौन? 7. सबसे छोटा कौन? 1 by 4. Okay, 7 and 1 by 4. Just look and decide, na. Just look and decide what else you are required to do. This is the largest number out of these three. Maxima, this is the smallest, this is the minima. Okay, this is the smallest, that is the minima. Done ho gaya. Answer is A, 7 and 1 by 4. How much? And such questions commonly come for 2 markers in the exam. Okay, no wavy curve, no first derivative test, no second derivative test, nothing. Just calculation. Calculate stationary point, and that also don't decide which stationary point is local maxima, which stationary point is local minima. Nothing I need from you. Nothing I need. Okay, next question. The important common case, fx equal to x cube. At the point x equal to 0, the function fx equal to x cube. Okay, you must be knowing it. You know the cubic curve also, but ठीक है, एक बार बता देता हूँ मैं. Okay, fx equal to x cube. What about fx equal to x cube? Tell me. What about the fx equal to x cube? So dear, what is the f dash x? That is known as 3x square. Okay, put it equal to 0, stationary point. So x square equal to 0 means x equal to 0, 0. X equal to 0, 0. Take it. Now, either you can go by first derivative or second derivative. Chalo, if I go by second derivative, what is f double dash? Okay, the second derivative will be 6x. And what is the second derivative at the stationary point? Ye important hai na? What is the value of second derivative at the stationary point? That becomes 6 into 0 is 0. And what I told you, when second derivative is 0, what to do? Go next. Go next. Okay, so go for third derivative. Okay, so what is the derivative of 6x? Will be 6. And what is the third derivative at the stationary point? Anyways, it is constant. So third derivative is non-zero. Dear, the third derivative is non-zero. Third derivative is non-zero. What does it mean? I told you, whenever third derivative is non-zero, maybe positive or negative, doesn't matter. If it is non-zero, it is known as point of inflection. Point of inflection. What is point of inflection? Neither maxima nor minima. Acha, same thing if you're trying by a wavy curve. Any method, guys, your answers should be always matching up. Even if you're trying wavy curve. Even if you're trying wavy curve. Okay. किसका wavy curve बनाते हैं? We draw the wavy curve for the derivative f dash x. So what are the roots of the derivative? F dash x equal to 0 at x equal to 0, 0. So there is only one stationary point, but that is repeated. Here you have a repeated stationary point. So what happens in the repeated stationary point? Dekho, wavy curve ka starting pattern is always fixed. I told you, it will always start with the right of the largest. It will always start to the right of the largest root. Right of the largest root with a plus sign. With a plus sign. Okay, and at every root it will change sign. And at every root it will change sign. Okay, but how many roots are at every root it changes sign? How many roots are available here? How many roots are available here? 2 roots are available here. How many roots? 2 roots at the same location. So how many sign changes? Think, na? 2 roots at the same location, to 2 times sign change, plus 2 minus minus 2 plus at the same location. So at the same location means you will moving with the plus only. No sign change basically. No sign change. Because of repetition, okay, because there is repetition, there is no sign change. Because it is repeated, there is no sign change. Now, based on the sign change, dear, based on the sign change, we were deciding local maxima, local minima. Local maxima, local minima. Okay, but here there is no sign change. That means it is point of inflection. No sign change means point of inflection. That is what, how do you see point of inflection using wavy curve when there is no sign change? When there is no sign change. Now have a look into the cubic curve basically. This is what the cubic curve is actually. This is how the cubic curve is actually. So now when you do the analysis at x equal to 0, dhyan dena. Okay, when you do the analysis at x equal to 0, let me first draw the tangent to the curve at x equal to 0. Okay, if I draw dear the tangent to the curve at x equal to 0, if I draw the tangent to the curve at x equal to 0, what happens? If I draw the tangent to the curve at x equal to 0, dear, what happens? What happens? What happens? The tangent is on x-axis. The tangent is on x-axis. Okay, so here the derivative is 0, no doubt. Okay, tangent is parallel to, tangent is exactly on the x-axis, the derivative is 0. Wherever derivative is 0, that is known as the stationary point. Okay, but within the curve itself, you are able to see cubic function. Okay, cubic function is always an increasing function. Is always an increasing function. Okay. Okay, if x increases, x cube will increase. Okay, 0 cube is 0. For negative x, cube is negative. For positive x, cube is positive. At 0, it is 0. Okay, but it's continuously increasing. So, is this local maxima, local minima? What it is? Nothing, na? It is a stationary point undoubtedly, but neither local maxima nor local minima. It is a stationary point, but there is neither maxima nor minima. Nothing. As seen from the graph also. Neither maxima nor minima. ना ये maxima है ना ये minima है. इससे छोटी value भी available है, इससे बड़ी value भी available है. Okay, that is why I called it as point of inflection. You can see from the graph also. That is why it is known as the point of inflection. Hope it is clear to everybody. Okay. That is why it is the point of inflection. Okay, hope that is clear to everybody. Now let me take you towards the next problem. Okay, some non-polynomial case. So please don't apply wavy curve here. It is non-polynomial. Okay, if e power y is x ki power 1 by x, then what about x? Maxima, minima at what points? Tell me. Maxima, minima at what points? Tell me quickly, quickly, quickly. Even the number has to be determined, Nitish, either by graph or by the same explanation. Repeated stationary points you have to see in the wavy curve. So tell me, guys, come on. If e power y is x ki power 1 by x, then what is y? Okay, first of all, we are talking about maxima minima for y. Okay, so if you take y, you have to take the log to remove the exponential. So y can be written as ln x power 1 by x. Okay, log a power b. Okay, the power comes outside. Okay, so ln x into 1 by x. Let me simply write it as log x by x. Okay, y is given by log x by x. Clear, everybody? Okay, so now what is dy by dx? Stationary point. Dy by dx, numerator by denominator differentiation, denominator squared x square, x constant differentiation of log x 1 by x, minus log x constant differentiation of x is equal to 1. Okay, so this is now x to x we cancel hua. So this is simply 1 minus log x upon x square. Okay, so now when you want to check dy by dx equal to 0 for stationary points, okay, that means numerator ko 0 kiya, 1 minus log x equal to 0, log x equal to 1, and x is e raised to the power 1. So stationary point is e power 1. Okay, whether it is maxima minima, chalo. The stationary points is x equal to e, but maxima or minima? Maxima or minima. So chalo, uske liye hum kya karenge? Let us now check the derivative. Okay, d2y by dx square. Let us now take the derivative d2y by dx square. And what is going to be the d2y by dx square? Okay, again if you differentiate, denominator further squared up, x square power x power 4. Okay, that is known as the x power 4. Then x square constant differentiation of 1 minus log x will be minus 1 by x. 1 minus log x ka derivative minus 1 by x, and then minus of 1 minus log x, and x square ka derivative is known as the 2x. Take it, done. Oh cool, we are at 500 attendance. Great. 500 loves, 500 likes. Great. So this is x power 4. Okay, chalo. So now when you see, don't simplify. When you want to calculate the value at the stationary point, which is x equal to e, this is minus x, that is minus e. This part will be 0 because 1 minus log e will be 0 upon e power 4. It is simply minus 1 by e cube. This is negative. Okay, this is negative. Second derivative negative, it is a point of local maxima. Second derivative is negative, point of local maxima. So it has a maximum at x equal to e. Acha dekho, whether this maxima is the global maxima also. Whether this maxima is the global maxima also. Ye bhi dekh lete. Whether this maxima is the global maxima also. What do you say? Ye bhi dekhte hain ek baar. Whether it is the global maxima, let me check. Let me take you towards a simple reason that there is only one stationary point. If there is one stationary point, only one stationary point, okay, that is x equal to e. Acha, what is the nature of stationary point? Function is increasing up to stationary local maxima point and then decreasing. There is one stationary point, that is a local maxima. And what is the nature of local maxima? The function is increasing up to local maxima, then decreasing. Whatever is the shape of the curve, rough banate hain. Okay, so function is increasing up to this point and then decreasing. Acha, there is no other stationary point. Also means that there is no other point where the function can change the nature again. There is no other point here also where the nature will change. Okay, that means before this maxima, this is the local maxima. Okay, before it, function is increasing and reaches here. After it, it is decreasing. Okay, so all the values to the left are less, all the values to the right are also less. Okay, that means I can say that this is also the global maxima. Okay, so whenever there is only one stationary point, and that stationary point is a local maxima, so that will be a global maxima also. Without range even. Without range ka matlab hai from minus infinity to infinity. This is the global maxima. Of course, global minima cannot be defined. If I ask you global minima, minus infinity, that means undefined. For global minima, I need the range, but global maxima is clear in front of you. So listen to me. If there is only one stationary point and that is a local maxima, it will also be a global maxima. Similarly, if there is only one stationary point and that is a local minima, it will also be a global minima. Whatever it is. Whatever it is. However you take it. Everybody okay? Everybody okay? Now some application, geometrical questions also can be there. Okay. Geometrical question can also be there. Okay. Okay. Oh, great to know that pursuing you are into VLSI in IIT, whatever IIT it is, but VLSI will definitely give you good placements. Okay, whatever IIT, but VLSI, at least you have got the best branch. Okay, so VLSI placements are on good track, whether it is IIT or even NITs also. Okay, so great. Thank you for your love and God bless you. Well, the right circular cone of largest volume that can be enclosed by a sphere of 1 meter radius. The right circular cone of largest volume that can be enclosed by a sphere of 1 meter radius has how much height? Okay, अब देखो यहाँ पे कहीं ना कहीं largest volume की बात चल रही है. That means it is the question on maximum volume. Okay, of a cone that can be enclosed by a sphere. That can be enclosed by a sphere. Have a look into the 3D picture here. Have a look into the 3D picture here. I need a cone that can be enclosed by a sphere. So I think first let me draw a sphere here. ध्यान देना. Okay. Let me construct a sphere. Let's say this is a sphere. The cone is to be enclosed by a sphere. So let's consider this sphere and there has to be a cone. Just a second, it is stuck. Now it is okay. There has to be a cone which is enclosed by this sphere. Okay. Approximately, roughly of this kind. Roughly of this kind. Everybody okay? ठीक है जी. So what I need is now, what is the right circular cone of largest volume that can be enclosed by a sphere of 1 meter radius? Okay, so the radius of the sphere is given to you. Let us call it as the center. Let us mark it as the center. Okay, and now what I will do is I will draw. I'll have some connections here. Okay, this is known as the radius of the sphere, so the center to the circumference. Let me drop the perpendicular to the base of the cone. Okay, and also let me tell you the radius of the base of the cone. Okay, let us say R is the radius of the base of the cone, capital R is the radius of sphere, and this is equal to x. अच्छा, ये x है, वापस ऊपर की तरफ चलते हैं. Okay, any distance from center to the circumference is capital R, and this now becomes the total height. This now becomes the total height. I need to find the height so that we get the maximum possible volume. Okay, we need to get the maximum possible volume. So when I say R is the radius of the base of the cone. That is not known to me. But when I say capital R, I'll explain here, that is nothing but the radius of sphere, and that is at least known to me because it is clearly mentioned that we need to enclose the cone by a sphere of 1 meter radius. By a sphere of 1 meter radius. R is known to me, small r is not known to me. Okay, but what is the total height? Okay, total height, this part x and then plus the capital R, that means x plus 1. That means x plus 1. Say this is O, this is P, this is Q. So when you consider this triangle OPQ separately, it's a right angle triangle. When you consider this separately, this is R which is equal to 1, this is small r and this is x. So these are also related by the Pythagoras theorem. Okay, x square plus r square equal to the 1 square. Pythagoras theorem. Okay, now I need to talk about volume. Acha ji. What is the volume of the cone? 1 by 3 pi r square h. I need to find h, so let us eliminate the r. I need to find h, so let us eliminate the r. Now what is going to be the r? Okay, if you eliminate r from here, it is 1 minus x square. Okay, further you can write down x as how much? Okay, so x is h minus 1. H is x plus 1, so x is h minus 1. H minus 1 whole square. So r square is 1 minus h minus 1 whole square if you open. H square plus 1 minus 2h. 1 will get cancelled. R square is 1 will get cancelled. Minus minus plus 2h pehle and then minus h square. So r square is also known to me in terms of h. So it becomes a single variable. There can be maxima minima for two variable also, वो भी cover करूंगा मैं. Okay, so this now becomes 1 by 3 pi r square as just now written 2h minus h square multiplied by h. So volume is a function of height 1 by 3 pi. Okay, then take h inside 2h square minus of h cube. Okay, volume is nothing but a function of h, and for maxima or minima you need to apply the regular calculus rules. You will start with the first derivative equal to 0. You will have dv by dh, and what is the dv by dh? 1 by 3 pi 2h square का derivative 4h minus 3h square equal to the 0. Okay, so 1 by 3 pi h को common भी लिया तो 4 minus 3h equal to 0. What is the solution coming up from here? That h would be how much? Either 0, which is not possible, or either 4 by 3. Okay, 0 is not possible because of the height of a cone is 0. There is no cone existent. Okay, the 0 is an impossible value. So that means that the height will be 4 by 3. Acha, in such cases, now you have only got one value of height, and the question is about maxima. For maxima, we need to check second derivative basically, but you have got only 1 point. Na? 100% it will be maxima only क्योंकि उनने maxima पूछा है. You can trust it, but चलो फिर भी निकालना है, no problem. So if I go for d2v by dh square, no problem. I go by d2v by dh square, second derivative of this. Okay, so differentiating again. 1 by 3 pi, 4h का derivative 4, 3h square का derivative 6h, and I only need to calculate at h equal to 4 by 3, what is the second derivative? 1 by 3 pi, 4 minus 6 into 4 by 3, so that looks like bigger than 4, it is negative. It is negative, ये हो गया 4 minus 8, okay, negative, confirming maxima. Confirming maxima. So at what height you will get maxima? You will get the maxima at the height 4 by 3. You will get the maxima at the height 4 by 3. You will get the maxima at the height of 4 by 3. Answer is C. The cone will have the maximum volume at the height corresponding to 4 by 3. Everybody okay? Okay, at the height corresponding to 4 by 3. Hope that is clear. Oh my god, it's like another non-stop 3-hour session completed, 3 hours tenure. So we are there since morning 10, but after lunch break we started at around 2:05, 2:10, it's 5:10. Non-stop 3 hours. Great energy guys, great energy. That calls for a like for all of you. Okay. Total 7 hours completed since morning. Total 7 hours completed since morning. Okay, so one more geometrical question I shall give you as homework. You can try it out. Let's move to the next category. Okay, for a right angle triangle, if the sum of the length of the hypotenuse and the side is kept constant, in order to have maximum area of the triangle, what is the angle between hypotenuse and side? क्या पूछा गया है? थोड़ा सा एक बार अगर आपको roughly समझा दें. So, right angle triangle है. A very basic application question. Okay, if the sum of the lengths of hypotenuse and the side is kept constant, suppose this is the side S and say this is the hypotenuse. Okay, the sum of these is kept some constant, suppose any constant C. In order to have the maximum area, okay, what is the angle between the hypotenuse and that side? Okay, let's say the angle between them is theta. The question is about theta. Okay, for maximum area. What is the theta between them? Okay, for the maximum area. Okay, maximum area. For the maximum area. Acha. Now again, what about the area? How do you write down area here? Area can be half into base into height. So what about this height? इसको मैंने hypotenuse लिया है. So what about this height? Okay, yeah. If you are confused with height or hypotenuse, let me say the hypotenuse is having some length L. Okay, let us say the hypotenuse is having some length L. This is one of the side. Now this is suppose the height, and height will be under root of L square minus S square as per Pythagorean. Okay, under root L square minus S square. Okay. Now you are looking like you have two terms, but you can replace one of them by L plus S equal to constant. Okay, you can replace L plus S equal to constant. You can say that L is equal to C minus S. You can write it in any of the terms. So let's convert this into terms of S. Area is a function of S. Solve it up. What is the maximum value Okay, dy by dx again 0. The hint also I have given. You can solve completely by as a homework. Okay. So here it looks like two variable, but the other variable is relatable. But some of the functions are actually two variable only. Some of the functions will be actually two variable only. Okay. So when you have the maxima and minima for two variable function, when you have the maxima and minima for two variable function. Okay, for two variable function. No, 45 nahi aayega, Dinesh, recheck it once. It will not be 45. Okay. Maxima minima approach for two variable. Acha, just let me tell you one thing. Are cos theta nikaloge an issue. How to calculate theta? Okay, you can calculate base upon hypotenuse. Okay, you will get a relation between S and L. Na? Cos theta is S upon L. Base upon hypotenuse. Okay, so then theta will also come. You need that theta, na? You can use cos theta as S upon L. यहाँ से theta आ जाएगा, ठीक है? चलो. Maxima minima for two variable. Okay, maxima minima for two variable. But before I start the two variable, okay, before I tell you the two variable maxima minima, just let me tell you that. Okay, just let me tell you that. Okay, yeah, we will jump back to this, but just allow me a minute. Okay, let me tell you some fundamentals because we are going to use the partial derivative. It is nothing new. बहुत quickly बताऊंगा मैं partial derivative. It is nothing new. Okay, so if suppose u is a function of x comma y, and very soon we are going to go for a break. Okay, it has been a 3 hours continuous session again after the lunch break. Okay, so it calls for another tea break. We are going to go for a tea break. So if u is a function of x and y, if u is a function of x and y only, okay, u is a function of x and y only. Okay, that is a function of two variable. We call del u by del x. Now, what is del u by del x? Del u by del x is known as the partial derivative. Okay, partial derivative of u with respect to x. So, when I say partial derivative with x, with one variable, so y is constant. So, what are the rules when you differentiate with a constant? You already know, na? That is why it is not a difficult problem for you. Direct question bataunga, but you must know the first principle. This is again the first principle. If it is f of x comma y, I am differentiating with x. So suppose x is changed from x to x plus h. इसको ऐसे मान लेते हैं. X is changed from x to x plus h. So what is the value of the function? Okay, what is the value of the function? F of x comma y, and here f of x plus h comma y. Y is unchanged. In both the scenario, you please see that y is unchanged. Okay, you please see that y is unchanged. Okay, only x changes. The function f of x plus h comma y minus f of x comma y. Divided by change in the value of x. For small change, limit h tending to 0. That is known as del u by del x. You should know the first principle. Similarly, when you want to calculate del u by del y, okay, f of x comma y plus h minus f of x comma y. X ko change nahi kiya. Y changes from y to y plus k. Change in y is k. So limit k tending to 0 for small change. Okay, for small change. Okay, for small change. Okay, now come here. Okay. For a function, find the first and second order partial derivative. Okay. Yeah, only some portions from here will be there for CS. I will tell you when to stop for CS. Okay. But at least fundamental of two variable. Okay. Indirect वहाँ पे question बनता है, तो fundamental of two variables should be known to you. The fundamental of two variables should be known to you. Where to stop for CS, I will tell you. Okay. So if u is equal to x cube plus y cube minus 3xy, find the first and second order partial derivatives. 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 So dekho, when I talk about first order, find the first and second order partial derivatives. Okay, when I talk about first order partial derivatives, okay, so dekho, what is going to be the del u by del x? What is going to be the del u by del x? Tell me. What should be the del u by del x? So del u by del x, 3x square, okay, plus 3y, sorry. When I told you del u by del x means what? Differentiation of u with x, keeping y constant. So you know the rules of constant. Okay, differentiate a constant, it will become 0. Okay, then minus 3xy में minus 3y तो constant है, x का derivative 1. That is del u by del x. ठीक है. Then next I will calculate del u by del y. Similarly, when I am differentiating with y, that is why it is nothing new for you. You know the rules of constant. So when you differentiate with y, keep x constant. तो x cube का derivative 0, y cube का derivative 3y square, minus 3x constant, y का derivative 1. These are the first order derivatives. These are known as the first order derivatives. Now what's next? These are the first order derivatives. What's next? यहीं पे second order करते हैं. Now first order derivative, again you see they are containing two variables x and y. They are again containing two variable x and y, na? They are again containing two variable x and y. So you can again take the two derivatives. One with x, one with y. Okay, one with x, one with y. So I am now going to take, see, del by del x of what? Del u by del x. Del by del x of del u by del x. That is known as, that is what is the second derivative. Del 2u by del x square, also known as uxx. Okay, this was the ux, na? Derivative with x. This was uy. Double derivative with x. Del 2u by del x square is uxx. Okay, is uxx. And what is the answer? Differentiate again with x. You get 6x. Y is constant. Okay, now next. Now I differentiate it with y. So del by del y of del u by del x is known as how much? Please see. Del by del y of del u by del x. Of del u by del x. So that is double derivative del 2u by del y del x. By del y del x. So now you are differentiating with y. Achha, this will be known as uyx. This is uyx. And what is the answer? Differentiating now with y, you get minus 3. Differentiating with y, x is constant, so answer is minus 3. ठीक है, अब इस पे आ जाते हैं. इसके भी दो cases बनेंगे. Both of them let us discuss. Okay, what is the first case? Differentiate with x. Del by del x of del y, del क्या है? Del u by del y. First differentiate with x and then with y. So del by del x of del u by del y. This is known as del 2u by del x del y. Del 2u by del x del y. Again I am differentiating with x. So y constant है, minus 3x derivative minus 3. Acha, by the way, this is known as uxy. And this is minus 3. Okay, now next I am taking del by del y of del u by del y. Double derivative del 2u by del y square. And that is known as uyy. Okay, double derivative with y. Okay, just notations also you should know. And what is again the differentiation with y? It's going to be 6y. This is going to be 6y. Okay, x is constant when you differentiate with y. Acha, note that these two values are same. Difference is del 2u by del y del x and del 2u by del x del y. It is a double derivative once with x, once with y. But order doesn't matter. Order doesn't matter. Order does not matter. Clear, everybody? Order will not matter. Okay, order will not matter. So that means you can note down not only here, always del 2u by del x del y or del 2u by del y del x, they are always the same. They are always the same. Okay, so when I ask you second order derivatives, okay, when I ask you second order derivatives, okay, they will be only counted as 3. Del 2u by del x square, del 2u by del y square, del 2u by del x del y, del 2u by del x del y. Yeah, del y del x, any one of them, del 2u by del y del x and del 2u by del x del y, usko ek hi count karna hai. So I'll consider 3 second order partial derivatives. And there are 2 first order partial derivatives. Notations are ux, uy, okay, and then uxx. Achha, these are also having different notations. In some of the books you call it as p. In some of the books you call it as u. Okay, pq. We call this as r. Okay, we call this as s. These two are same only. uxx या uxy or uyx, they are s. And the double derivative with y, that is t. So we also have the notation pqrst. Just notations hai. Okay, just notation hai. Sometimes it is a very simple topic, but sometimes to a surprise, there can be simple one marker question from here. Like, look into this question. There is a function, okay, f equal to e power 1 minus cos xy, 1 minus x cos y plus xz e power minus 1 upon under root 1 plus y square. Okay, some random function is given. But the only question is, what is the partial derivative of this function with respect to x? Only with respect to x. So function is f. So I am only asking you del f by del x at a particular point. What is del f by del x? So when, very simply, even if it is 3 variable function, even if it is 3 variable function, okay, even if it is 3 variable function, okay, when you are differentiating with x, so what you will do? Other two y and z will be constant. Other two will be constant. So differentiate kiya x ke saath. Exponential derivative is exponential only, 1 minus cos xy. But I am differentiating with x, dhyan rakhna. Okay, so now I apply chain rule. 1 is constant, minus x cos y, mein cos y constant, x is 1, x derivative is 1, so minus cos y is left. Plus, Now, this whole term z into something 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 is constant. Derivative of x is 1. Okay, so this is whole left as it is. Okay, plus z e raised to the power minus 1 upon under root 1 plus y square. Now, I need this value at the point 1 comma 0 comma e. At the point 1 comma 0 comma e. Okay, so what is going to be the del f by del x? It is e raised to the power 1 minus, okay, 1 minus 1 into 1 cos 0 भी 1 है, okay, into minus cos 0, okay, cos 0 1 plus z is equal to e into e power minus 1, y की जगह 0 आएगा तो power is just 1. So this is known as how much? 1 minus 1 0, तो e power 0 1 तो minus 1 plus e inverse cancel 1, तो answer is 0. Final calculation, it is just some basic calculations, the answer is 0. Oh, I think option number C missing hai, that has to be 0 only. The correct answer has gone missing and that is my answer, that is the C. Everybody okay? No. They cannot be in general related. Okay? So correct answer is option number C, which is equal to 0. Okay? Achha, based on the partial derivatives, na? Based on the partial derivative, you should also know what is the total derivative formula. Not here, but they are somehow useful in the vector based. ठीक है, इस पर direct question का कोई sense नहीं है. This is very fundamental, but we will use it later. Okay, in the vector differentiation concepts and all, divergence, gradients especially relate करेंगे इसको. We are going to relate it to the gradient. Okay, so the total differential operator df, suppose f is a function of 3 variable x, y, z. General वाला बताता हूँ. Then df is written as del f by del x into dx. Del f by del y into dy, del f by del z into dz. Okay. Del f by del x into dx, del f by del y into dy, del f by del z into dz. This has a very simple derivation based on chain rule, but not required right now, na? ठीक है. अरे rt minus s square होता है, that is in the maxima minima. We will come to that, na? We were discussing maxima minima only, 2 variable पे भी आएंगे. Okay, that is rt minus s squared here. ठीक है. So before that, I'm just revising some basic concepts around partial and total derivative. Because total derivative, once we discuss the vector, now we will be requiring here. Okay, it is nothing but chain rule differentiation. Okay. Okay, so you can simply note down. Okay, now I have the total derivative of f. Maybe x, y, z are further dependent on t. F also, see, f depends on x, y, z. Suppose x, y, z further depends on time. So also we can say that the function depends on time. So we can write down du by dt also. Yeah, df by dt also. So that expressions can also be done. So suppose if that is the condition, okay, if that is the condition, total derivative, okay, suppose u is a function of x, y, z, okay, where x, y, z are functions of time, then what is du by dt? What is du by dt? Del u by del x into dx by dt. Del u by del y into du by dt. Oh, sorry. Yeah. dy by dt होगा, typo error. Del u by del z into dz by dt. Okay, nothing. You remember this, na? All the derivatives are taken with time. dx by dt, dy by dt, dz by dt. Okay, substitute here, you get the du by dt also. Okay. Simple, you must know the formula related to gradient, directional derivative. Okay, but directional derivative, again, directional derivative looks like a calculus term, but actually that is studied under vector calculus. Directional derivative. Derivative of a function along a given direction. So because direction is involved, वो vector में जाएगा. वो vector में जाएगा. Directional derivative is an important area again. Is an important area. Questions are coming up on that. Now there can be some more, application of the partial derivative, differentiation of implicit function. पहले implicit function क्या होता है? Suppose, what is the implicit function? Listen to me. What is the implicit function? Listen to me. Suppose I give you, there is a relation. Suppose x square plus y square equal to 5. Suppose. Okay. X and y are related. But can I tell you y as a function of x? X and y are related. But can I tell you y as a function of x? Yes, I can tell you. Y is equal to 5 minus x square whole under root. X and y are related and you are able to explicitly specify y in terms of x. Okay. Yeah, there may be relation of the form. Okay. Okay, suppose 2x plus 5y, okay, is equal to 4, something like that. So can I express y as a function of x? Okay, yeah, it is 4 minus 2x divided by 5. Okay. There may be relations of the form x square y is equal to 2. So can I write down y? Y is 2 by x square. So in many functions, in many relations, you can write down y as a function of x. Okay. Tell me y as a function of x. 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 नहीं बता पाओगे. However you want to try, please try. You will not be able to tell me. Okay. Okay. So there is some relation between x and y. देखो, they are related. If there is an equation, they are related. Okay, but we cannot split. The problem is we cannot split. Okay. We can't express. है relation है, but we can't express explicitly. Okay, such relations are known as implicit. There is relation, but we can't express what is y versus x. But all of them, this is explicit, this is explicit, this is explicit. When you're able to write y as a function of x, then that is an explicit relation, otherwise it is implicit. And if you have an implicit function, suppose f of x comma y equal to some constant, okay, like this function, okay, something 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 equal to constant. This is dependent on x and y. There is a xy function equal to constant. Then the derivative dy by dx is given by minus del f by del x upon del f by del y. Nothing, guys, this is just all chain rules. This is all chain rule thing, nothing new. This is all chain rule thing, nothing new. ठीक है भाई, मैं एक सिंपल एग्जांपल लेता हूं. चलो, ये तो मैंने एक रैंडम एग्जांपल लिया. ओके, से फॉर एग्जांपल, इवन इफ आई टेक अ फंक्शन ऑफ दिस काइंड x क्यूब प्लस y स्क्वायर, ओके, प्लस xy इक्वल टू 5. यू ट्राई, यू विल नॉट बी एबल टू एक्सप्रेस y. नहीं, यहां पे तो फिर भी कर पाएंगे, यहां पे तो फिर भी कर पाएंगे. ओके, लेट मी चेंज इट स्लाइटली बिकॉज क्वाड्रेटिक इक्वेशन से हो जाता है यहाँ पे. x क्यूब प्लस y क्यूब plus x square y square equal to 6, something like that. Here, okay, you will not be able to express explicitly. Okay, this becomes an implicit example. This becomes an implicit example. अब देखो, what is dy by dx? Either you go by basics or either you go by formula. Your choice. Okay, your choice. I told you what is dy by dx, and that is known as minus del f by del x divided by del f by del y. Okay, where you call this as the function f equal to constant. Okay, once partial differentiation with x, तो कर दीजिए partial differentiation with x 3x square, partial differentiation with x में y constant, तो 2xy square. Okay, divided by partial differentiation with y, तो 3y square. Okay, plus 2x square y. That's it. That is your answer. Only thing is formula will give you a one line answer. Otherwise you can go by your basics also. Dear, you can go by the basics. अब basics क्या बोलता है? I want d by dx ना. I will start differentiating it left side and right side. और actually वहीं से ये formula आया है. Differentiating both the sides, but right side is constant. The differentiation of constant will be 0. Okay, will be 0. अरे बाबा, that is because of the derivation, Sudhanshu. ठीक है? Okay, you can express, see, what is the derivation? Nothing. Express the total derivative of f. Okay, equate, you will understand why it is 0. Okay, simple hai. So, if you take here, differentiation with x, it is simply 3x square. A differentiation of x cube is 3x square. Okay, plus y cube. Now, we are differentiating with x. So, what is the y cube derivative is 3y square, but I have to write down dy by dx. I have to write down dy by dx because ultimately I'm differentiating with x. That is what chain rule is. Now I told you everything is nothing but a chain rule application. Okay. Plus now I have product of two terms. So I will apply product rule also. Okay. So x square को constant रखा तो y square का derivative 2y dy by dx. Okay. Because differentiation with x. Okay. Plus if you take y square constant, तो x square का derivative is only 2x because it is with x only. Right side में आ गया 0. Okay, now can you tell me the answer? Dear, dy by dx, if you take common from the left side, you have 3y square plus 2x square y. Send other terms on the right side, so that becomes minus of 3x square plus 2xy square. Are you not going to get the same answer? You have got the same answer. Nothing. Okay, so that is why I'm telling all these applications na, function of implicit functions or differentiation of implicit function, total differentiation, all this comes under the partial derivative, but this is basically application of chain rule and product rule, nothing more. Nothing more. Okay, got it? Okay, Sudhanshu. Okay, now let us come back to a point that we were discussing. Okay, let us come back to a point that we were discussing, and we were discussing the maxima and minima. Okay, we were discussing maxima, minima, and we wanted to go for the maxima, minima of two variable. Okay, we wanted to go for the maxima, minima of two variable. Okay, so suppose z or u, whatever you say, is a function of two variable x, y. Okay, the rule is slightly similar. Stationary points, first derivative equal to 0. Okay, but how many first derivatives? 2. Del z by del x, del z by del y. Okay, this can be known as P, this can be known as P, Q. Already I have told you the notations P and Q. Okay, so take the first derivative equal to 0. Stationary point calculation. Okay, stationary point calculation. The solution that you get from here, they will be known as stationary points. Okay. So, del z by del x equal to 0, del z by del y equal to 0. You will have two equations because two variables are there. Solve for x and y, and that is known as the stationary point calculation. Then next is substitute the stationary points in the RST. Now, what is RST? Second derivatives. How many second derivatives? Total I told you 3. Del 2z by del x del y or del y del x, one and the same thing. तो एक ही लिखा है मैंने. तो R del 2z by del x square, S del 2z by del x del y, T del 2z by del y square. So what you have to calculate basically, okay, after finding this expression, what you are required to do is calculate RT minus S square at the stationary point. Calculate RT minus S square at the stationary point. Okay. RT minus S square at the stationary point. Okay. And if the RT minus S square, if by chance is negative or equal to 0 also, if RT minus S square less than equal to 0, then there is neither maxima nor minima. Okay, such a case is, which is similar to the point of inflection. Okay, is nothing but a saddle point here. It is nothing but a saddle point here. Okay, just like the point of inflection for single variable function. But if RT minus S square is positive, then check the value of R. Okay, if RT minus S square positive, check the value of R. R negative, local maxima, R positive, local minima. That is how it is going to be. That is how it is going to be. It's better to apply on a problem and then conclude. Have a look into this. Yeah. Look into the function 4x square plus 6y square minus 8x minus 4y plus 8. What is the optimal value? Now, when I say optimum, it's either maxima or minima. Okay, if either optimum, either maxima or minima. Okay, if all principal, देखो, no separate doubts here, please. Okay, my concentration disturb होगा. Okay, what is the optimal value of x and y? What is the optimal? Optimal means maxima or minima. Okay, so given the function 4x square plus 6y square minus 8x minus 4x minus 8y plus 8 equal to 0. ठीक है? Whether it is maxima minima, the first step is stationary points. So I start with the calculation of stationary points. I start with the calculation of stationary points. So I start with the calculation P, that is del f by del x. And what is del f by del x? Differentiate with x. So you get 8x minus 8, y is constant, and we have to equate it to 0. Okay, so we get x equal to 1. And then we have q. Both the derivatives we need to take. First derivative, del f by del y. With respect to y, 6y square derivative 12y minus 4 equal to 0. This gives y equal to 1 by 3. So what is your stationary point here? Only one stationary point. Okay, 1 comma 1 by 3. So we have only one stationary point. Okay. We have only one stationary point, and that stationary point is 1 comma 1 by 3. There is only one stationary point, that is 1 comma 1 by 3. Clear? Where is that? Okay. Soon I am going to announce a break, a tea break. Okay. We will continue after tea break. But most likely the topic I am taking after tea break will not be there for CS. Okay. CS again invited tomorrow. I will tell you. Let me announce the break. I will tell you. Okay, but CS will be again invited tomorrow. CS का syllabus over नहीं हुआ है, but I will now take a topic which is not in CS. ठीक है, थोड़ा एक different topic पे चले जाएंगे. Okay, so the today's PDF password, before you move out, before the CS students move out, the today's PDF password Maxima, and I'm not going to repeat it till night. जब तक पे चलेगा. I only tell once. Okay. It's all those who are sitting continuously, they deserve it. Okay. Telegram link I shared, Pavan, I'll share you one more time. Just wait and let me give the break. I'll share one more time. Okay. So it is going to be Maxima, everything in small. Maxima, everything in small. The password for today's PDF, Maxima, randomly created. Okay. Okay? Maxima. Okay? Chalo. Aate. So we were into the middle of a problem. Let us complete that. But I'll tell you when CS have to leave. मैं बताऊंगा कब leave करना है, अभी नहीं. Okay, so I have a stationary point and that stationary point is 1, 1 by 3. Now at the stationary point we calculate RST. Okay, so first individually what is RST? Del 2f by del x square. Okay, I have del f by del x. Okay, differentiate again with x, so you get 8. You get 8. Okay, please don't type any passwords. Okay, then if I get s, okay, that is the double derivative del 2f by del x del y. So suppose I have differentiated with x. Now differentiate with y. Kitna milega? 0. If this is the derivative with x, when you differentiate with y, it's going to be 0. And t del 2f by del y square. Okay. Del 2f by del y square. Okay. Differentiate the first derivative with y. Differentiate again with y. The answer is 12. The answer is 12. Okay. What is the value of rt minus s square? Okay, so r into t is 8 into 12 minus s square 0. So rt minus s square is definitely positive, 8 into 12. Okay, it is definitely positive even at the stationary point. Okay, even at the stationary point. So now what is r? Whenever rt minus s square positive, we check the value of r. Okay, and r is going to be how much? 8, which is positive. So that confirms a minima. R positive confirming minima. Okay, so optimal value is minimum, and what is the equal? So I mean the value bhi nikalna hai. So I can say that the function f has minima at the given stationary point 1, 1 by 3. So what is the minimum value of the f? Ye nikalna padega. So we have 4x square plus 6y square plus 8x minus 8x minus 4y, sorry. Okay. Minus 8x minus 4y plus something plus 8. Okay. Let us write down the answer. So it's going to be 4 and plus 6 by 9 minus 8. 6 by 9 minus 8 minus 4 by 3 and plus 8. So 8 cancel hua. It's 4. This is 2 by 3. Okay, so it's plus 2 minus 4 by 3. Okay, so answer is 4 minus 2 by 3, 12 minus 2, 10 by 3. Answer should be 10, and that is the minimum. That is the minimum. So it has a minima, okay, and equal to 10 by 3. It has having a minimum equal to 10 by 3. Answer is 4x square, not cube, Prabhanjan. It has a minima and that is equal to 10 by 3. They can ask you minimum at what value of xy? Yeah, minimum value. So there is minimum value equal to 10 by 3. By putting xy, that is x equal to 1, y equal to 4 by 3. X equal to 1, y equal to 4 by 3. ठीक है? Done है? Chalo, if you are comfortable with this, okay, now the function f has minimum value at, okay, has minimum value. So guys, similar, just some small data is changed, just small change in data. 2 variable function, homework for you. 2 variable function, homework for you. 2 variable function, homework for you. Now one more homework, one more request homework. Okay, one more request homework. Okay, for you guys, I have a request homework. You decide whether you take up this request or not. Okay, what is that request homework? There is one more theory, not very important. Homogeneous functions and Euler's theorem onto it. Not very important, guys. Dekho. Not very important. Even if something moderately important, okay, we are standing and covering. Okay, so homogeneous function and Euler's theorem. Okay, please go through it. Can you do this homework? Okay, It will be included in the PDF. चलो और बोलिए. When I share you the PDF, it will be included in it. Okay, Cauchy ratio तो complex में आएगा ना, अभी तो calculus में है, basic calculus. We were talking about partial derivatives, ना, two variable function and all. So with two variable, there is one topic, Euler's theorem. Not very important, even not moderately important. Okay, and I will give in the PDF also. I have the slides, but I think it's better to start something more important. Okay, you can try. Any doubts? Yeah, if you want कि करना ही है तो कल करेंगे. Okay, but yeah, advantages. I will include this in the PDF. I will include this in the PDF. Okay, I will include this in the PDF. Okay, ready? It's a request homework. Okay, if you know, if let me know if you don't want to do it. It's a request. You can try. नहीं होगा तो कल बताओगे. That is why I'm giving today. नहीं होगा तो कल आप बताओगे. Tomorrow you can at least tell me. Okay. Okay. I'll give you the PDF. I'll give you the slides in PDF. अब चलो. Let's go for a tea break. Let's have some munching. थोड़ा बहुत munching करके आते हैं. Tea break करते हैं. Approx 15 minutes. Approx 15 minutes. Okay. So we resume at 6:00 p.m. We resume at 6:00 p.m. Okay. Very carefully, please remember that. Very carefully, please remember that CS students, okay, are not allowed, not requested to come after this. I mean, if you want to study extra, you can come. Okay. इसके बाद CS को नहीं आना है. Okay. So all CS students, okay, now you join tomorrow. यहीं पे मेंशन कर देते हैं, इजी होगा. CS students, join tomorrow at 10 a.m. Join tomorrow at 10 a.m. Okay. ठीक है, join tomorrow at 10 a.m. All CS students can join tomorrow at 10 a.m. अच्छा, कल 10 a.m. पे मैं क्या पढ़ाऊंगा? Okay. CS students, join tomorrow at 10 a.m. And what is that I'm covering at 10 a.m.? Exact topic तो I don't know. Okay, exact topic तो I don't know. Okay, I will start with either probability. चलो मैं hint कर देता हूं. और integrals. कल 10 बजे या तो प्रोबेबिलिटी डिस्ट्रीब्यूशंस या इंटीग्रल कैलकुलस स्टार्ट करेंगे. बोथ ऑफ देम आर इन द CS एंड अदर ब्रांचेस आल्सो. अच्छा, द टॉपिक आफ्टर ब्रेक, इट इज देयर फॉर ऑल ब्रांचेस एक्सेप्ट CS. सबको आना है, CS अलाउड है जाने के लिए. इफ यू वांट लर्न समथिंग एक्स्ट्रा, या इन केस यू आर प्रिपेयरिंग फॉर एनी गवर्नमेंट एग्जाम्स या PSU ESC एग्जाम, तो देन यू कैन स्टे. किसी और ब्रांच से अगर आप इंजीनियरिंग सर्विसेज लिख रहे हो, देन यू कैन स्टे. बट दैट इज श्योर, टुमारो 10 a.m. आई विल स्टार्ट अ कॉमन टॉपिक लाइक प्रोबेबिलिटी और इंटीग्रल कैलकुलस. ठीक है, इंटीग्रल कैलकुलस ये जरूर करेंगे, कल यहीं से स्टार्ट करेंगे, ये पक्का. एनी ऑफ दीज टू आई विल डिसाइड. आई एम नॉट डिस्क्लोजिंग राइट नाउ, बट एनी ऑफ दीज टू आई विल स्टार्ट टुमारो. ओके, राइट नाउ लेट्स स्टार्ट द ब्रेक. 15 minutes. ओके, 15 minutes. So let's make it 6:02. Let's make it 6:02 p.m. We start. No more discussions. Crucial. Time is critical. Time is precious. Let's go. Meet after 15 minutes. Okay. So now time to continue. Time's up for the break. Very good evening, everyone. Hope you had your tea. Hope you had your munching. And time to get moving ahead. Now. Okay. All right. So, just now we have shared you the link for tomorrow's session. So, in case you don't miss out where is that, where is not that. Okay. So, number one thing that we will do before we start up before the break, there is a link for tomorrow's class. Again, we are going to start at 10 a.m. As mentioned. Okay. And I have requested one homework also from you. Remember that. I have given you a request homework. Okay. So this is the mathematics that we need to cover for the 2 days, 20 and 21st January as promised. Okay. Tomorrow is 21st January and we are going to have the part number 2 tomorrow at 10 a.m. Okay. Just now the class link again shared. Okay. Do click it and set your reminder. Don't miss it. And already for today we have already hit. Okay. The 5th century. Okay. Let me see the current numbers. Let me just go to the tab. For today we have already hit the 5th century of likes. Okay. It's been almost 9 hours since morning. 9 hours since morning. Is it not audible? How come so? It's been almost 9. No, it's clearly audible. Vinay, maybe your system is at mute. Okay. So it's clearly 9 hours since morning. Or at least 8 hours. Sorry, my bad. It's 8 hours since morning completed. 8 hours since morning completed. Okay. And we are done with the 5th century of likes. 527 something. Okay. Now, I want to continue more, but with that continuing more, I also need to come back tomorrow with the same energy. I want to know how many of you with the same energy are ready for tomorrow 10 a.m. because I know day 1, day 2, there is a difference between these students. But I'm again telling you, if you have to secure best in maths, you have to give me 2 days. 1 day will not be very sufficient. You have to give me 2 days. How many of you are ready? Okay, for the day 2. And if yes, go to the link and put your attendance right now. That will tell me how much are you ready for tomorrow. Go to the link, put your attendance. You know what is attendance. Like kar do abhi se. Okay, let us energize ourselves. Let me energize myself. You can energize yourself. The link is there. Okay, go and put your attendance. Okay. Attendance is nothing but a simple like button and do it up and let's see how many of you are extremely ready for tomorrow from now on. Okay, yet you comment that your attendance is put. And agar attendance put kiya, attendance tabhi put karna aa rahe ho. If you feel dicey, don't put. Okay, if you feel dicey, don't put. Okay. So let me see the attendance. I will check within 5 minutes. Okay. Pata chala aaj se hi pata chal gaya attendance nahi hai, so we can cancel tomorrow then. Okay, if there is no attendance going to come tomorrow, then let's cancel the tomorrow's event. Chalo, so part 2 going to come up tomorrow at 10 a.m. Okay, tomorrow at 10 a.m. And also guys, for all ECEE students, after the maths marathon, maths is common for all. Maths of course is common for all. Okay, but then, okay, do boost up your practice in the technical subjects, the T20 series. To boost up your practice in the technical subjects, 20 important questions, okay, from different subjects, one by one, starting live on the same channel, okay, from 23rd of January. Starting live on the same channel from 23rd of January. Okay? Okay. Let's continue. Okay, now a topic which many of you were already asking, differential equations. Okay, differential. Let us cover some concepts from differential equations. Jitna bhi kar sakte hain aaj karenge. Okay, let us cover the concepts from differential equation. So here it is. Okay, let me first start with the fundamental but very important. Yes guys, my Telegram link is also there in the chat box, so you can open the Telegram because the PDF for today, tomorrow, both dono PDF I will share in the Telegram only. Today's PDF password already disclosed. Okay, now let's come up here. The first simplest category but very expected. Lots of questions you get from variable separable only. Okay, the solution of the initial value problem, dy by dx is minus 2xy. Now when I talk about variable separable, okay, basically in the variable separable, you get the equation of the form first order. देखो पहले फर्स्ट ऑर्डर से स्टार्ट कर रहे हैं, नहीं पासवर्ड तो लगेगा. ओके, dy by dx, okay, may be a function of x and y like you see here. dy by dx may be a function of, okay, Okay, function of x and y. Okay, and that can be further maybe splitted into f1x, f2y. Okay, that is what is the case we are talking about when variables can be separated. And if they can be separated, separate them with respect to the individual differentials. Okay, that means the function of y will be taken with f2y. So f2y upon dy upon f2y, the function of x will be taken with dx, will be f1x dx. After splitting, the next step would be integrating on both the sides. Okay, that's a simple integral on both the sides. Simple integrals on both the sides. Okay, the solution of the initial value problem, dy by dx is minus 2xy. Okay, minus 2xy with the initial problem. Why I call it as initial value problem? Because some boundary value, that is initial value, is given to you, that at x equal to 0, y will be 2. Okay, chalo, so now let's solve it. Okay, okay, let's solve it. Let's solve it. Okay, so I have a very simple problem here. Dy by dx is known as minus 2xy. So we can separate it. Now x and y are splitted. So bring the y on the left side and shift the dx on the right side. So dy upon y is minus 2x dx. Very simple now. Integration process only. 1 upon y integral log y is equal to minus 2x integral. Okay, so that is x square, but it is an indefinite integral, to add the constant of integral. So ln y is minus of x square plus c. So let me continue from here. So you have ln y is minus of x square plus c. But then you are given the initial value y of 0 equal to 2. That means what? When x takes the value 0, y will take the value 2. Log of 2 is minus 0 plus c. That means the value of c is log 2. Okay, so what is log y? Minus x square plus log 2. Minus x square plus log 2. Okay, so we can now rearrange it, bring the log 2 on the left side. So log y minus log 2 is minus of x square. Okay, log a minus log b is log of a by b. So log of y by 2 is minus x square. Minus x square. And then to eliminate log, we will take the exponent. So what is y by 2? What is y by 2 is exponent of minus x square. And shift the 2 on the right side to 2 e power minus x square. 2 e power minus x square. 2 e power minus x square. Answer is B. So no worries, no worries. Okay, for today, bonus. One more time I will tell you the password. One more time. Abhi nahi bata raha, I will tell you at random in between. One more time today I will tell you the password. Okay, happy all? Happy? Happy, happy, happy. I'll tell you. One more time I will tell you. Wait for some time. Okay, so it is 2 e power minus x square is the correct answer. 2 e power minus x square is known as the correct answer. Simple? Okay. So that is what variable separable case is. When dy by dx is given to be f of x comma y, that can be splitted into two different functions. So it becomes a simple problem. Separate dy a function of y, dx a function of x, and then start integrating. Very easy but very expected. Okay. इसलिए इससे start किया है. Next is what? Next is what is the general solution of the differential equation? Dy by dx equal to 1 plus cos 2y upon 1 minus cos 2x. Okay. 1 plus cos 2y upon 1 minus cos 2x. Okay. Now see, when there is no initially a boundary value given, the answer will be in terms of some constant, of course. The value of c will be there. To calculate c, we will be given some condition. If not given, expressions will be in terms of c. Okay, now, first of all, basic trigonometry. 1 plus cos 2y, 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. So 2 sin square x, 2 se 2 cancel. So I have cos square y divided by the sin square x. Okay, separate. Y function separate, x function separate. So separate them with their respective integral. Okay, dy upon cos square y. Right side dx upon sin square x. Acha, 1 upon cos square y can further be written as sec square y. Okay, so integral sec square y dy is equal to, this is cosec square x. 1 upon sin theta is cosec theta. So cosec square x dx. Integral cosec square x dx. Integral sec square y dy is equal to integral cosec square x dx. So what is the integral sec square theta? The differentiation of tan theta sec theta. So when you integrate, the answer will be tan y is equal to minus cosec. Now differentiation of cot theta is minus cosec square theta. So integral of cosec square theta is minus cot theta. Yahan pe x hai, and then plus the constant. So what is the correct option? Bring it on the left side. Tan y plus cot x. Directly option mark karenge. Tan y plus cot x is constant. Answer is C. Option number C. Correct, Lokesh, Akshay, Titi Saha. Correct answer is option number C. Tan y plus cot x is equal to C. Tan y plus cot x is equal to the C. Okay, done eh? A simple one. Next. An ordinary differential equation is given to you. Okay, dy by dx. Okay, dy by dx into x log x is y. What is the solution for above equation? What is the solution for the given equation? Okay. What are the solution for the given equation? 8 hour sessions. Okay. Yeah. For XZ sufficient. Okay, whole 8 hours attend किया अभी भी और continue कीजिए. This is also there in the XZ differential equation and all. ठीक है. तो dy by dx x log x equal to y. चलो, let us complete this quickly. Okay, dy by dx into x log x is equal to y. Okay, so can I separate this? Definitely y वाला term left लेके आएंगे. dy y variable to be separated is equal to dx and x log x completely on the right side, dx upon x log x. Integral dy then करेंगे upon is equal to integral dx upon x log x. Integral dy तो simple है. Okay, 1 upon y is log y. Okay, 1 upon y is log y. What about 1 upon x log x integral? Now to integrate one up, sometimes some integration technique like substitution may be involved. So here what you can do it on the right side. Okay, log x को रख देंगे t. Log x t, because what I have log x is there, so differentiate log x, 1 upon x will automatically come. So when you differentiate the log x, 1 upon x dx, that will be dt. So 1 upon x dx will be dt. Okay, will be dt. Okay, so then I can write down the integral as, integral dy upon y, and right side you have integral dx upon x is dt, log x is t, so integral dt by t simply. Okay, now integrate both sides. 1 upon y integral is ln y. 1 upon t integral is ln t. Acha, when both of them are in terms of t, na? So add the constant also. Both of the terms are in log. So add the constant also as log c. Add the constant also as log c. Okay. Now, what is going to be y? ln y log a plus log b. Log a into b. So log ct. Log cancelled. Y is equal to ct. Now what is t? Answer is obtained. Just put the value of t. T is equal to log x. Okay, so y is equal to c log x. That's it. That's solved. Y is equal to c log x. Okay, yeah, k log x. Whatever the name of constant, na, c, k, whatever it is. Okay. Okay. So x log x. X log x. ठीक है, done है. Next question. A simple one B. Okay, now next, there can be some equations which are reducible to variable separable. Some equations which are reducible to variable separable. They are not directly variable separable. For example, पहले example बताते हैं. For example बताते हैं. ठीक है, Vineet, I will see if time permits. Maxima, minima finished, Rajesh. It is completed already. Which of the following is the general solution of this differential equation? dy by dx is equal to x plus y minus 1. Now see, x plus y minus 1. See, what is type of equation that is available here is, you have dy by dx, and that is a particular function of ax plus by plus c. That is a particular function of ax plus by plus c. Particular function of ax plus by plus c. Clear? That is a particular function. It is a square. Maybe it is a square function or log function or something like that, but it is a function of ax plus by plus c. Okay, look into this. Whenever you have a differential equation of the form dy by dx as some function of ax plus by plus c, for example, anything like the example I took, dy plus dx is equal to 2x plus y plus 3, anything, any coefficients, whole cube. Function may be cube, function may be square, like the next example जो मैं देने वाला हूँ. Or it could be any function. Maybe dy by dx is equal to maybe sine of x plus y minus 1. Okay, all these cases, when you have a function of ax plus by plus c, abc can be any numbers. Okay, can be any numbers. Okay, then this can be solved by variable separable. It is not directly variable separable. Okay, you cannot separate variables here directly, but there is a trick. The trick is, Okay, substitute this ax plus by plus c equal to t and then solve. And don't remember every formula. Just remember ax plus by plus c equal to t. Leke aage solve karna hai. That's it. Just remember the substitution. Okay, so what I'm going to do here is, guys, in this question, what we are going to do here is put whatever is ax plus by plus c, that is x plus y minus 1. Put this equal to t. What? Put this equal to the t. Everybody. Put this equal to the t. Now, if this is equal to t, now differentiate both the sides with x. Okay. Ultimately, differentiate with x. X ka derivative 1. Derivative of y dy by dx. 1 is a constant. Then that is equal to dt by dx. So, you have the replacement for dy by dx also. That is equal to dt by dx minus 1. Now, place this. Okay. Place this in the differential equation. Okay, left side dy by dx. dy by dx is now dt by dx minus 1 equal to right side x plus y minus 1 is t. Okay, so it is t square. Now solved. dt by dx minus 1 is t square. Clear? Yeah, PDF will be sent in the telegram. Don't worry. Don't worry. So you have dt by dx minus 1 is equal to t square. That's what you had. T square tha? Correct. Okay, so what is the value of dt by dx? The dt by dx will be 1 plus t square. Separate the variable. I have dt upon 1 plus t square is equal to the dx. dt upon 1 plus t square is equal to the dx. Integrate both the sides. Integrate both the sides. Okay, and what do you get integrating both the sides? What do you get integrating both the sides? So dt upon 1 plus t square is equal to integral dx. Ab kya milega aage? Okay, so again 1 upon 1 plus t square, it is the integral of tan inverse t. This is tan inverse t. Is integral dx. Integral dx is x, so x plus c, that's it. Integral dx is x, so that is x plus c. Okay, x plus c. Okay, so now what is the value of t? Tan ko hata denge. Right side mein that becomes tan of x plus c. And what is the t? T came in the place of x plus y minus 1. Okay, you have x plus y minus 1 equal to tan of x plus c. Okay, and hence what is y? Bringing the other terms. Okay, you have tan of x plus c. Okay, then minus of x plus 1. Tan of x plus c minus of x plus 1. Okay, tan of x plus c minus of x plus 1. The answer will be D here. Correct answer is D. Substitution, dekho. For example, whatever is this ax plus by plus c, whatever it is, you have to substitute this as t. Okay, whatever is ax plus by plus c. For example, chalo ek aur example batate hain. Okay, suppose there is a question of the form. Okay, dy by dx is equal to, say for example, okay, say for example, sine of 2x plus y minus 3. 2x plus y minus 3, whatever it is. Suppose I need to solve this. Suppose I need to solve this. So, देखो क्या होगा? Here, it is again a function of the form. What is dy by dx? It is a function of what term? Sine is a function. Function of what? Ax plus by plus c. ABC can be any numbers, guys. Okay, ABC can be any number. So, now what you can put is, okay, whatever is ax plus by plus c, 2x plus y minus 1 minus 3 is t. ठीक है? So now differentiate. So 2x का derivative 2 plus dy by dx is equal to dt by dx. Okay. Now you will start putting. What is dy by dx? dt by dx minus 2, and that is equal to sine t. That is equal to sine t. And then solve further. Some integration techniques will be required. Solve further. Okay. You can solve further. Okay. Solve by some integration methods. Okay. This is what, up to this I have held you. Okay, up to this it can be clearly explained. Okay. Okay ji, chalo, next question then. Okay ji, next question. So, let's move ahead to the next category. Now, within the first order, next category is homogeneous, which is again convertible. Dear, this will also be convertible. Okay, this will also be convertible. Okay, to variable separable. So what is homogeneous differential equation? What is homogeneous differential equation? A differential equation of the form dy by dx equal to n upon d. N by d means numerator and denominator. Okay, numerator and denominator, where numerator and denominator are both homogeneous functions of x and y. Okay, of the same degree. Then the differential equation is homogeneous. For example, देखो homogeneous functions भी यहाँ पे थोड़ा सा revise हो जाएगा. Okay, I have already given you one homework regarding homogeneous functions ना. So देखो, Say for example, let me take an example first, then the method is available for you. Okay, say for example, I tell you dy by dx is equal to, suppose, x cube plus xy square, okay, upon x square minus y square. Now listen to me very carefully. Listen to me very carefully. Okay. Whenever in a function, okay, हाँ मैकेनिकल सारी ब्रांच के लिए पूरा कवर हो रहा है यार, एवरी टाइम सारी ब्रांच के लिए देखो, whenever a particular function has the terms such that the combined power of x and y is constant, then such a function is homogeneous. Such a function is homogeneous. Look into the numerator. Look into the numerator. Okay, when you combine, okay, this is power 3, and when you combine this, this is also 1 plus 2 power 3. Every term is of same degree. Every individual term is of same degree. Okay, so I can say that numerator is homogeneous. Okay, and what is the degree? Okay, that total degree, that is known as 3. Okay, now look into denominator. In the denominator, okay, this was y square, I missed it. Okay, in the denominator, okay, let me call it as dxy function. Every term is a term of equal degree. This is 2, this is 2. This is 2, this is 2. Okay, this is 2, this is 2. Okay, so dxy is also individually homogeneous. Okay, with what degree? With the degree equal to 2. With what degree? With the degree equal to 2. So in a particular function, polynomial expression, if every term has the total power equal, has the total power which is equal, then that is a homogeneous function. That is a homogeneous function. अब देखेंगे, what is a homogeneous differential equation? The differential equation is homogeneous if both the numerator and denominator are homogeneous, but that too of the same degree. That too of the same degree. So individually these two functions are homogeneous, but is the differential equation homogeneous? Is the differential equation homogeneous? No, it is non-homogeneous. It is non-homogeneous because you had unequal degree coming up. Clear, everybody? This was non-homogeneous because numerator, denominator, they are homogeneous, but they are not the same degree homogeneous. Clear? Achha, now let me write down another example here. Let me write down another example here. Suppose I tell you that dy by dx is equal to x power 4 plus x square y square, something like that, is divided by x cube y plus xy cube, something like that. ठीक है, नहीं ऐसा नहीं रखते हैं, ये तो गड़बड़ करेगा. Let it be like that. X power 4 plus y power 4 upon x cube y plus xy cube. Tell me, is it homogeneous or not? Is it homogeneous or not? Okay, देखो, first of all, numerator, both the terms are of equal degree. Degree 4, degree 4, degree 4, degree 4. So this is homogeneous. Correct? Okay, with the degree 4. Okay, with the degree 4. Okay, what about the denominator? What about denominator? 3 plus 1 is 4, 1 plus 3 is 4. Both the terms are equal degree. Both the terms are of same degree. So denominator is also homogeneous. Correct? पहले तो individually देखना है. So this is also homogeneous. And what is that combined degree? 3 plus 1, 4. Okay. Now because both numerator homogeneous are homogeneous, that too of the same degree, then the differential equation is homogeneous. Then the differential equation is homogeneous. Then the differential equation is homogeneous. ठीक है? That is what I mean by homogeneous differential equation, which will be again convertible to variable separable case by just one substitution. Based on the equation, you can decide either you can put y equal to vx, okay, that means y by x equal to v, or you know, if y by x equal to v, y equal to vx. So if y is vx, no need to mug up this formula. You can write down what is dy by dx, or x by y v equal to v. Okay, there are two cases. Y by x equal to v, वो question देख के समझ में आएगा किस टाइप के टर्म से, और x by y equal to v. Okay, now let's apply it. Although homogeneous not important, what is important is variable separable, but just basic थोड़ा सा पता होना चाहिए. So have a look into this. Solve the differential equation. dy by dx equal to y square upon xy minus x square. Y square upon xy minus x square. Is it a homogeneous differential equation? Is it a homogeneous differential equation? Tell me. Is it a homogeneous differential equation? चलो, to solve the differential equation, dy by dx equal to y square upon xy minus x square. Look into this, homogeneous. Numerator has only one term, and that is, of course, one term hai to homogeneous हुआ ही degree 2. Denominator has two term. Okay, the degree of first term is 2, degree of second term is also 2. Okay, so denominator also individually homogeneous. कितना degree के साथ? Second degree के साथ. Second degree के साथ. ठीक है, second degree के साथ. So what I can do is, okay, now I will start the method. Both are homogeneous of the equal degree. So the differential equation is homogeneous. So put y equal to vx. And if y equal to vx, dy by dx, you can write immediately it is the product of two functions. V constant, differentiation of x will be 1. X constant, differentiation of v will be dv by dx. Okay, so put down the results here. Okay, you put down the results here. Dy by dx will be known as v plus x dv by dx. And that should be equal to y square, that is v square x square upon x into y. Y is vx minus x square. Okay, so now x square is going to come common. First simplify कर देंगे. X square cancel ही हो गया basically. This will also be x square. This is also x square. The v square upon v minus 1. Okay, v plus x dv by dx. Okay, so what is going to be? What is going to be x dv by dx? That is v square upon v minus 1 minus v. Solving it, v square minus v square cancelled, minus minus plus v. So v upon v minus 1. That's what I'm getting. Am I correct? Yes. Let me rewrite this. So I have x dv by dx. I have x dv by dx will be equal to how much? Will be v upon v minus 1. V upon v minus 1. Separating the variables, guys. V minus 1 by v on the left side with the dv. dx upon x on the right side. Okay. इसको थोड़ा सा split भी कर ले, divide करें तो v by v cancel. V 1 minus 1 by v dv. Okay, 1 minus 1 by v dv is equal to dx by x, and integrate on both the sides. Now, when you integrate on both the sides, integral of 1 is v. Okay, 1 upon v integral ln v. 1 upon x integral ln x. Okay, so now v is equal to log v plus log x. Log a plus log b is log ab. So log vx, and y is already vx. So what is v? Y by x, and that is equal to log vx, that is log y. Y is equal to, so how the solution is turning out to be? Y is equal to x log y. Now see how you have to rearrange that depends how the options are given. How you have to rearrange that depends how the options are given. Okay. ठीक है. किसके लिए बात कर रहे हैं? You are maybe talking about degree and order of differential equation. देखो sometimes ना basic 1 mark question वहां से भी आ जाता है. चलो. If I ask you a simple question, चलो ठीक है. Let me switch the gear for a moment. चलो एक और चीज यहाँ पे बता देते हैं. Let me switch the gear for a moment. Okay. And let me ask you. Suppose there is a question. Okay. ये एक अलग ही concept है. देखो. What is the degree and order of the complete differential equation? Suppose that is dqy by dx cube plus 2 d2y by dx square का whole square, okay, plus 5 dy by dx plus y is equal to suppose some function of x. ठीक है. What is the order and degree of this differential equation? Can you tell me? What is the order and degree of this differential equation? What is the order and degree of this differential equation? Now, order means the order of the highest derivative term. Order is the order of highest derivative term. So, what is the highest derivative term is 3. Okay, and according to it, order will be equal to 3. Okay, now tell me the degree. Now tell me the degree. Order the 3. Order is the order of highest derivative term. Okay, so chalo, most of you have got it correct. The degree is 1. Okay, sometimes students take it from here. Degree means highest power. So is the degree equal to 2? Some of you still say 2 also. Is the degree 2? No. Degree is not equal to 2. Degree is the power of the highest derivative term only. Jahan se order nikala. Okay, it represents the power of highest derivative term. Okay, highest derivative term. ठीक है, हाईएस्ट डेरिवेटिव टर्म। अच्छा अब देखो एक और क्वेश्चन देता हूँ, ये तो सिंपल है। लेट मी गिव वन मोर क्वेश्चन, लेट मी गिव द वन मोर क्वेश्चन। देखो if I tell you dy by dx, suppose if I tell you that dy by dx is given by yeah sorry ये तो फर्स्ट ऑर्डर ही बन जाएगा। लेट मी गिव यू एनी रैंडम ऑर्डर। ओके सपोज आई हैव dqy by dx square okay plus 2y okay is equal to sin of x. Tell me the order and degree here. Tell me the order and degree here. Yeah, chalo. Let me change it even more slightly. थोड़ा सा और change कर देता हूँ मैं. Suppose you are given the equation of the form d2y by dx square whole square is equal to dy by dx plus 5 under root dy by dx plus 5. Now tell me the degree and order. Now tell me the degree and order. चलो थोड़ा सा और clarity लाने के लिए. Now tell me the degree and order, everybody. So order is the order of the highest derivative term. Order is basically the order of the highest derivative term. Okay, so what is the highest derivative term? Highest derivative term 2, it is the second order term. It is the second derivative d2y by dx square. Now what is the power over it? I told you, na, it is the degree and it is the power of the highest derivative term. So is the answer 2. So the power is clearly seen 2. Okay, no. No. The correct answer for degree is 4. The correct answer for degree is 4. While deciding the degree, there should not be any radical term, okay, at least on the derivatives. At least on the derivative. Okay, so you have to square it up. d2y by dx square, when I square it becomes power 4, that is dy by dx. That is dy by dx plus 5. Okay, now look, the degree is 4. Okay. Radicals. Radical means square root, cube root, not allowed with the derivatives, with any derivative. So whenever you are talking about degree, na, it is the power of highest derivative term. Okay. And all the derivatives, whether it is first, second or highest, all derivatives, okay, must be free from radicals. Under root, square root में नहीं होने चाहिए, और fractions. It will not be in the fractional form also. Like divide by something वाला form नहीं होना चाहिए. Free from radicals or fraction. Okay. Free from radicals or fraction. ठीक है. चलो. Okay, so this is some basics that you must know. Okay. Although these days they don't really ask the degree and power. Very fundamental concept. But चलो. Somehow the topic got started and I told you. Okay. इस पे ज़्यादा research नहीं करना है. And now let me tell you one more thing based on this degree and order only ना. Let me jump to the more important case. Okay, exact equation I will cover later, but let me start with the linear differential equation. Okay. In the first order, there is also exact differential equation. वो आगे देखेंगे. ठीक है, have a look into it. Linear differential equation. The differential equation is said to be linear. Now, when is the equation linear? First, learn that if the dependent variable and all the derivatives, if the dependent variable and its derivative means all the derivatives appear in the first degree and not multiplied together. Appear in the first degree and not multiplied together. Let me write down some examples. Okay. All the derivatives must appear in the first degree. Examples के साथ समझते. Okay. So suppose I give you a equation d2y by dx square. Okay. Plus 5 dy by dx. Okay. Plus 2y is equal to suppose x square, something like that. So what is the dependent variable? Please tell me. Okay. What is a dependent variable? Please tell me. dy by dx. Y is differentiated with x. Means y depends on x. Means y depends on x. So dependent variable is y. Look into the power of y. Look into the power of dy by dx and look into the power of d2y by dx square. All of them appear in the first degree, right? All of them appear in the first degree. Okay. So it is linear. This is a linear differential equation. Of what order? Of second order. This is a linear differential equation of second order. Linear differential equation of second order. Acha. Next example. It could be any order. Tell me, comment on this, linear or not, and also tell me the order. Come on. Dependent variable y and all the derivatives are in the first degree. And all the derivatives are in the first degree. Tell me. Dependent variable and y, all the derivatives are clearly in the first degree. Kahin koi problem hi nahi hai. Right? All of them are in the first degree. So what to do? All of them are in the first degree. So what to do? Yes. Okay. This term is multiplied. All of them should be in the first degree and not multiplied together. Not multiplied together. So this particular term makes it non-linear. This term makes it non-linear. Clear, everybody? This is what is non-linear. This is what is non-linear. Order you can still say. Order to iska 3 hoga. It is third order, but it is non-linear. Ye linear nahi hai. It is non-linear. Acha ji. d2y by dx square plus 5 d2y by dx की power 3 plus 4y is equal to 2x. Tell me quickly, dear, quickly. Dependent variable and all the derivatives appear in the first degree. Okay, so here there is one of the derivative which is not in the first degree. That makes the answer as non-linear. This is clearly non-linear. Simple, na? Ye to non-linear ho gaya. If any of the derivative ya y is in the degree more than 1, it is non-linear. So you don't have to check the degree of this x square or whatever. This is not responsible for linearity and non-linearity. For linearity, you have to check dependent variable and the derivatives not multiplied together and all of them in the first degree. Okay, acha. Next example. Now I give you x square d2y by dx square plus 5x dy by dx. Okay, plus 2y is equal to ln x. X का कोई भी function हो सकता है. Now tell me. Now tell me the answer. X square d2y by dx square plus 5x dy by dx plus 2y is equal to ln x. Plus 2y is equal to the ln x. Clear? Tell me, linear or not? Now देखो, dy by dx multiplied by x, d2y by dx square multiplied by x square. Any problem? Dependent variable and the derivative should not be multiplied together. Baba, if they are multiplied with x, no problem to you, no threat to you. Okay, dependent variable को देख लीजिए, y, and all the derivatives are in first power, so that is not at all a problem to you. Okay, so it is linear only if they are multiplied by x. If this is linear only, and this is a very special differential equation, we will study this. Yes, Nikhil, correct. Okay, differential equation like when the first derivative multiplied by x, second derivative multiplied by x square, third derivative multiplied by x cube. Okay, when such a pattern is followed, such a differential equation comes under, actually comes under Euler-Cauchy differential equation. Cover करेंगे उसको. Okay, that will come under the Euler-Cauchy differential equation basically. That will come under the case of Euler-Cauchy differential equation, right? That will come under the case of Euler-Cauchy differential equation. Euler-Cauchy differential equation, right? Chalo. Okay. Acha. Now this particular case, the first example was linear of second order, and look into all the coefficients. Okay. Second order. Okay, and look into all the coefficients. What are all the coefficients here? It is in the second order, but all the coefficients are constant. Okay, all the coefficients are constant here. Such differential equation we are going to see very, very most important here actually. most important in this chapter, that is known as LCCDE. That is known as LCCDE. Okay, linear constant coefficient differential equation. Linear constant coefficient differential equation. Yaad rakhna. That is known as linear constant coefficient differential equations. Okay, the linear constant coefficient differential equation. The linear constant coefficient differential equation, right? Chalo, if that is right, let's move ahead. Okay, so let's move ahead. Okay, and let's first talk about the linear differential equation of first order. Linear differential equation of first order. Okay, exact differential equations last mein dekhenge, but first let me cover the linear differential equations of the first order. Okay, so the differential equation of the form dy by dx, the dy by dx plus py equal to q. Okay, plus py equal to q. देखो, only dy by dx means first order की बात कर रहा हूं मैं. For some time first order, then we will start second order or higher order also. Okay, dy by dx plus py equal to q. So only first derivative. Acha, y and both the derivatives, y and its derivative, both the terms are in first degree and they are not multiplied together. They are not multiplied together means it is linear. Means it is linear. What is p? It is a function of x. Y can be multiplied by any function of x. Y and dy by dx should not be multiplied together. So this can be any function of x, this can be any function of x. To solve it, just know the procedure. Solve it, first evaluate the integrating factor. Okay, what is the integrating factor? Sometimes question will only be on integrating factor, wo bhi dekh lena. But firstly evaluate the integrating factor. That is given by e raised to the power integral p dx. That is given by the formula e raised to the power integral p dx. Okay, e raised to the power integral p dx. Okay, then the solution of this differential equation is given by what? The solution is given by y into integrating factor. Y into integrating factor is equal to integral q into if dx plus c. That is given by integral q into if dx plus c. Integral q into if dx plus c is integral q if dx plus c. Okay, let's apply this to a problem. Let's understand. Okay, so solution of y x power 4 y dash means dy by dx. Okay, means this is of the form x power 4 dy by dx plus 4x cube y is equal to x power 8. But I think I should start with dy by dx. Let us start with the dy by dx form. Okay, so divide by x power 4. Let us start writing by dy by dx. So divide by x power 4. तो यहाँ पे बचेगा 4 by x. And right side x power 8 by x power 4. X power 4 will be left. So dy by dx plus 4 by x into y is equal to x power 4. What is this 4 by x? That is known as the p function. This is known as the q function. Dy by dx plus py equal to q. First order linear differential equation. Simple method of solving it is available. What is the simple method of solving it, dear? What is the simple method of solving it? The simple method is first calculate the IF. Okay, IF is given by e raised to the power integral p dx. E raised to the power integral p dx, that is e raised to the power 4 by x dx. Okay, e raised to the power 4 by x dx. Now, what is 1 upon x integral? 4 to constant hai. 1 upon x integral is ln x. So e power 4 ln x. Okay, e raised to the power. Now, 4. Number outside the log, take inside, it will become power. Why I take inside? So that e and log will come together and they are inverse and they cancel each other. Okay, so e power ln x power 4. So answer is x ki power 4. Answer is x ki power 4. So that is only the integrating factor. Sometimes question will only be integrating factor. Ye bhi ready rehna. Okay, but now the question is complete solution. Okay, so when I want to talk about the solution. See what is going to be the solution. What is going to be the solution? Dekh lete hain. So by solution I mean y into if. Formula I told you. Y into if is equal to integral q into if dx is equal to integral q into if dx plus c. Okay, so y into the integrating factor, put down the value, is equal to integral q. So what is the value of q? Q function is x ki power 4. Okay, so is equal to integral x ki power 4. If is also x ki power 4 into dx plus c. Okay, so I have x power 4y is equal to x power 8 ho gaya basically, and integral x power 8 is x power 9 by 9 plus c. Okay, so what is the answer for y? Y divide by x power 4. So dividing by x power 4, x power 5 bacha by 9 plus c divided by x power 4. Go and match your options. Y is equal to x power 5 by 9 plus c upon x ki power 4. X power 5 by 9 plus c upon x ki power 4. Correct answer is A. Correct answer is what is known as the A. Okay. X ki power 9 plus C x ki power 4. That is the value of y. X power 5 divided by 9 plus C upon x ki power 4. Plus C upon x ki power 4. Clear everybody? Done. Next question. Okay, simple one. Okay, let's go for the next question then. Then there will be some cases convertible to it. Uspe bhi aayenge. Okay, if y of x satisfies the differential equation, y of x satisfies the differential equation sin x dy by dx plus y cos x equal to 1, subject to the condition y pi by 2 equal to pi by 2, then what is the value of y pi by 6? Then what is the value of y pi by 6? If yx satisfies the differential equation sin x dy by dx plus y cos x equal to 1, subject to the condition y pi by 2 equal to pi by 2, initial value is given, then what is y pi by 6? Okay, y pi by 6 converted to a numeric answer here. So देखो, again, first of all, take in terms of dy by dx. So what is the dy by dx? Okay, dividing by sin x, so you will have cos upon sin, that is known as cot x. Okay, so cot x into y is equal to 1 upon sin, this is going to be the cosec x. This is going to be the cosec x. Okay, that is going to be the cosec x. That is going to be the cosec x. Okay? Okay, now you have your function. Okay, this is known as the p function. This is known as the q function. Okay, you have the p and the q function done. Okay, so you have the p and the q function. Okay, done. P and q function done. Okay, so dy by dx plus py equal to the q. So first of all, integrating factor given by the formula e power integral p dx e raised to the power, what is the p? Cot x. What is the p? Cot x. Okay, cos upon sin x. Okay, what is the integral of cot x? What is the integral of cot x? E raised to the power ln sin x. E raised to the power ln sin x. Cos by sin, just a second. Okay, I have cos upon sin, I put sin equal to t, cos x dx is dt, dt upon t, integral is log t, correct. It is log mod of sin x. We apply mod for just safety point of view, so that inside the log always positive number is there. Okay, so the integrating factor will be equal to modulus of sin x, basically, correct? Now, what is the solution? Okay, what is the proper solution then? Okay, y into if. Okay, integrating factor, let's assume sin x positive here. The values are also, we'll see what are the values given, is equal to integral q. Now, what is the q function? Dekho, q is cosec. Okay, so that's good. If q is cosec, integral q into if is sin x and they are inverse of each other. Okay, so cosec and sin cancelled. Cosec and sin cancelled each other, and integral dx bacha. Integral dx is simply x, then the constant of integration is already there. Now you are given y pi by 2 equal to pi by 2. That is for the boundary. That is for the to calculate the constant value. Y pi by 2 equal to pi by 2. I'm just going to put down this value. Y pi by 2 equal to pi by 2 means when x equal to pi by 2, y will also be pi by 2. Okay, y will also be pi by 2. So pi by 2. Okay, sine of pi by 2 is equal to x is again pi by 2 plus c. But sine pi by 2 1. So pi by 2 cancelled. C ka value 0 aa gaya. Okay, and if c is equal to 0, so you have your answer as y sin x equal to x. Y sin x equal to x. That is the solution if they are solution. But they are asking what is y pi by 6. Okay, y pi by 6. Okay, so now I put x equal to pi by 6. Okay, so y into sin pi by 6 equal to pi by 6. Okay, y sin pi by 6 30 degree. Sin 30 degree is half. Okay, this is pi by 6. 2 एक बार cancel करेंगे तो y should be pi by 3. What is the value of y? It is pi by 3. What is the value of pi? Correct answer is C, option number C, pi by 3. Okay, pi by 3. The correct answer is pi by 3. Okay, everybody. Hope it is clear to all of you. The correct answer is in front of us. Done. Cool. Pi by 3. Correct answer. See, many of you are coming with that. So now be ready for the next question then. Now, linear differential equation of first order, very simple to solve. Y into if is integral q if dx plus c. First calculate if, that is e power integral p dx. But within that also, there can be some equations, okay, which are reducible to linear differential equation of first order, okay, and that is of the form f dash y dy by dx plus fy into p equal to q. Okay, p and q are same functions of x and y. Okay, so with the function of x, you don't have y. Earlier we had py, na? Earlier we had py. Bernoulli bhi aayega iske baad. This is even more general case. Okay, rather than py, you don't have y, you have a function of y. Okay, you have a function of y. Okay, you have a function of y. Okay, now, okay, the derivative of the same function is available here. The derivative of the same function is available here. F dash y is available here. The derivative of the same function is available here. So we have f dash y dy by dx plus fy into p equal to the q. Okay, equal to the q. Clear everybody? Okay, okay. Chalo. If that is the case, okay, what you will do is, there is one substitution. Put fy equal to u. Just itna yaad rakhna hai. What will happen? Okay, what will happen? Okay, if you put fy equal to u, na, okay, what is going to be the derivative? See, f dash y dy by dx. Everything is going on differentiation with x. So f dash y dy by dx, right side mein du by dx. Okay, so now when you take this equation, what will happen? Dekho, f dash y dy by dx is now du by dx. Clear? This is now du by dx. Okay, plus fy into p. What is fy? That is u, and equal to q. Now, is it linear differential equation? Everybody please see. Is it going to be the linear differential equation? Yes, guys, great enthusiasm. Keep joining. All right. Du by dx plus pu equal to the q. We have the du by dx plus pu equal to the q. Du by dx plus pu equal to the q. Is it? Dekho, now it is a differential equation, but in terms of u. The dependent variable is u. The dependent variable u and its derivative in the first order, not in the first degree, not multiplied together, same. And p and q are any function of x. P and q same, any function of x. Okay, so this is a regular LDE first order. Okay, and now we know how to solve LDE for the first order. Let's apply to a question basically. Solve the differential equation. Tan y dy by dx plus tan x is equal to cos y cos square x is equal to the cos y cos square x. Tell me. Tan y dy by dx plus tan x is equal to cos y cos square x is equal to the cos y cos square x. Chalo, dekh lete hain. Tan y dy by dx plus tan x is cos y cos square x. Come on, let me know what to do. Come on, everybody, let me know what to do. Tan y dy by dx plus tan x is cos y cos square x. Is cos y cos square x. Dekh lete hain. So dekho, first of all, okay, right side mein, look into this arrangement. Right side I only left q. Q is a function of x only, na? Q is a function of x only. Okay, so right side mein you have to eliminate this first of all. Make only the function of x. So eliminate cos y, divide by cos y. So I have tan y divide by cos y dy by dx plus 1 upon cos y tan x is equal to the cos square x. Is equal to the cos square x. Divided by cos y किया है सबसे पहले, ठीक है. Now 1 upon cos is sec, तो थोड़ा बहुत rearrange करेंगे. I have sec y tan y dy by dx. Sec y tan y dy by dx. Okay, what is 1 upon cos? इसको भी लिख दिया sec y. Okay, into tan x is equal to cos square x. Now please see. What is this? Okay, this is what is known as p function. This is what is known as the q function. Okay, they are the function of x, p and q. Now, normally with p, you had the y term, p into y. But now you have a function of y. But the beauty of this is that whenever you have a function of y, the derivative is automatically available here with the dy by dx. Isn't it? देखो, अगर आपने इसको some function बोला, suppose u, sec y. Suppose u is sec y. So tell me what is the differentiation of sec theta? The differentiation of sec theta is sec theta into tan theta. The differentiation of sec theta is sec theta into tan theta. So this is automatically available here. This is du by dx if u is equal to sec y. If u is equal to the sec y. Clear everybody? Okay. So if I put down here u is equal to sec y. Okay. So its derivative du by dx, okay, will be automatically sec y tan y dy by dx. Okay. So this whole term, okay, this whole term sec y tan y dy by dx will be du by dx, including this, including this. Okay, so now my differential equation becomes, first term is only du by dx plus, what is the next term? Plus tan x into sec y, but sec y is equal to u. Okay, so plus tan x is multiplied by u is equal to how much? Is equal to cos square x. Okay, dy by dx plus py equal to the q. Rather than y, नाम में क्या रखा है? Rather than y, it is u. du by dx plus pu equal to the q. du by dx plus pu equal to the q. Clear everybody? du by dx plus pu equal to the q. Okay, तो देखते हैं what is the integrating factor. Integrating factor is e raised to the power integral p dx. E raised to the power integral p dx. Okay, that is e raised to the power integral tan x dx. Okay, e raised to the power p, that is tan x dx. Okay, what is the integral of tan x? It is ln sec x. It is known as the ln sec x. Okay, e and log cancel. Again, for security we apply the mod. Okay, but let me write down the answer as only sec x. That is the integrating factor. Okay, now what is the solution? What is the solution? Same procedure is now the same. Solution is given by y. No. Solution, if you write down y into if, no. It is not the equation of y. It is the equation of u. It is the equation of u. So, ये difference आपको याद रखना है. U into if is equal to integration q if dx. Wherever it is x remains to be same. Y की जगह बस u रख देना है. That is the solution you are supposed to take. U. Okay. So put down the u here. Okay. Now you will be having u. Okay. Into if. If is sec x. Is integration of q. What is the q function? देखना पड़ेगा एक बार. Q function is cos square x. Okay. Q function is cos square x multiplied by the if, which is sec x. They are inverse of each other. One of the term will get cancelled. Okay. 1 sec and 1 cos get cancelled. Okay. Y की जगह रख देंगे. वापस कितना था? Y was substituted for sec y. U was substituted for sec y. Okay. So now I have sec y multiplied by sec x. Is integral cos x. One of them cancelled. Integral cos x is sin x plus c. The answer is sec y sec x is equal to sin x plus c. In terms of sec y, in terms of y लिखना है तो sec x on the right side will become cos x. So that is cos x whole multiplied by the sin x plus c. Okay, sec y is cos x into sin x plus c. Okay. Clear? That should be the answer. Options थे यहाँ पे क्या? Or it is just a regular question? No, ठीक है. So whatever options are there, we can arrange accordingly. ठीक है. Maybe in this format or this format, whatever it is. Got it? Simple. Okay, but just a substitution. Yes, guys. Okay, so team is automatically already present, and yes, you can mark your presence for the tomorrow. Okay, by putting your attendance right now. For the tomorrow's session. What is the attendance for the tomorrow's session right now? Let me just see. How many of you show the enthusiasm? Okay, for tomorrow. Right now only. How many of you showing the attendance for tomorrow? Enthusiasm for tomorrow. Okay, just now. Let me get the data. I think it's running slow. Chalo, ठीक है. Let's move ahead. Okay, Jisk. Okay. So now next question. Okay, only 35 is the attendance. Only 35 attendance for tomorrow. Only 35 attendance for tomorrow. कैसे करेंगे? 35 में तो session कैसे करेंगे? Okay, have a look into it. Now, specific case of this. ये भी important है. Specific case inside this. Bernoulli's equation. The specific case inside this will be the Bernoulli's equation. Differential equation of the form dy by dx plus py equal to qy power n, where p and q are functions of x, will be a Bernoulli's equation. Okay, where p and q are functions of x will be known as a Bernoulli's equation. Where p and q are functions of x. ठीक है? When p and q are known as the functions of x, that will be known as the Bernoulli's equation. dy by dx plus py equal to qy power n. अब देखना. Okay. is equal to q y power n. देखना. Okay, what happens? The only procedure, please note down, it is similar, dy by dx plus py q y power n, but it is non-linear. It is non-linear. First of all, it is non-linear. Why it is non-linear? Because y power n है ना. Y can only take the power 1. Linearity means a dependent variable and all the derivatives in the power 1. So y power n, non-linear. Okay, but it is convertible to linear again. The procedure is divide by y power n. Okay, divide by y power n. So when you divide by y power n, क्या होने वाला है? Okay, you get left side first term y power minus n dy by dx plus p y power 1 minus n. Okay, y power n divide किया equal to q. Now previous case will be applied. Whatever is multiplied by p ना, whatever is multiplied by p उसको u बोल देंगे. Okay, let y raised to the power 1 minus n equal to u. So now differentiate again 1 minus n y raised to the power minus n dy by dx. Differentiation formula apply करके that is du by dx. So once again you see guys, y power minus n dy by dx, y power minus n dy by dx is substituted. आपको केवल इतना याद रखना है, divide by y power n. Rest automatically in the question, but just let me explain you. So this particular term is again substituted, and that will become 1 upon 1 minus n. Okay, du by dx. Okay, अगर यहीं से relate करना है तो okay, 1 upon 1 minus n du by dx. Okay, plus p into u is equal to q. Is equal to q. That means you can write down du by dx. 1 minus n तो just constant है ना. 1 minus n तो just constant है, multiply throughout. तो p1 minus n into u, okay, will be equal to q1 minus n. Will be equal to q1 minus n. Clear everybody? Now tell me what is this case? Is equal to q1 minus n. Now tell me what is this case equivalent to? Du by dx plus p 1 minus n is equal to q1 minus n. What is this case equivalent to? Okay, now this is linear. Dependent variable is now y, sorry, u. Dependent variable u है, वो यहाँ पे miss हो गया है. P into 1 minus n into u. U and derivative appear in first degree, not multiplied together, and p and q are any function of x and y. So it's a linear case. Okay, this has been converted to LDE first order again. This has been converted to LDE first order again. Okay, so now please take up the question and answer me. Please take up the question and answer me. Here it is. Solve the differential equation dy by dx minus 3y equal to minus 12y square. आपको कुछ formula याद नहीं रखना है. Just one procedure for Bernoulli. First of all, 12y power, right side y power n, it is Bernoulli. What you have to just do is divide by y square and then automatically solve. Automatically solve in the flow. Okay, automatically solve in the flow. Okay. So dear, yes, if you divide by y square, then what is going to happen? Let us go in the flow. If you divide by y square, चलो, so divide कर देते हैं. So I have 1 upon y square dy by dx minus 3 upon y is minus 12. Now there is a simple substitution. See, 1 upon y and 1 upon y square, they are the derivatives of each other in a sense. तो हम क्या करेंगे? Directly minus 1 by y ले लेंगे. Minus 1 by y if you put u. Okay, so derivative 1 by y is minus 1 by y square. So if you take minus 1 by y, you will have 1 upon y square dy by dx. 1 upon y square dy by dx. That will be du by dx. that will be known as du by dx. Okay, so this is already substituted. So your differential equation now becomes how much? 1 upon y dy by dx, that is du by dx minus 3 by y, but minus 1 by y is u, so plus 3u is minus 12. Simple. Okay, first of all, ये LDE है, तो e raised to the power integral 3 dx. The integrating factor is e raised to the power integral 3 dx. Okay, now what is e raised to the power integral 3 dx? That is 3x. Okay, 3 dx, it's going to be 3x. Integral dx is x. The integrating factor obtained. Now solution. What's going to be the solution here? What's going to be the solution here? Now to solve it, I have y into if is equal to integral q into if dx. Y की जगह बस आपको ध्यान रखना, you have to put u. Okay, integral q if dx plus c. Okay, so what is the u? Okay, अभी u ही रखते हैं. Integrating factor कितना आया है? That is e raised to the power 3x. That is e raised to the power 3x is integration q. What is the q function for us? Q function is simply minus 12. Minus 12 e raised to the power 3x dx plus c. Put down the value of u. U was equal to minus 1 upon y basically. So minus 1 upon y e power 3x. This is minus 12 e power 3x integral is e power 3x divided by 3 plus the constant of integration. Plus what? Plus the constant of integration. Okay, so e power 3x से divide कर दिया अगर तो minus 1 by x is minus 4 plus c e power minus 3x. So what is the value of y? Solving from here, y, taking the reciprocal, adjusting the minus on the other side, it will become reciprocal 1 upon 4 minus c e power minus 3x. Something of this format. 1 upon 4 minus c e power minus 3x. For value of c, some initial value may be given, may not be given. If it is not given, you can leave it in the form of c. 1 upon 4 minus c e power minus 3x. 1 upon 4 minus c e power minus 3x. Okay. This was the linear differential equations of the first order. Linear differential equations of the first order. Now let me also take up the exact differential equation. First order एक साथ में कर लेते हैं. But देखो, let me be very honest, this exact differential equation is not that important. Only thing is, again, there are some areas which are not important for question, but you must know somehow, you know, the application of exact equation you will find in vector calculus. Application of exact equation you see in a lot of technical areas also. In lot of technical areas also. Okay? So with that point of view, I am covering, but for question point of view, to be honest, it is not important. आता है कभी कभी question, आता है, I am not telling नहीं आता है. Okay, आता है, तो you must know if there is a case when the questions are not at all coming, so वो बिल्कुल नहीं cover करेंगे. तो maybe questions also coming up. But then this is useful in vector calculus, and it is there in very lot of technical areas also. Technical subjects में भी काफी काम आता है. Okay, so exact differential equation. What exactly exact differential equation is? देखो, what exactly the exact differential equation is? Understand by example. So suppose you have x dx plus y dy. Okay. Suppose you have some equation x dx plus y dy equal to 0. Okay, anything of this format. X dx plus y dy equal to 0. Okay. Now देखो, please see. Okay. Please see. X dx plus y dy equal to 0. Okay. X dx is the integration of what? It is the integration of x square. Actually x square by 2. Okay. X square integral is 2x dx. Chain rule say 2x dx divided by 2. Similarly, y with dy, that is the integral of, that is the differential of y square by 2. That means now I have d of x square. Differentiation is a linear operator, dear. Okay, you can take it common, so you have x square plus y square whole divided by 2. Differential of x square plus y square by 2 equal to 0. You started with two differential terms. One more example. Okay, suppose x with dy, y with dx equal to 0. Now it's a crisscross, x with dy, y with dx. X with dy, y with dx. ठीक है, अभी थोड़ा सा और करते, then we will decide what to do. Yeah, it's exactly more than 9 hours over now. Okay, you have x with dy, y with dx. Okay, now from where does this term comes? ये term कहाँ से आ रहा है? ये टर्म कहां से आ रहा है? This is x constant differentiation of y constant differentiation of x. This is nothing but the product rule. When you differentiate the product x y, same pattern will come, the x constant y derivative, next time y constant x derivative equal to 0. So here also you start by two different differentials, dx and dy. Okay, but convertible to a single differential term. Convertible to a single differential term, that is known as du. Okay, that is known as du. Okay, it is converted to the single differential term du equal to 0. This is also convertible to a single differential term u. Okay, whatever may be u, kuch na kuch u to aayega. Okay, so it is convertible to du equal to 0. Okay, when differential equation containing 2 or 3 या multiple differential terms, they combine and form a single differential terms of the form du, okay, then such a differential equation is exact differential equation. Such a differential equation is exact differential equation. Clear? Such a differential equation is known as exact differential equation. Acha, that means if I now write down an example here, x dy minus y dx equal to 0. That was plus. Now let me take x dy minus y dx equal to 0. Now tell me, is this exact? Only this is available. X dy minus y dx. Okay. Sometimes it is easy to guess. Okay. UV rule hai ya basic x square differentiation hai. Okay. Sometimes this also looks that, if it is minus, the minus comes when there is a denominator also. Okay. Denominator constant differentiation of numerator minus numerator constant differentiation of denominator, but where is the denominator? That is not given actually. Okay, so this is not the differentiation of the y by x also, या x by y also. This looks like non-exact. इसको मैं combine नहीं कर पा रहा हूँ. If I cannot combine, it is non-exact. If I cannot combine, if Ankit Kumar, for that I should have divide by x or y term. Okay, so if I am not able to combine, means it is non-exact. Now we cannot always trust our intuition key whether it is somehow convertible or not. We need a method, and the method is a differential equation is exact if del m by del y is del n by del x. See, what was the equation I told you? The equation was m dx plus n dy equal to 0. इस format में arrange किया है. M dx plus n dy equal to 0. Okay, the condition for exact is del m by del y equal to del n by del x. If this is true, it is 100% exact, otherwise not. M is the coefficient of dx, n is the coefficient with dy. ठीक है, अब देखना यहाँ पे. So if I come back to this problem, okay, what is del m by del x? Okay, that is del by del x of x. By this is m. Okay, then that is 1. Okay, what is del n by del y? Okay, that is del by del y of n, and n is also y. This is 1. So dear, I have del m by del x equal to del n by del y. Del m by del x equal to del n by del y. ठीक है, del n by del y. So it should be exact, and it is exact. पहले तो ये तो foundation है. This is the method, but this is the foundation. Foundation is कि when you have m dx plus n dy equal to 0, and this left hand side is exact differential of some function u. When m dx plus n dy can be written as du, then that is exact differential equation. ठीक है, अच्छा, one of the way of solution is u equal to constant. अरे why? Dear, if differential of a term is 0, तो differential of a constant is 0, na? Okay. If differential of some term is 0, that term is constant. I can say x square plus y square by 2 equal to constant. The solution is u equal to constant. That is simple, na? Okay, that is simple, na? Okay. Now let's come to this example. Okay, here del m by del x. What is x here? What is m here? M is the coefficient of x. ये ध्यान रखना. M is the coefficient of x. This should be m and this should be n. m dx वो mismatch नहीं होना चाहिए. Okay, so del m by del x is del y by del x, but partial derivative operator है. In the partial derivative, y is constant with x, so this is 0. Similarly, del n by del y, dear. What is del n by del y? That will be del by del y of the n, and n is x here. Partial derivative with y of x, that is also 0. So hence I can say that del m by del y is equal to del n by del x. Okay. Oh sorry, मैंने उल्टा लिख दिया. del m by del x is del n by del y. जो कैलकुलेट किया वही del m by my god, ये मैंने पूरा ही, sorry, I think in the hurry burry I made a hassle. It is del m by del y. In the del m by del y, it is the del m by del y. Sorry. ठीक है. The end moment glitches. Okay. Del m by del y, but yeah, still answer will match. Sorry, है ना? These are some end moment glitches, I think. Looks like now I am tired. Maybe looks like sometimes happens, yeah. Not exactly tired, but ठीक है, थोड़ा बहुत हो जाता है. Okay, so now del m by del y. Okay, del m by del y of m is equal to x. Differentiation of x with y in the partial notation, it is 0. Okay, it is 0. Okay, now del n by del x. Del n by del x. Del by del x of n. Okay, so this is m, this is n. Okay, so del y by del x, that is 0. Ultimately, they match. Del m by del y should be del n by del x. Okay? So yeah, there was a slight confusion, but now that is okay. That means the differential equation is exact, and already proved it was exact. Okay? Now come here. Okay, m dx plus, this is m dx and this is n dy. Now let me start. Del m by del y. Okay, that is known as del by del y of the m. What is m is y. Del y by del y 1 हुआ. Now del n by del x निकालना है. What is del n by del x? Del by del x of n. Okay, n का value है x and this is again 1. Del x by del x. So dear, I can see that del m by del y will be del. ठीक है, it is du. Okay. It is du. It is exact. Already we proved it is exact because when m dx plus n dy combine into a single differential, it is exact. ये हो गया basics. This is the method. Now, in this third case, we were trying to say that. In this third case, we are trying to say that. Okay, whether it is exact or not. ये confusion है ना? Whether it is exact or not. Okay, we can arrange it like this. Okay, I think it is not exact. Whatever intuition says, guess करके ये समझ में आ रहा है कि exact नहीं है. Intuition says it is non-exact. But let us try ना. Minus y dx plus x dy is 0. Minus y dx plus x dy equal to the 0. Okay, minus y dx. So this becomes m and this becomes n. And now let me try del m by del y. Del by del y of minus y. So it is going to be minus 1. Del by del x of n. And what is n? What is the value of n? N is x. Del x by del x is 1. This is clearly not equal. Here del m by del y does not equal. There is an opposite sign. There is a sign difference. So hence this equation is non-exact. Hence this equation is non-exact. Hence this equation is non-exact. Acha, ab dekho. If the equation is exact, okay, one of the foundation theory says that if the differential is exact, you can write m dx plus n dy equal to du and u equal to constant is the solution. Sometimes equation may be exact. By this method, del m by del y equal to del n by del x, it may be exact, but differentiation may be complicated type of differentiation. You may not be, on your own, you may not be able to write m dx plus n dy equal to du. If you are not able to write like this, then how the solution you can write? U equal to constant, agar u nahi nikal paye, to how the solution maybe you can write? How the solution you can write? Dekhna isko. Then the general solution is given by, okay, then the general solution, if you don't want to express in terms of u, okay, then the general solution is given by integral m dx plus integral terms of n not containing x dy. So when you are integrating m, y is constant. Okay, then integral terms of n not containing x dy equal to constant. Yes, this is useful. I told you vector calculus mein this portion is useful. Okay, terms of n not containing x dy equal to constant. Okay, terms of n not containing x. What is this meaning? वो भी समझ लेंगे. But यहाँ पे आते हैं एक बार. Okay, now there is a twist in this story. This is non-exact. चलो, non-exact. Proved it is non-exact. Okay, proved it is non-exact. Multiply this equation. सबसे पहले मैंने x को constant रखा है. Multiply by 1 by x square. Multiply it by 1 by x square. Multiply by 1 by x square. Then what is the equation you are going to get? You get now x dy minus y dx upon x square equal to 0. देखो now denominator को count करके चले. Denominator x square. Okay, denominator constant, differentiation of numerator minus numerator constant, differentiation of denominator. This is very clearly now d of this is the differentiation division rule with y by x. Okay, now you have converted this into the form of du equal to 0. That means it should be exact. If it is convertible to a single differential term, it is exact. Right? It is exact. It is exact. Acha, proof bhi kar lete. Okay, so now what is m? Okay, first I have to calculate del m by del y. Na? So what is m? देखो हमेशा याद रखना, m is the coefficient of x minus y by x square. Please take a note that it is the coefficient of x minus y by x square, m dx. Okay, so when you are differentiating with y, x constant hai, so it is minus 1 by x square. Now what is del n by del x? That is del by del x. Del by del x of n with dy, and 1 upon x square is 1 upon x basically. What is the differentiation of 1 upon x? Everybody knows. What is the differentiation of 1 upon x? It is known as minus 1 by x square. Okay, so that means del m by del y should be equal to the del n by del x. Is it equal? Yes. That is why it is exact ना. पहले proof किया exact है, पहले foundation से बताया exact है. तो 100% this should match ना, and it is matching up now. It is not matching up earlier. It is matching up now. Now what does it mean? There was a non-exact equation. There is a non-exact equation, and what I have done with that non-exact equation, listen to me. There was a non-exact equation, and I have multiplied it by some factor. That is 1 upon x square. I have multiplied it by 1 upon x square. That non-exact equation converted to an exact equation. Any multiplication factor which converts non-exact into exact, is known as the IF. There was a IF, we was using linear. Na, pehle maine linear cover kiya, so that is important. I intentionally tried linear differential equation first order because that is very important. This is not important much. This is not much important. ठीक है? That IF, ये concept है IF का. What is that IF? Integrating factor is a factor which when multiplied by a non-exact equation converts it into an exact differential equation. Converts into an exact differential equation. So next what you should know is the integrating factor. Okay, a multiplication factor which turns a non-exact equation into an exact equation. So non-exact can be convertible, okay, to exact. Okay, thank you Bhanu, thank you for your love. Okay, so non-exact converted into an exact differential equation, then that is known as the integrating factor. Such a factor will be known as what? Integrating factor. Now there are some cases of integrating factor. Okay, out of which one of them is important. Okay, not honestly all, but yeah, I'll tell you all. Rules for IF, again not important. Okay, not that important, but yeah, agar question aata hai to straight formula hai, but I will tell you. Okay, it's not that important. Okay, but since exact start kiya hai, to no harm in seeing the formulas for IF. If it is a homogeneous equation, then the IF. Now we know what is homogeneous equation. Numerator, denominator. Okay, both of the same degree. Both should be homogeneous of same degree. Homogeneous पढ़ के आए हैं. Okay, but they specially ask the IF for it. Then IF is given by 1 upon mx plus ny if the equation is in the form of mdx plus ndy. ठीक है, mdx plus ndy. If there is an equation of the form f1xy y dx plus f2xy x dy, f1 and f2 are functions of x and y only. F1 and F2 are functions of x and y only. इसका एग्जांपल मैं यहीं बता देता हूँ. देखो homogeneous तो already discussed, okay? Homogeneous already discussed. इसका एग्जांपल मैं बताता हूँ. What is function of xy? Any function in which xy will come together only. For example, एक एग्जांपल लिखता हूँ. Suppose let me write down 1 plus xy into y dx plus next मैंने लिखा 1 minus xy into x dy. So please see that this is known as f1, which is a function of xy. Agar function of xy means wherever xy, it will be together. Wherever xy, it will be together. Okay. And this is known as the function f2. Wherever xy, it is together. Like 1 minus x is a function of x. This is 1 minus xy, function of xy. This is f1, f2. Okay, and then if the differential equation is of this format, f1 xy y dx plus f2 xy x dy, then IF is given by 1 upon mx minus ny. Okay, provided denominator non-zero. Okay, denominator non-zero. So what is the IF here? Chalo, isko calculate bhi kar le. So IF will be given by 1 upon mx. Okay, what is the m? This whole part will be the m dx. This whole part will be the m. So what is m? 1 plus xy, okay, into y. This is m, then multiplied by x, minus, okay, minus n. Now what is n? N means 1 minus xy into x, then multiplied by y. Dhyan rakhna, this part is known as the m, this part is known as the n. mx minus ny kiya then. So continuing the calculation, if for this equation will be 1 upon, open karenge. So it will be xy plus x square y square, okay, minus xy. You again minus xy, minus minus plus x square y square. Clear? xy and minus minus plus. So xy cancelled, but x square y square is available. Okay, so 1 upon 2x square y square. 1 upon 2x square y square. हाँ Ankit, not exactly, but हाँ ठीक है. For the same reason, you can say at least you have your notes complete. Na? See, when I say not important means practice less there, but at least it is there in your knowledge. We have covered up the rules for IF. So what is the IF for this? 1 upon 2x square y square. 1 upon 2x square y square. Okay, that is the integrating factor corresponding to it. That is the integrating factor. Rule number 3. Now, if del m by del y, example समझाता हूं मैं. If del m by del y minus del n by del x, see, if it is an exact equation, then what I have told you, del m by del y equal to del n by del x, and when you are subtracting, it becomes 0. When you are subtracting, it becomes 0. ठीक है? तो del m by del y minus del n by del x upon n. ठीक है? Upon n. Okay, when you solve it, and suppose it is a function of x only. Suppose it is a function of x only. Okay, that is fx. Okay, that is fx. Okay, suppose that is a function of x, then if will be given by e power integral fx dx. This one is especially the important one. Third case is the only important. Achha, on the other hand, del m by del y minus del n by del x divided by minus m. Okay, suppose you solve and you get a function of y only, then the if is e power integral fy dy. Okay, e power fy dy. Okay, e power fy dy. ठीक है, अरे ये तो हो गया था. So now, अच्छा, before I take a question here, I will give you one more important point. Before we take a question here, na, take this. ये जो किया था हमने, I'll give you a hint. We were talking about LDE first order. उसके लिए integrating factor निकाला था. Guys, you can rearrange. Okay, but you know this integrating factor e power integral p dx. This is solvable by IF rule number 3. This is related with IF rule number 3. We need not derive it, but just I am giving you hint. It is solvable by IF rule number 3. You can try out later on. It is solvable by the IF rule number 3. IF rule number 3. ठीक है? ठीक है? IF rule number 3. That comes from the IF rule number 3. You rearrange the equation as m dx plus n dy, you will get the answer. You will get the answer. ठीक है? So let's come back to the IF rule number 3 basically. Let us come back to the IF rule number 3. So rule number 3, when del m by del y minus del n by del x upon n is completely a function of x, मतलब y eliminate हो जाना चाहिए, then only the rule 3 applicable. Example देखेंगे यहाँ पे. Okay, xy square minus e power 1 by x cube dx minus x square y dy equal to the 0. Okay, this is what is your m and this is what is your n. Okay, what is del m by del x? First of all, what is del m by, del m by del y? Differentiation with y for m. So del by del y of xy square minus e की power 1 by x cube. So when you differentiate with y, okay, x to constant है, y square का derivative 2y. So it is 2xy, but differentiation of this term will be 0, na, because you are differentiating with y. So you are only left with 2xy. Acha. Del n by del x. Differentiation of n with x. But what is the n? Minus x square y. Minus x square y. X square का derivative 2x. Okay, so this is 2xy. Are they equal? Very clearly, del m by del y does not equal to the del n by del x. So this differential equation is non-exact. ये तो clear हो गया. This is a non-exact differential equation. Non-exact differential equation. Can I convert it to exact differential equation? Let us check. Let us check. Okay, now please listen to this step. Please listen to this step. ठीक है? देखो, it is definitely not homogeneous. Okay, homogeneous होता तो exponential. Homogeneous means all terms are polynomial of the same degree. This is non-homogeneous. Then is it the xy case? Okay, it is the xy case. No, this is not a function of xy. This is a function of x only. Case number 2 was there should be xy separate function. Case number 2 bhi nahi hai. That is why I start with the case number 3 now. And case number 3 says that, dekho, del m by del y not equal to del n by del x, so subtract. Del m by del y minus del n by del x is equal to how much? Now divide by n ya m, wo dekha jayega. But it is equal to how much? Del m by del y, that is 2xy. Del n by del x, that is minus 2xy. This is 2 2s are 4 ho gaya. This is 4xy. Now what I should divide with? देखो, अगर आपने m से divide किया, m has an exponential term. If you divide 4xy upon this, nothing can be cancelled. When you divide, you should either get a function of x या function of y. कुछ ऐसा चाहिए था ना? So if you divide by this, there is an exponential term. Nothing. It cannot cancel with anything. No result will be obtained. But if you divide by n, so definitely y cancelled out. Divide by n, y cancelled out. So इस तरीके से try कीजिए. So now if I divide by n, okay. Now if I divide by n, ये रहा n was x square y, तो y cancelled, x भी एक बार cancel हुआ. I have only a function of x. Rule number 3 आ गया. Okay, I have only a function of x. So rule number 3 of IF can be applied. When del m by del y minus del n by del x divide by n, okay, is only a function of x, rule number 4 is applicable. Now what is the IF? IF is then given by e raised to the power integral of the function of x. Whatever is the function of x, e raised to the power 4 by x dx. ठीक है? तो e raised to the power 4 outside 1 upon x का integral ln x. 1 upon x का integral ln x. ठीक है? तो 4 send inside so that e and log सामने सामने आ जाएंगे. E and log cancel and the integrating factor is x power 4. Question can only be integrating factor x power 4. Most likely itna question hoga because complete solution will be lengthy. But let me tell you the complete solution here. Okay, the integrating factor is x power 4. But agar complete solution chahiye, so I have to use the solution formula for exact differential equation. Dhyan dena. Even the smart board is very tired. You know, to change the slide it is taking time. Honestly, itna nahi lagta hai. That means smart board is also very tired now. Very tired. देखना यहाँ पे. If it is exact na, then you can use this answer. Integral m dx y constant plus terms of n not containing x dy equal to constant. If it is exact. अब देखो. When I took the question, I proved that it is non-exact. ठीक है. I proved that it is non-exact. But what is the meaning of IF? What is the role of IF? When you multiply non-exact by IF, you get an exact equation. So what can be my next step? Okay, when you have a non-exact equation, non-exact differential equation, whenever you multiply by IF, the resultant that you get 100% exact. Otherwise, IF का कोई role ही नहीं हुआ ना. Okay, so what I'm going to do is now, my IF is x power 4 to be multiplied by the original equation. Okay, what is that original equation? Xy square minus e power 1 by x cube. Xy square minus e raised to the power 1 by x cube multiplied by dx minus x square y dy. Okay, equal to 0. Multiply both the sides, but right side to 0 here, na? Okay, even if you multiply both the sides, it's not affected. Ab dekho, multiply throughout. So first term is x power 4 into xy square minus e raised to the power 1 by x cube into dx. Correct. Minus, here, IF was x power 4 kya? Just a second, I doubt. Del m by del y minus del n by del x upon n. Oh ho. Correct, Jisk. That's what. This is minus x square y. वो मेरे को solve करते समझ में आया, otherwise तो complicate हो रहा है. Okay, so this is minus 4 by x. That means the IF is the fx is minus 4 by x. ठीक है, minus 4 by x. Minus 4 log x. 1 upon x integrals remains to be same. So the power will become how much? X की power minus 4. So what is my IF? My IF is x की power minus 4, या known as 1 upon x power 4. My IF is 1 upon x power 4. So accordingly I will multiply here. Accordingly, I will multiply here 1 upon x power 4, 1 upon x power 4. Just guys, allow me a second. Yeah, sorry. Okay, so it is 1 upon x power 4, clearly taken. Now multiply inside. Okay, right side to anyway 0 rahega. Xy square minus e power 1 by x cube divided by x power 4 dx. Okay, the next term is x square x power 4 thoda bahut cancel hoga, so I have minus y by x square dy. Okay, equal to the 0. Okay. Now guys, it is your choice. You want to check del m by del y equal to del n by del x. I am telling you 100% true hoga. Your choice, you want to check, you check it out. Why? Because non-exact into IF should be 100% exact. Otherwise, this should not be the IF, na? Okay, so but if you want, you try later on. M aa gaya, n aa gaya. Now del m by del y, del n by del x will be equal 100%. But not required. Not required. Okay. Chalo, now what is the solution then? What is the solution? I told you solution. Integral m dx. When you are integrating m dx, y equal to some constant, any constant, plus terms of n not containing x. Terms of n not containing x. यही बोला था ना, not containing x dy. Okay, this is equal to constant. That is what is the solution I told you, correct? Integral m dx. This is what it is. Yeah, have a look into it once again. Integral m dx plus terms of n not containing x. So I will explain this not containing x dy equal to the constant. अब आ जाते हैं यहाँ पे. Okay, integral m dx. तो m तो as it is पूरा लेना है. All terms of m. Okay, all terms of m, and this is m. xy square minus e raised to the power 1 by x cube divided by x power 4 dx plus terms of n not containing x. Terms of n not containing x. So dekho, this is n, which there is only one term y by x square and that contains x. Listen to me carefully. There is only one term y by x square and that is containing x. That is containing x. So what are the terms of n not containing x? Nil. Nil. You cannot write anything. Terms of n which do not contain x. Okay. Suppose if it was like this. Y plus x upon y. So this is a term containing x. This is independent of x. So that you can include. Got it? That you can include. But here there is only one term. Okay. And that somehow contains x. Kisi bhi form mein x hai. There is only one term in n. Somehow x is there. You cannot include it. Means nothing is there in n. So second integration not required. Okay, so we have to just focus on the first integration. Okay, उसमें भी divide कर देंगे. तो first part is y square upon x cube. Okay, one of the x cancelled, dx. Second one, little you have to substitute and then solve the integral. E power 1 by x cube upon x power 4 dx. Okay, equal to constant. ये तो 0 हो गया. ठीक है. Now, there will be one substitution to solve the second one. And what is that substitution? If it is 1 upon x cube, its derivative 1 upon x power 4 available. Okay, so if you have 1 upon x cube, if you put it as t, okay, then differentiate minus 3 upon x power 4 dx. ये minus 3 आता है, okay. Minus 3 upon x power 4 dx will be equal to the dt. Will be equal to the dt. Correct. So, now what is going to be the answer? Let me take one more slide. I have, in the first term, y is constant. Okay, in the first term, y is constant. So, dekho dear. Y square, integral of first term, keeping y equal to constant. Y equal to constant. Okay. Now, okay, y square constant is outside the integral. 1 upon x cube integral. 1 upon x cube integral. Okay, x power minus 3 integral. X power minus 2 upon 2. X power n plus 1 upon n plus 1. X power minus 2 by 2. I treat it as x power minus 3. Minus, now in the second integral, e power 1 upon x cube. 1 upon x cube मैंने ले लिया t. So I have e power t. dx upon x power 4. dx upon x power 4. Minus भी adjust हो जाएगा. dx upon x power 4 will be minus dt by 3. Correct? Will be minus dt by 3. Okay, right side में constant चल रहा है. Okay. ठीक है. So now this is equal to ये x power minus 2 वापस नीचे भेजेंगे So I have minus 1 by 2 y square by x square. Next is, ठीक है, ये माइनस माइनस प्लस, तो ओनली 1/3 इंटीग्रल e पावर t प्लस हो गया 1/3 e पावर t इंटीग्रल इज e पावर t, दैट इज सिंपल. Okay, and this is equal to constant. What is t? Put back the value of t. Okay, so your final answer here. Okay, minus y square upon 2x square plus 1/3 e raised to the power t, where t was 1 upon x cube, equal to c. That is the solution of the differential equation. Okay, now what I told you, going for the solution will be lengthy for exact differential equation. This is helpful, you need to know for upcoming topics, for upcoming subjects. But इस पे direct question, trust me, that is why I clearly told you, less important direct question. But just एक illustration कर दिया कि by chance you need somewhere, you are able to solve. हाँ, maybe up to IF it is okay. Maybe up to IF it is simple, you can calculate. So there are 4 rules of IF. Okay, there are 4 rules of IF. ठीक है, that you can go through. ठीक है. Now we are done with the linear differential equation first order, वो तो कर ही लिया था. Let's move ahead. After the exact differential equation, linear. What is linear? Okay, and all that explained. The definition of linear equation. The IF is coming from rule 3. वो hint भी दे दिया. The IF that is coming here is as per the rule number 3. ठीक है. Now then, some questions solved on exact differential. Sorry, on the linear differential equation first order. Equations are reducible to linear differential equations. Okay. A special case of the reducible form is the Bernoulli's also. Okay, Bernoulli's वाला important है. थोड़ा सा mark कर देता हूँ मैं. Actually, LD linear differential equation itself is very important, whether first order or higher order. तो Bernoulli's हमने देखा. Okay, Bernoulli's were also simple, but that is easy. मतलब that is important. तो ये Bernoulli's हमने देखा. Completely solved the Bernoulli's equation also. Now the next major thing you have to start is the linear constant coefficient differential equation. LCCDE. LCCDE. LCCD. ठीक है, अब इसको कल कवर करेंगे. This is most important. Okay, because okay, you will have the case of CF and PI here. It is solved by the method of CF and PI, and most important. Differential equation, most important segment. Okay, you can get the question only of CF, only on PI, yeah, maybe CF plus PI. Okay, maybe CF plus PI. Okay, so it's almost approximately मान ले 10 hours. Okay, it's approximately 10 hours. We started around 10 a.m. and it's going to be 8 p.m. approximately 10 hours done. Let's continue tomorrow. Okay, with the same motivation. Let me see how many of you ready for tomorrow. Let me tell you how many of you ready for tomorrow. Yes. Let me see how many ready tomorrow. Put the attendance now. मुझे आज से ही पता चल जाएगा कि how many of you are really ready for tomorrow. Tomorrow 10 a.m. Okay, tomorrow 10 a.m. Okay, it is Maxima, Vineet. It is Maxima. Once again, those who want the password, it is Maxima. मैंने बात एक बार और बताऊंगा, एक बार और जान लीजिए. Maxima. Okay, how many of you are ready? That should be seen in the attendance for tomorrow. Okay, the like buttons for tomorrow, that should be reflected. Everything is going so slow right now. Everything is tired. Everything is tired. Well, honestly, I could have continued a little bit more, but now I feel, okay, कि, you know, let me also give a little bit break here so that tomorrow, कल कितना भी खींच सकते हैं, but tomorrow I have to be ready with this. Tomorrow I have to be ready with this complete clear throat. Tomorrow will, because tomorrow is the day 2, we can extend even more if possible. But today also, guys, great effort. Hats off to you also, those who are there since morning, because it is almost 10 hours going to complete. Almost 10 hours going to complete. But the 45 is the only attendance for tomorrow, yaar. How will we start with the 45? How we will start with the 45? Maza nahi aa raha, yaar. Maza nahi aa raha. With the 45 likes only on tomorrow. ठीक है, PDF on the Telegram. चलो, yeah, let me share the Telegram. Come on, guys. Where is the attendance for tomorrow? ये लीजिए. Guys, PDF in the Telegram link. Okay, link I have shared. Okay, ठीक है. PDF for today, I will try to share tonight only. Okay, I'll try to share tonight only, provided my energy is there, because first I will finalize some contents for tomorrow. tomorrow 10 a.m. अच्छा अब ये बताता हूं मैं आपको. There are some things important that I should tell you. There are some things important that I should tell you, dear. First of all, okay, ये कल कवर करेंगे, but we are not starting with this. Okay, please remember, ये कल कवर करेंगे, but we are not going to start with this. We are not going to start with this. Okay, okay. Tomorrow, part 2 at 10 a.m. Tomorrow, part 2 at 10 a.m. Okay, we start with. I already told you. Probability distributions और इंटीग्रल कैलकुलस. किसी में से एक देखते हैं किसका मूड बना. Anyone I will pick up. Okay, but something common where CS students can also come. Okay, tomorrow many topics are there. Probability, integral, multiple integral, vector calculus, remaining differential equation, numerical methods, multiple topics are there. But which to start, we'll see in the beginning. But any of these two is going to be the starting topic. Okay, ji, chalo, bye. See you tomorrow at 10 a.m. Okay, with the same energy. Okay, do not forget to miss it. And that is why, okay, put the reminder for the tomorrow session. Okay, bye. Good night. Thank you. Stay safe and take care of yourself. Okay, take care of yourself. Can it be 600 likes? I don't know what is the status right now. एक बार मैं check करता हूँ. चलो, anyways, whatever it is, yes. Okay, I don't want to check right now. But yeah, do not forget, okay, to join tomorrow. Okay, and yes, in case you have not liked the today's session, okay, complete 10 hours. Hats off to your energy and like it on your name because it's been 10 hours. It's been almost 10 hours. See you tomorrow at 10 a.m. again. Okay, at 10 a.m. once again.